In the last decade, we have seen the rise of cloud computing and how it has taken the technical world by storm. Thus, we see many companies wanting to move their business to cloud and many individuals wanting to make a career in this domain. That is why we see that many cloud service providers coming up and providing wonderful cloud computing services to many organizations and many people. So one such cloud service provider is Google Cloud Platform, which is also the home to popular services like YouTube and Google search engine. Hello all, I welcome you all to this session by Edureka, where we are going to discuss Google Cloud Platform in detail. So without any further ado, let's take a look at today's agenda. So in the first module, we are going to have an introduction to Google Cloud Platform, where we will first understand what is cloud computing, then what is Google Cloud Platform, and finally why one should go for Google Cloud Platform. So in the second module, we are going to see the differences between the major cloud service providers. So the three major cloud service providers are AWS, Azure and GCP, and we will understand the comparison between them. So in the third module, we are going to understand the concepts of Google Cloud Platform. So where we are going to understand the global infrastructure of GCP, and also we are going to have an overview of GCP products and services. Then in the fourth module, which is Google Cloud Compute Engine, we are going to first understand what is infrastructure as a service, and we are also going to have an introduction to features and application of Google Compute Engine. So in the fifth module, which is Google Cloud App Engine, we are going to have an overview of Google App Engine and have an architectural understanding of the App Engine, and also we will implement an app through Google App Engine. Then in module 6, which is Google Cloud Anthos, we are going to have an overview of Google Cloud Anthos, as well as going to understand the features and benefits of Google Cloud Anthos. Then in module 7, which is GCP Networking, we are going to understand what is Google Cloud VPC, that is a virtual private cloud. We will have an overview of GCP networking concepts. Then in the 8th module, which is GCP Database Services, we are going to understand the types of GCP databases and their services. And also we are going to see the deployment techniques of GCP database. Then in module 9, which is Google Bigtable, we are going to have an overview of it. We will understand the architecture and data model of Google Bigtable. Then in the 10th module, which is Google BigQuery, we are going to have an overview of Google BigQuery, and we will also go through the BigQuery architecture and explanation of BigQuery storage. Then in the module 11, which is Google Kubernetes Engine, we will have an overview of Google Kubernetes Engine, and also we will be deploying a containerized web app on GCP. Then in the module 12, which is GCP Terraform, we are going to have an overview of Terraform, and we will also look at the tools for Terraform in GCP and also the support provided by Terraform for GCP. Then in module 13, which is GCP Security Services, we are going to have an understanding of Cloud Security Command Center and also the Cloud Armor. Then module 14, which is GCP Identity and Access Management Service, we are going to understand the working concepts of Google Cloud Platform Identity and Access Management and also the security enforcement through IAM. Then module 15, which is Google Cloud AI Platform, we are going to understand the AI building blocks in Google Cloud Platform and also the AI solutions in Google Cloud Platform. Then in module 16, which is Billing in GCP, we are going to understand the billing accounts and payments profile in GCP and also the charging cycle and billing context done in Google Cloud Platform. Then in module 17, which is GCP Best Practices, we are going to see the best practices for different products and services in Google Cloud Platform. Then in module 18, which is Google Cloud Certification, we are going to understand the different types of Google Cloud Certification and also the major role-based certifications. Then in module 19, which is how to become a Google Cloud Architect, we are going to understand the GCP Architect career growth, jobs, salary and future scope. We will also understand the roles and responsibilities of a GCP Architect as well as how to crack a GCP Architect exam. Then finally, in the module 20, which is GCP Interview Questions, we will understand GCP Interview Questions and answers and also the skills required to become a cloud engineer. With this, I come to the end of my agenda. Before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you are interested in online training certification in Google Cloud Platform, check out the link given in the description box below. What is cloud computing? Well, cloud computing is the on-demand availability of computer system resources like storage, databases, networking, software, and many more. And guess what?
All of these resources are provided over the internet. Now you might be guessing why people opt for cloud computing, right? Well, you see, cloud computing offers faster innovation and flexible resources. And the best part is, you typically pay only for the services you use. This in turn helps in lowering your operating costs and thus ensuring your infrastructure runs more efficiently. Now you might be wondering how many cloud service providers are there, right? Well, this come to you by surprise. There aren't a few, but a lot of them. Some of the major cloud service providers in the market are Amazon's AWS, which is known as Amazon Web Services, with a market share of 31%. That is the largest market share of any cloud service provider. Second is Microsoft Azure with the market share of 20%, and third is Google Cloud Platform with a market share of 7%. But if you see in the last 3 years, Google Cloud Platform has the highest growth in the market, which is of 58%. You can also see some other popular cloud service providers here, like Alibaba Cloud, which is a Chinese cloud computing company and a subsidiary of Alibaba Group. It is the largest cloud computing company in China. Similarly, there are many others like Huawei, IBM, and a lot of them like VMware and Phoenix Snap. Now that you know what is cloud computing, let's take a look at some of its popular applications. So first we see cloud for IoT, which is a massive network that supports IoT devices and applications that includes the infrastructure, servers, and storage needed for real-time operations and processing. An IoT cloud also includes the services and standards necessary for connecting, managing, and securing different IoT devices and applications. Moving on to cloud for machine learning, artificial intelligence and machine learning are steadily making their way into enterprise applications in areas such as customer support, fraud detection, and business intelligence. So there is every reason to believe that much of it will happen in the cloud. The top cloud computing platforms are betting big on democratizing artificial intelligence. Over the past 3 years, Amazon, Google, and Microsoft have made significant investments in artificial intelligence and machine learning, from rolling out new services to carrying out major reorganizations that place AI strategically in their organizational structure. Like Google CEO Sundar Pichai has even said that his company is shifting to an AI first world. Now let's see the next application, that is disaster recovery. As we all know that data is the most valuable asset of modern day organizations, so its loss can result in irreversible damage to your businesses, including the loss of productivity, revenue, reputation, and even the customers. It is hard to predict when a disaster will occur and how serious its impact will be. So, what disaster recovery in cloud computing does is it demands strong critical data and applications in cloud storage and failing over to a secondary site in case of a disaster. Cloud computing services be accessed from anywhere at any time. Backup and disaster recovery in cloud computing can be automated, requiring minimum input on your part. So now let's move ahead to understand thoroughly what is Google Cloud Platform. Offered by Google, it is a suite of cloud computing services that runs on same infrastructure that Google uses internally for its end user products, such as Google Search, Gmail, file storage, and YouTube. Along with a set of management tools, it provides a series of modular cloud services including computing, data storage, data analytics, and machine learning. For organizations with large amounts of data to store or analyze, Google Cloud Storage prices are up to 20% cheaper than AWS, and the price of database services also compares favorably. While there is no difference in the price of container services, Google Cloud is an industry leader in the field and is also investing heavily in AI and machine learning technologies. Many small and large enterprises are increasingly adopting Google Cloud Platform since it engages things and makes them more secure at reasonable costs. So now let's move on to understand why we should prefer Google Cloud Platform. So now that you have a brief idea of what is cloud computing is and what is Google Cloud Platform, let's understand why one must go for Google Cloud Platform. We all know how big is the database of Gmail, YouTube, and Google Search is. And I don't think in recent years Google server has gone down. It's actually one of the biggest in the world. So it seems an obvious choice to trust them, right? So now let's take a look at some of its features of Google Cloud Platform, what really gives it an upper hand over other vendors. So first one is it has a better pricing than its competitors. It is highly scalable and it uses auto scaling to automatically adjust the sum of virtual machine instances that are hosting your application. So what it does is it allows your application to adapt to different varying amounts of traffic. Now, if you see the third one with custom machine types, you can create compute engine virtual machines with optimal amounts of virtual CPU and memory. Now, coming to Google Cloud's IoT Core, which is a fully managed service to easily and securely connect, manage, and ingest data from globally dispersed devices. Google Cloud APIs, if you see, like they allow you to automate your workflows by using your favorite language. So this Google Cloud API ecosystem consists of compute API, storage API, big data analytics API, networking API, and several others. Now moving on to the sixth one, it is like big data analytics. So Google Cloud Smart Analytics solutions are fully managed. This multi-cloud analytics platform empowers everyone to get insights while eliminating constraints of scale, performance, and cost. Big data analytics use real-time insights and data apps to drive decisions and innovation. With Cloud AI, GCP Cloud Functions is the easiest way to run your code in the cloud. So moving on to the last one, that is serverless, Google Cloud Platform is highly available and fault tolerant. Let's now look at some popular advantages of Google Cloud Platform. So first one is like customers gets a higher uptime and reliability. If a data center is not available for some reason, the system immediately falls back onto the secondary center without any service interruption being visible to users. Moving on to the next one, economic pricing. So Google's economies of scale let customers spend less. So it works in a way like Google minimizes overheads and consolidates a small number of server configurations. It manages these through an efficient ratio of people to computers. Now, moving on to the last popular advantage, that is, of course, the higher security. So, Google's investments in security to protect customers. So, customer benefit from process-based and physical security investments made by Google. So, Google hires leading security experts. That's how Google provide a higher security to its customers. So, let's take a quick demo now on Google Cloud Platform. Okay, so just simply go to Google Cloud Platform. What you can do is you can just directly go to the console. If you don't have an account on Google Cloud Platform, then create one because it's a good platform to have your account on. And it will ask for your credit and debit card details while creating the account just for the verification purpose only. Let me first introduce you to the platform that the Google has to offer to us. Okay. Before that, remember one thing, like Google Cloud Platform provides you like a free trial for like 90 days. Okay. And it has certain limitations also, but if you like need the complete package and need complete access, then you can like go for a paid version also. So that's how it starts. This is how interface looks like. You can see there's a project information is here. Like when you create the account, there will always be a inbuilt project will be there. But you can like go here to my first project, and here you can like go to new project, and you can create a new project with whatever name you want to give. Okay. Now coming to the dashboard. So I have like explained you previously, right? Products and services. So here are like products and services provided as of networking and of storage and of compute. Okay. So let's see how to create an instance in Google Cloud Platform. So just go to compute engine and you can go to VM instances. It will take a little time. Okay. So you can create an instance from here. You can like name your instance, whatever name you want to give to the instance. Okay. Then you can fill in the details. If you want to do some customization, you can do from here, and you can then just go as per your requirement, create it. So the instance will be created. It will take a little time, but it will be created. So the instance is being created. So remember one thing, like as I've told you, like I have a free trial, so it has a little limitation, right? So here limitation is that I cannot create an instance for Windows from here. Okay, I have a like Windows OS, so for Linux OS only, that's the limitation. So get it for the complete access for Windows also, so you can go for a paid version. Okay, so right now I'm just deleting this. You can just go here and delete the instance. I'm not able to launch it here. We can go to some other service and we can use that service of Google Cloud Platform, not if not the instance thing. We can go for the other one. First it gets deleted, let it get deleted. Takes a little time. So you can just go out of compute engine. We can use the service of a storage. Okay. Like we can store files or whatever kind of files you want to store, we can use the storage for that. Okay, cloud storage. So yeah, remember I have like explained you about storage. There is this a bucket system in cloud storage. If you remember, like we have the drives in our laptop, right? That we have folders and we can store files in that. Similarly, here is the bucket system. So you can create a bucket from here. And remember that while naming the bucket, its name should be globally unique. Okay, if like there's a similar name of any bucket is there, like anywhere in the world, they have created with the same name, then you can't create that. Okay, use some unique word for that. Okay, like I'm using here bucket 6622. Okay, continue. So you can see like there is no bucket name 6622. here you can like choose the accessibility for it if you want to access for multi-region, dual region, or single region. So here I am choosing single region, and then I will just create it. It takes a little time. Yeah. Okay, done. So remember that here you can like create folder, upload folder, just like your hard drives. Okay, or you can upload files. So let's upload a file. So this is like an exe file, this is an image file, whichever file you want to upload, you can upload. So yeah, let's upload a exe file here. And any kind of file like video file or any CSV file, txt file, whatever kind of file, you can upload any kind of file here. Okay, yeah, so it got uploaded. And remember that this is the life cycle thing. Okay, so what you can do is retention, permissions, everything is there. So in life cycle, what you can do is while you are storing a file or anything, any kind of file, but you feel like you want to delete it after 15 days or 30 days or any kind of days, any number of days, so you can go to life cycle and you can like choose its time period. Okay, so what happens is if you forget like you want to delete it, it will automatically get deleted after some days. If you're given for 30 days or 15 days, it will automatically get deleted. In also you can delete it from here, like you can select it and you can delete it from here, or also you can download it if you want to download. Whenever you want to download, you can download it from the download option. Now we are deleting it, so yeah, it's permanent action, so it's permanently got deleted. Okay, also if you want to like delete the bucket also, you can just go back here, the bucket section we can go, all the buckets are given. So here we have created this bucket, we can just go select this and delete it. All you have to do is just type delete here, just delete it. Okay, I hope you have understood this now.
Now let us move on and compare these three cloud service providers. Let us first compare them based on the market trends and growth rate. Now, according to Statista, AWS owns 32% of the total cloud market share. Amazon reported that Amazon Web Services revenue was $13.5 billion in the first quarter of 2021, which actually exceeded the analyst prediction of $13.1 billion. Now, when you compare this to the first quarter revenue of 2020, which was $10.33 billion, we can see AWS revenue grew more than 30% in a year. In the first quarter of 2021, AWS revenue accounted for 12% of total Amazon's revenue and nearly 47% of Amazon overall operating income. Amazon CEO Jeff Bezos has said AWS has an unusual advantage of a 7-year head start before facing like-minded competition. As a result, the AWS services are by far the most evolved and most functionality rich. Next, let us take a look at the market trend for Azure. According to Statista, Microsoft Azure owns 20% of the total cloud market share. Now, unlike Amazon, Microsoft only reports the growth rate and not the revenue. It reported 50% revenue growth over the previous quarter, which was better than the 46% growth the analysts expected. In 2020, Microsoft reported that its commercial cloud officially hit the 50,000 billion mark for its annual run rate. Next, looking at the market trend for GCP, according to Statista, GCP owns 9% of the total cloud market share. In the first quarter of 2021, Google Cloud reported revenue of $4.0 billion, which was an increase of 46% compared to the previous year. Also, the operational losses were reduced to $974 million this year compared to the losses of $1.73 billion last year. Now, this was the market trend and growth rate of AWS, Azure, and GCP. Now let us move on and compare them based on their availability zones. But before we compare their availability zones, I would like to define what are availability zones and regions. Now a region is a specific geographical location where it can host your resources, and availability zones are distant locations within the region that are engineered to be isolated from failure from the other availability zones. Now talking about the availability zones of AWS, it has the most extensive global cloud infrastructure. Its multiple availability zones are connected by a low latency, high throughput, and highly redundant networking. AWS has 80 availability zones within 25 geographical locations around the world, and has also announced for 15 more availability zones and 5 more regions in Australia, India, Indonesia, Spain, and Switzerland. Now comparing it to the availability zones in Azure. Azure has 60 plus regions, with each region having at least 3 availability zones. Next, coming to GCP availability zones, its global network spans across 25 regions with 76 zones and is available to users from 200 plus countries and territories. GCP has recently announced new regions in Seoul, Salt Lake City, Las Vegas, Jakarta, and Warsaw, and will also expand its networks to 9 more regions. Now, this was about the availability zones. Next, let us see what are the top companies using these cloud service providers. First, talking about AWS, its services are used by top companies like Netflix, Coca-Cola, McDonald's, Unilever, ESPN, and Adobe. Next, coming to Azure, it is used by many Fortune 500 companies. And some of the companies which use Microsoft Azure clouds are Samsung, HP, BMW, FedEx, and Pixar Animated Studio. Moving on to GCP, the top companies who use their services are PayPal, Twitter, 20th Century Fox, P&G, and King Digital Entertainment. Now that we have seen what are the top companies which use these cloud service providers, let us compare them based on the compute services. Compute services are one of the core services when it comes to cloud computing. Compute services helps to create instances of virtual machines in minutes and also scale up instances instantly if needed. So in today's session, we're going to compare these three cloud service providers based on the compute service and storage service. The primary compute service for AWS is Amazon EC2. The primary compute service for Azure is Azure Virtual Machine. And for GCP is Google Compute Engine. Now all the three services are equally powerful but unique in their own way. Each one has its own advantages and disadvantages. Like Amazon EC2 has 99.5% of the annual uptime and can be tailored with variety of options according to users' requirements. On the other hand, Azure Virtual Machines provides enhanced security and hybrid cloud capabilities. But when you compare the cost, Azure instances tend to get costlier as the compute size increases. Next, talking about Google Compute Engine, they're comparatively cheaper, they come with a persistent disk storage and provide consistent performance. Next, talking about the storage services, AWS offers a variety of storage options like S3 for object storage, EBS for block storage, EFS for file storage, and a few other storage services. Next, talking about Azure Cloud Storage, this also includes object, file, disk, queue, and table storage. They also have specialized services for data-rich applications and many data backup services. Now talking about GCP Cloud Storage, they have a fewer storage as compared to the other two, but they are more targeted. For object storage, GCP offers cloud storage. It offers persistent disk for block storage to be used with virtual machine, and file storage for storing the files. For backing up your data, AWS provides a service called as AWS Glacier, and Azure provides a service called as Azure Backup, but Google does not yet have any backup services. Next, let us compare these three cloud service providers according to the pricing. Now, all the three cloud service providers offer a pay-as-you-go structure, which means you only pay for the services you use. Now, pricing would vary for different services. Like for compute services, one cloud service provider could be cheaper, but it could be costlier for database services, and so on. So just to give you a general overview of the pricing, among the three cloud service providers, GCP offers a slightly cheaper pricing model and has a flexible cost control, which allows you to try the different services and features. AWS charges you on an hourly basis, whereas Azure charges you on a per minute basis, and GCP provides per second billing for its resources. When it comes to a short-term subscription plan, Google Cloud and Azure gives you a lot more flexibility. But in certain services, Azure tends to be costlier when the architecture starts scaling up.
How Google Cloud Platform specifically operates globally and what kind of infrastructure it boasts of. So global resources are multi-regional resources is what it has, be it your BigQuery, data store, cloud storage. Then you have your regional resources, right? App Engine instance, and you have your zonal resource like your VM instance and disk. Now, let me explain what these things are, okay? So basically when you talk about an infrastructure, what GCP does is it basically gives you zones, right? And regions. Now, when you talk about your zones are nothing but your servers that you put forth. To give you an example, let's assume that you have a server in a place called as, now I'm an Indian, so my examples could be little Indian, you might have noticed by now. Now, let's assume that Google has its server in Mumbai. Okay, let's assume that. So when you talk about the server being in Mumbai, what it does is, let's assume you are based in India and you want to run your business in India. So if you want to reduce some of the latency issues, or probably you want your data to be close to you, also you want to ensure that your government compliances allow you to run your business, and in that case they want you to run the business in India. So in that case, having a server in India is good, right? So I want to put forth my data on Google Cloud Platform, but I want to put forth that data in India. So if there's a server in Mumbai, in that case, I can put my data in that server, right? So that server here is called as my disk, or basically my server, or my zonal resource. So Mumbai would be a zone for me, right? Now, when you talk about something like your server, that server has to reside in a particular region. Now, in that case, that geographical location is called as your region. Okay. So basically, you'll have your servers and you'll have your regions, and your data would reside in these different geographical locations. Now, these different regions across the globe are connected by low latency network. What that means is you can basically access all this data by using your internet and stay connected to these different regions and different zones. Let's try and understand them a little better. What I'll do is I'll just go ahead and switch into the web page where we can discuss the global infrastructure of Google Cloud Platform, that is. So when you talk about the Google's infrastructure, right, you can see some information here while it loads. It says that it spans in 22 regions, 67 zones, and 140 points of presence. It has 96 CDN edge locations. I'll tell you what edge locations are, and that is what it offers. Now, meanwhile, this loads up. Let's quickly see what CDNs are. These are nothing but content delivery network. Now, there's a networking service called as CDN. We'll talk about that. But what it does is, I mentioned the fact that when you talk about these cloud platforms, basically these are globally residing. So let's assume that I put forth my data in India and my business is in India. But there are customers who are accessing this data outside India. So for them to put forth a web request where they search for a particular data, if the server has to come back to India, fetch the information, again send it back to the user, it could take time. What if I have a pseudo server that is close to that particular user, and whenever a user makes a request, a copy of that data is maintained, which is more frequently accessed, right? So anybody who throws in a request to that data, it can be fetched from that server there and there, right? So this location is called as edge location, and the edge location is nothing but something that is provided by your CDN, that is content delivery network. So it is the job of this particular service to ensure that it helps communicate between these various endpointer requirements. Let's see what Start Exploring has to offer to us. There you go. So this has been updated. Last time I checked it, it wasn't like this. But last time when I checked, it was way back. So I think it must be a while that this has changed. So these are the different locations in which you have your data center. So I called about Mumbai, so I don't need to say that suppose in Mumbai. We can be certain that there's a region in Mumbai. Okay. So these are the different global regions where you have your data centers. Okay, dear audience, I'm not sure whether you can hear this music or not. It is the Google Cloud Platform playing this music. So I believe the gist is clear to you people, right? If you click on these icons, you'll get information about how this network is connected, right? And then you can explore it. So what are the CDN POPs, right? So Los Angeles can connect to these networks, right? Or these CDN POPs. So I'm going to close this because it's not good for viewing when the noise comes in. So as you saw on the previous screen, right, that is what the infrastructure of GCP looked like. Okay. So I believe the basic idea is clear to you people. We'll understand these services and these edge locations and all those things would be clear to you. When you talk about AWS and Azure, they too have a similar approach where they have availability zones and regions. Availability zones in their case are nothing but their data centers, and their regions are nothing but their geographical locations. So if Mumbai is a region, they'll have a zonal resource there or an availability zone. So they work on similar platform, and this is how the infrastructure of Google works like, or Google Cloud Platform rather, where you have your zonal resources or availability zones which are put forth in a region, and all these are connected by low latency network for fast data transfer and communication. So this is what the global infrastructure is. Let's now go ahead and discuss some of the other pointers. Now, when I say the other pointers, let's try and understand GCP service domains. Now, when you talk about GCP service domains, there are plenty of service domains that GCP has to offer. The reason for that is there's so many services that GCP offers. Now, each of these are the major domains that GCP operates in. And when I say major domains, all of these domains will have sub-services or services that fall under these domains. Say, for example, when you talk about compute, now there are different compute services which are IaaS in nature, PaaS in nature, even serverless in nature, right? Similarly, you have storages and database. Now, this is where you can store your data, right? When you talk about storage, this is where you store your data in different files, formats, right? And database is something that lets you work with this data. Networking. Now, when you talk about a cloud platform like Google Cloud Platform, what it does is it has its resources that are spawning in different or existing in different parts of the world. Now, assume that you want to host applications, right? So we are not just dealing with computation, storage, database. There could be a number of services that are intertwined. So where is the data coming from? What is the amount in which it is coming? What are the metrics that I need to track? This is something that your management tools tell you. And data transfer is something that lets these applications communicate with each other. So these are some of the core domains when you talk about GCP. Now there are more, but these are the core ones. So if you want to be a good developer, maybe a good architect, and even a good administrator, these are some of the core services that would be core for any GCP exam that you give. So it is important you understand majority of these services. So I believe the overview of these services is clear to you people. Let's now quickly go ahead and take a look at the first domain, that is the compute domain. So these are some of the popular compute services that GCP has to offer. Now there are more than these, but these are the important ones. Let's try and understand them one by one. Now the first on our list is the compute engine, which is more of an IaaS service. Now this is where the service models that we discussed would add more value to your exploration. So when you talk about the compute engine, basically it is an IaaS offering, as I've already mentioned. And what basically you can do is you can launch or spawn your virtual machines. Now, in case if you need a CentOS operating system virtual machine, or basically you need your Linux operating system or Windows operating system, you can basically go ahead and launch those services by a mere click. Okay. So not by a single click, but few clicks is what will let you have those engines up and running. Apart from that, you have your app engine. Now, this is where your platform as a service application comes into picture. I discussed Elastic Beanstalk as well, right? So you can basically go ahead and do that as well here. You will be provided with a platform. You can decide what kind of platform you want there, right? You can choose whether you want it, you want a Python based, right? You want some PHP based, you can decide that. What GCP will do is by using compute engine, it will launch a virtual machine by itself. You can just go ahead and put forth your data and application on top of it. Everything else would be managed by your app engine. Then you have your container engine. Now, container engine, it is also known as your Google Kubernetes service. Now, when you talk about Kubernetes, it is a container management service. Basically, what Kubernetes does is it lets you launch these containers in which you can basically put forth your data, your bin files, and all those things, and it will start running. You just pick up that container and put it on any base, and it will start working for you. Let's assume that you have a multi-purpose charger, right? Where your phone gets connected once it does, and in front you have 10 different ports, and you can connect that to any kind of socket that is there, right? So that is what a container is. It will basically take in your data. In your case, if you're charging your phone, right, your phone is your data. So it will take that data, it will connect it or put it in that container, and that container can be used anywhere on any kind of platform or base, basically. So that is what container engine does, and container registry is one of the services that lets you do that or supports that activity. And then you have your cloud functions. Now this is your serverless offering that GCP has to give to you. So this is what some of the popular compute services that GCP has to offer are. Let's now go ahead and get into the demo part. We've been talking for an hour almost. So let's just go ahead and see how the GCP compute services pan out, how they work. Okay. Okay, so what I've done is I've actually gone ahead and signed into my Google Cloud Platform account. Now, when you talk about your Google Cloud Platform account, what GCP does is it basically offers a free tier version to you, which you can use, and you can practice quite a few things by using this free tier account. So when you have a free tier account, it comes up with a certain set of benefits, like all the basic services can be implemented there. And what GCP does is for a certain duration, it provides n number of units of money for you to use. So you can use that free units or those free units to spawn your instances, launch your storage services, database services, and stuff like that. So what you have to do is you have to just go to Google Cloud Platform free tier, create an account. They'll ask for your credit card. That is for verification. In case if you're using paid services, they'll charge you, but they give you a list of free services, so you can always use those free services, right? So once you do that, once you give in your credit card details, they'll verify your account and you'll be having an account that is ready to use for you. So ensure you go ahead and create a free tier account for your usage. Okay. Once that is done, you can always come to this platform and start using it. You can see that all the major services, be it your IAM, APIs, compliance, security, all these services are here. Okay. We'll be discussing these one by one. Do not worry about that. But meanwhile, let me just scroll down. The compute engine is the one that we'll look into right now. App engine is your service where you have your PaaS offerings. We'll see the IaaS one, right? The basic one. In your compute engine, you have your services, versions, instances. So a virtual machine is called as an instance when you talk about these cloud platforms. Let's open one of those. Unable to find a resource you requested. There was an error loading it. So let's reload it. Okay, no problem. We'll go back and we'll try something else. So let me go back. Let me just click on it and let me just go to compute engine. This was the reason, because I probably did it from the wrong place. So you can go for virtual machines, VM instances, right? Let's click on VM instances. So there's an instance that I created a while back. This was just for the usage purpose I wanted to show you, but let's not do that. Let's just stop this first. Now it might take a couple of minutes for this to stop, but I can instead just say delete. So let me delete it. Are you sure you want to delete it? Yes, I'm very sure I want to delete it. So it should delete this instance, and once this instance is deleted, I'll be having this interface for my usage. Okay. And there are various other options that you can do. You can see at the panel at the top where there are quite a few things that you can basically control. But meanwhile, let me just delete this instance and we'll launch a newer instance. Okay. So let me just refresh this and see how it pans out. If it is still deleting it, then it could take a minute. Okay, let's just say create now. During the course of this video, I'll also show you how do these things work in other platforms as well. I'm not going to walk you through them in detail rather, but I'll just give you an idea as to how these works, or those services also work there. So let's quickly take a look at, or just add a name here for our instance that we are planning to launch. Let's call it SAM4321. Labels, do you want to add a label? Because if you create multiple instances with similar names, it could be confusing. So you can add a label as to what that instance is for. You can see that I have this much amount of free credit, somewhere around 21,000 Indian rupees for my usage. So I can span these many instances. If I use this particular instance for a month long, it would charge me $25. In Indian currency, if we say like 70 to 75 rupees for a dollar, right? That is 750 for 10. So around roughly 2,000 rupees for an instance to run for the entire month if I keep it running, which you might not need to, but giving you an estimate, right? So it gives you the detailed information as to how long would this instance be running and how it would be working and stuff like that. Okay, let us now go ahead and discuss some of the other pointers. So it is a general purpose instance, right? If you can click on these things, you'll understand quite a few other things, right? So basically, when you say a general purpose instance, it serves a moderate performance of your computation and storage. Okay. If you talk about compute optimized, those are optimized for your computation, and memory optimized are something that give you higher memory or better memory usage. GPU is something that is used for your graphical processing. Okay. So we'll stick to the general purpose for now. This is its configuration. Okay. You can choose what you want to. You can also use a micro one. Okay. So this is not a concern for us. We are using it for a demo purpose. You see, each time you select one, it will give you all the details. It is using 2 virtual CPUs and 1 gigabyte of memory. And I can choose what kind of machine that I want to use here. If I click here, I'll get to choose. So I can use a Debian, right? I can use a GNU Linux. So instead of Debian, I can go for Windows and other things as well. So I have the option of choosing other servers if I want to, whether it's a Linux one, Red Hat one, and stuff like that. Let's stick to CentOS for now, or the Debian one for now. Okay. Buster size is balanced. If I go for standard, and if I say apply, now if you scroll up, you'll see that how much this one costs. So it will cost me $6 monthly. So it is fairly low, right? So from $25, we've come down to $6. Why? Because we've launched us or planning to launch a smaller instance. So these are the things that we can configure. If you go ahead, you have other things to configure as well. Okay. Or you can stick to the basic ones if you want to. Let's just go ahead and say create one. And just like that, my instance would be created. Guys, here you also have an option of working on quite a few other factors, right? You can just go back to the instance and see what kind of virtual network it falls under, what kind of storage that is attached to it. By default, you'll have persistent disks attached to every VM that you launch. We'll see what do those mean as we go ahead. But just to give you a gist, that is what it is. Yeah, so it is giving me a notification. This I can dismiss because I'm going to delete this instance any which way once its usage is done. So if I select this, why am I getting this thing here? I don't want it. I'm just going to scroll it for now. And it gives me different ways to connect. I can use SSH to connect to it. I can use it in different browser as well. Open browser windows with private SSH key and use this command. So this is the easiest way. Let's do that. Let's select this, copy it, and I'm going to say run in Google Cloud Shell. And within a minute, my instance would be up and running and I should be able to connect to it. There you go. It has fired up my terminal, right? And using the terminal, it has put forth that command as well, using which I can connect to the instance. If I just hit the enter button, do you want to authorize? Yep. And just like that, it would help me connect to my instance. You see? So it has connected to the instance that was there. And I can actually go ahead and start using this Debian if I want to. Similarly, if you go back to AWS, right? There's a service called as EC2 that lets you do the virtual machine job. And you can see that there are instances that you can create and launch. You can always come here and say launch instances where you can choose different kind of instances that you want to. Okay. It will also give you details about what instances are up and running and what are you planning to do with these instances and stuff like that. Okay. So there are quite a few things that can be done here, and you can use this AWS platform for similar things as well if you close it. If you go back to AWS services, it also has plenty of services that you can use. So we'll compare these services, how do they fare with each other and what kind of offerings these platforms give us. But by now, I believe the basic compute service is clear to you people, how it works and what all can be done with it. Okay, let's go back to our presentation and see what are the other pointers that we have to cover here. So we've seen how compute services work, at least the basic fundamentals as to how virtual machines on GCP work. And we've seen how, as they call it, compute engine rather works on GCP, which is equivalent to AWS EC2. Let's now go ahead and discuss how storage services work on GCP. Now, when you talk about GCP storage services, there are plenty of storage services that are there on GCP. And the reason storage services are important is when you talk about cloud platforms, right? It is very difficult to imagine any cloud platform without data. And the reason is simple, right? I mean, any application you create, any kind of data you put forth, you are dealing with data, right? Be it monitoring the data, managing the data, analyzing the data, right? Processing the data, everything happens on cloud. And that is why when you talk about storage services, they're fairly important. Now, when you talk about these storage services, they will store data in different ways and in different formats, right? You could be required to store your images, you could be required to store your videos, you'd be required to store maybe your structured data and stuff like that, right? So first, here you have something called as cloud storage. Now, it is a unified cloud storage service. What this unified cloud storage service does is it lets you store data in the form of blobs, or you can store your data, be it your images, as I mentioned, be it your videos, right? Be it your other forms of data. It can be your structured data, unstructured data, right? So you can store that kind of data here. But mostly the data that is stored here is stored in the form of objects or objects rather, and is stored in containers called as buckets. Now, when you talk about other cloud platforms, something like AWS, Microsoft Azure, now on these platforms, when you store this kind of data, you have separate services for storing the data. Now you have something like S3, right, which stores all these kinds of data. Then you have something called as EFS, which stores files in the form of data. You have EBS for block storage. Here to have persistent disks for that, but I believe you get the gist what I'm trying to say here. Apart from that, you have your other data services, like you have your Bigtable, that is Cloud Bigtable, and your Cloud Data Store. Now, these are your NoSQL databases. Now, when I say NoSQL databases, I'm talking about those databases that basically deal with not only SQL data, it can be your unstructured data as well. Now, these are different from your cloud storage. The reason is these are more towards the line of database services where you can process your data, right? You'll be having your data stored in a particular server, and then you can process this data by using something like Cloud Bigtable or your cloud data store. When you talk about cloud data store, it mostly works with hierarchical data, whereas your Bigtable is responsible for dealing with data that requires low latency, right? Quick processing of data. You can read, write your data, and it gives you highly, or you can say high throughput performance for data analytics as well. If you go ahead, you have your Cloud SQL. Now, this is something that deals with your SQL data or your sequential data rather, right? So if you have structured data and you want to put it in databases and process it, this is where your Cloud SQL storage will come into picture. And then you have something like persistent disk. Now, what is a persistent disk? When you talk about persistent disks, we are talking about block storage. What is a block storage? This kind of storage always needs a host machine, a host system to access this kind of data, right? So when you talk about this kind of storage, to give you an example, let's assume that you have your hard disk, right? You can store your data in your hard disk, but how? You need to connect that hard disk to your system, right? To some other device where you can put forth that data and copy that data there, right? So it is dependent on the host machine. But your block storage again comes in two parts. You have your ephemeral storage and persistent storage. Ephemeral storage is something that dies with your instance. Okay. That means if there's a particular instance or virtual machine that you've launched or a system you've launched, if you delete that particular virtual machine, your data would die with it. In case of persistent storage, there's a slight difference here. In your persistent storage, your data won't die. Why? Because you are creating this storage separately and you can attach it to your instance, you can detach it to your instance, and it will not die even if your instance does. Okay. So this is what persistent storage, and these are what cloud storage services are like. I will understand these services practically as well. But before that, let's quickly jump into the other set of services, that is your networking services. Now, when you talk about cloud networking services, again, network is a very important aspect of cloud. I believe I've already discussed this when we talked about popular service domains on a surface level. And the reason for that is when you talk about clouds, as I've already mentioned, your data could be residing in different parts of the world, and there could be different things that you need to control. One of the major things that you need to have here is an umbrella of network that connects these different locations and places where your resources lie, right? So there would be a lot of things like who gets to access what, how, right? What are the firewalls that are in place? What are the subnets? What are the IP addresses? What needs to be assigned to whom, right? And this has to happen virtually because you cannot have physical subnets and networks, right? You cannot have physical routers and stuff. Yes, there would be some physical routers, but all this network is basically connected over a virtual umbrella. And that is why you need these virtual network services that GCP offers, in this case of Google Cloud Platform, right? So let's try and understand them, as in what are these and what all can you do with it. So first you have your virtual private cloud. So whatever I've just discussed, right? So you can create a virtual private cloud or cloud virtual network, right? Where you can put forth certain set of resources in that particular network. Say, for example, you have like 100 devices that you can assign in that particular network. So you can basically create subnets, create sections, decide how many IP addresses you want to assign to a particular network or to a subnetwork. Again, decide what resources fall under that particular network and what are the ways in which you can access the resources from there, right? So it's a mix of various IAM services as well, something that we'll discuss as we move further. But I believe by now the gist is clear to you as to what your virtual private cloud does, okay? Or your cloud virtual network. Apart from that, you have cloud load balancing. Now, this is another interesting service. We discussed about those applications where we have our e-commerce website and it experiences traffic. So if we stick to our Diwali example or a New Year's example, we are talking about a lot of people shopping, right? In that case, there could be a possibility that there's a lot of burden on a particular resource, a server. In that case, you have one option of scalability, which we talked, right? You can upscale horizontally and vertically as well. Now, for people who do not know what horizontal scaling and vertical scaling is, we are referring to two important pointers here. The first one is how do you scale horizontally? That means if there's a lot of load on a particular resource, you can have multiple servers attached, multiple machines attached. And there's something called as vertical scaling, where you can actually go ahead and increase the computation storage power of a single machine. So there are different ways to scale as well. But what does load balancing do? What load balancing does is instead it diverts the traffic from a particular resource to the other to manage the load in case of existing infrastructure where you do not need to scale up or down. This is very good in terms of disaster recovery as well, where you do not have to worry about if a data center goes down or stuff like that. So say, for example, you have an instance where you have this your e-commerce website and it is experiencing a lot of traffic. Can you just transfer your traffic to some other node or some other instance or virtual machine that is located in some other region or which is close by? So your traffic would be distributed. Yes, absolutely. You can do that, and you can do that by using cloud load balancing. Okay. So these cloud load balancers, they come in various forms, right? And there are different purposes for these. There are application load balancers, there are standard load balancers and stuff like that. Okay. So depending upon the applications, they vary as well. To give you another layman example for these things, you have something, if you are in India again, then you'd know that the Cosmos cities here experience a lot of traffic. And if you stick to that traffic, you'll either get late to your work or you'll have to start a couple of hours early, right? So we always know our shortcuts where to move from to do what, right? So if there's a lot of load, lot of traffic in particular area, you can always take this other route. And that is what cloud load balancing does in terms of your data, right? Where should they move your data? They'll move it to some other load balancer where it can be balanced better. Okay. Moving on, you have your cloud, or rather you can say content delivery network. Okay. So cloud CDN or content delivery network is again a content distribution service. Okay. So I'll tell you what this does for you. Let's assume, I'm again gonna stick to an Indian example. Now in India, we have cities like Mumbai, you have your Bangalore, you have Ahmedabad, right? You have Kanyakumari. The reason I'm specifying these cities are, let's assume that I'm based in Mumbai right now, and I want to move to Ahmedabad, which is in Gujarat, or to Bangalore in Karnataka, or Kanyakumari down south, okay, right to the bottom of the country. So depending upon their locations, the closest to me would be Ahmedabad from Mumbai, right? The next would be Bangalore, and the last would be Kanyakumari because the distance is lot. Let's assume that Mumbai is a server. Or for example, let's continue with this example. Let's assume that I want to travel to these places and I use a similar vehicle. Let's assume I'm either taking a bus or I'm taking my personal car, right? So if it takes like what, 10 hours to reach to Ahmedabad, it would take like around 15 to 20 hours to reach to Bangalore, and somewhere around 25 to 30 hours to reach to Kanyakumari, depending upon how I leave from Mumbai. Okay. So the point I'm trying to make here is, the more the distance, the difficult it is, or the longer it will take for me to reach to a particular location. So if Mumbai had a server and I had to fetch data from Mumbai server and I was based in these three different locations, the earliest I would get the data would be in Ahmedabad, and the latest I would get it would be in Kanyakumari, right? So what that implies is data latency can be a big issue. So how does Google Cloud Platform solve this issue? It creates content delivery networks, or in simple words, it has edge locations. So each edge location is located close to a particular data center. What they do is they fetch the frequently accessed data from the server and cache it there in that particular edge location. So that way, whenever, if I am trying to access this data, let's assume from Kanyakumari, and if it has been cached there, I would be accessing this data at a faster rate because the distance would be minimized, thus resulting in low latency results. So this is what content delivery network does. And then you have your cloud domain name service. Now for people who do not know what domain name service is, let's assume that we all use website like Amazon, right? Or maybe our Google search engine. So we put in an address there, right? The address can be something like www.amazon.com, right? So this is an address which is easier for you to understand in a layman language, right? Similar to if I have to visit to my friend's place, right? I'll be looking at the address that is given, maybe flat number X, road number X, area number X, and something like that, right? So what do these labels tell me is, where does this person reside? And it is easier for me to find this person based on this address. Similarly, if you want to access particular set of data, you'd need to know where does this data reside, right? Your website address. And that is something is controlled or governed by your domain name services. Now with cloud, or in this case with GCP, you specifically have a service called as Google Cloud Domain Name Service, which basically lets you control these domain names, have access to data for people from different locations and stuff like that. So the domain naming service that is controlled by Google Cloud is Cloud DNS, which lets you do these domain naming service activities. Okay. So this is what GCP networking services are, and this is what these services do. Let us now go ahead and take a look at the demo part and explore some of these services a little more. Okay, so previously we saw how to create an instance, right? Now we'll go ahead and explore the storage service as well. So guys, note one thing. You might have not realized in the previous part that when we saw how to create an instance, the fact that whatever thing I'm creating, it goes in this my project, right? So it is a container where my GCP is storing all my resources. Okay. So similarly, to store your data, you also need to create a storage account. Okay. So when you start this for the first time, if you click on cloud storage, it will ask you to create an account. So make sure you do that. You just have to enter a name for it. And I think you should be good to go ahead with it. Right now, in my case, I think I should be having a storage account already. So I'm going to just go ahead and say cloud storage. And once you do that, no sooner this page loads, this is where you get a notification. When you click on create bucket, it says that you cannot do that right away. Now, again, as I've already mentioned, bucket is nothing but a container where you store your objects or your files, right? The data that you plan to store. So you have to create a bucket first. So when you create a bucket, guys, please note this thing that these buckets have unique names. You cannot just go ahead and say that, okay, use this bucket in this form. Okay. You'll have to give a specific name to it. And if the name is already been taken, you will not be able to create that bucket. So let's try and create one. There are other clauses as well. If I'm not wrong, you cannot use a caps name as well, something like that. But let's try it if that works. So I'm going to name it GCP demo bucket. I'm going to say continue. It says that use only lower cases. As I've already mentioned, there's an error here. So let's say GCP demo bucket and say continue. This bucket name already exists. As I've told you, the bucket has to be globally unique. Let's give it a terrible name for now. This I'm sure should be acceptable. So guys, once we click on continue, these are the other things that we need to take a look at or need to understand, as in what kind of bucket I want. Do you want it regional, dual regional, or multi-regional? By the name itself, it should be clear, as in the latency is reduced because in a regional bucket, you are dealing with a single region, single bucket. All your work would be concentrated there. In dual region, you'll be having high availability, low latency, and you can access this data across two regions. In multi-regions, you can have data in multiple regions as well, or buckets in multiple regions as well. That is, you can access this bucket from multiple regions. In this case, we are sticking to the region one. This is a basic demo. Apart from that, you can choose what kind of region do you want to store or create your bucket in. Say, for example, I can select Mumbai, India, right? Let the basic one be here. This is not very important for us. So I'm just going to go ahead and say continue. Okay. And once I click on continue, the next thing is I need to choose what kind of storage account I want to use right here. So I have certain options here, whether I want a standard storage, nearline one, cold line one, or archive one. You might read what is written here. Meanwhile, I'll explain what those are. Say, for example, you want to store your data, right? It is mission critical data and you want to access it right away. Okay. So in that case, you should store your data in standard access. This is where no matter when you put your data, you can retrieve it right away. Okay. No retrieval time is required. Nearline is something when you put your data there, you have to put that data there for at least a month. You cannot access it or retrieve it before that. In some cases, you might want to store your data for a longer duration, maybe around a quarter or 3 months, as we say. That is where you can use your cold line data. And finally, you have your archival data, which is for a duration which is longer than 1 year. Now, you might wonder, as in why do we have these kind of different brackets? First of all, the first one is the costliest here. Why? Because there's no retrieval time. I mean, you do not have to wait for more than seconds, right? The latency is like in seconds, so that which is very less, even milliseconds in some cases, so which is very less. So since if you're talking about mission critical data, it is always wise to put your data in these kind of storages or in the storage. Next is your nearline and the others. Now, what do these others implies? There could be a particular requirement for you to store your data for a particular duration. Suppose that you either might not want it or might not want to use it, right? Say, for example, there's a particular data that you don't want to use, like is something that you're certain you will not use for years. Medical records could be one example, or something like your school leaving certificate. So let's assume that I go to my school and I collect a copy of my school leaving certificate. Okay. Say, for example, take my case, I passed out in 2007, my schooling. Okay. So if I am to take a look at this information, right, and this for some reason for today, it's like 2021, right? So like 14 years, I want that copy of my school certificate. So I can always visit my school and apply for that, right? But the fact is I'm accessing this data like what after 14 years, right? So this data is important to me, but not something that I need it right away for mission critical purposes, right? So what happens is I go ahead and request them for that birth certificate, and they might say that, okay, come back after 2 days, right? Because we'll have to go through so many records to fetch your data and something that you've not accessed in like 13 years. So something like archival storage is similar to that, where you do not need to access your data regularly, but you need a copy of it to be maintained somewhere. So you can do that. Since the retrieval time is longer, it's cheaper compared to other storages. And why do you store data in these kind of things, right? Let's assume that Edureka makes courses, right? What if Edureka had its database on something like GCP, right? In that case, if I had to store a particular copy of my course, which I do not use regularly, I might put that copy in a cold storage or archival storage, which I do not access frequently, right? So the data would be there, but it would not cost me a lot. But what if there's a course that I do not access at all and I put it in standard storage? Now it is being charged very heavily. I'm being charged very heavily for that, but it's of no use, right? So that is what these different storage systems talk about. Okay, I hope that is clear to you. Let's continue with the standard one because this is a very minor demo that we are creating. What kind of access you want, fine grained or stuff, let's not get into details of that. It's not important. Let's just create a bucket. And just like that, I'm sure a bucket would be ready. You see, within a minute you have, not even a minute, within click you have the buckets with you. It says upload file. I'm just gonna go ahead and say live stats, and I'm gonna open that bucket. And there you go, the live stats PNG file is uploaded. So you can upload your videos here, you can do quite a few other things here. Now again, you might wonder, as in, is this the most efficient way to use this particular set of data? Are there other things that I can do with it, right? Yes, there are a lot of things that you can do. You can basically go ahead and assign bucket policies, right? As in, you can decide who gets to access this file. Say for example, this is a private bucket, so storage is standard here, and you can see public access, it's not public, so not anybody can access this data but me, right? And it says retention expiration date. There's no date here. Why is that? Because I haven't set a life cycle policy. Something that I can do, when I say assign a life cycle policy, what that means is basically I can decide after a particular duration what to do with this file. Now, there's a certain set of data that might be useful to me in real time, but that data might not be as useful after 3 months, right? So let's assume that there's a particular image that I put forth here, and I realize that after 3 months, I'm not using that image. Or I know that after 3 months, I will not be using that image at all. So in that case, I can assign a life cycle policy to it. I can say that in that life cycle policy, I can say that, okay, for 3 months, let it be in standard storage. Post that, either move it to cold line or near line, or directly move it to archival, because I might not be accessing that file for that longer duration any further. In case if I feel that I'm just not going to access that again, I can just set an expiry date and it would be deleted and garbage collected by GCP. Okay. So that is what your lifecycle policies let you do. The other things that you can do, you can delete your content here, download it, right? You can upload your files and do other things as well. So that this is what your bucket or your Google Cloud Storage lets you do. Now with AWS, you have something like AWS S3 Simple Storage Service. I'll show you what that is, but when I discuss the IAM part, that is when I'll show you, because I want to also talk about multi-factor authentication and stuff like that. So meanwhile, you can wait for it. Okay. So this is what these buckets or these storage services do for you. So I hope this is clear to you. We also discussed the VPC part, right? So let's quickly see what VPC also does. So do we have VPC here? So for VPC, I'll have to maybe scroll up or scroll down. VPC, there you go. And you say create your VPC networks. Okay. So this is where you can create your virtual private cloud. By default, you can see that these are the subnets that are assigned to it. I will not create one, but I'll show you what can be done here. It's fairly easy. You can definitely try doing it on your own, but let's not spend too much time doing this. Okay. So you can basically give a name, maybe ABC as a network. Okay. That's a terrible name, but let's stick to that. Apart from that, you can decide whether you want to automatically create subnets or custom create it. What's the difference? When you custom create it, you specify what IDs, IP addresses do you want to put under a subnet. If you select automatic, it will automatically distribute the IP addresses. Say, for example, you have 20 IP addresses. You can decide what these 20 IP addresses need to be assigned to what subnet. Okay. So accordingly, you can decide that based upon the region in which these exist. Okay. So this is one. And then once you do that, you can also go ahead and create a firewall here. So what do we do with firewall? With firewall, you can decide who gets to access this network, right? Where are you allowing data to enter into this network? Now, let's assume that I have an instance. We saw how to create a CentOS instance, right? So if I have one lying in this network, In that case, I need to decide how can I sign into this instance, right? Am I SSHing into it? And does my virtual private cloud allow me to do that? So I can set up policies that let us control these things. Okay. So this is how the virtual private cloud works. And similarly, if you look for CDN, I'm sure you'll have that here as well, because we've discussed that. So you have your cloud CDN as well. So when you talk about your cloud CDN, you can add origin here. So when you say origin, you can decide where do you want to basically go ahead and cache your data from. That is why you add your origin and stuff here. Okay. So that is what your CDN lets you do. Okay. So this is what CDN is all about. Let's now go back to the presentation and discuss the other services that we have with us. So let's now go ahead and try and understand how GCP security works. Now, when you talk about security, security is a very important aspect for clouds as well. If you go back to like 2014, 2012, people already questioned cloud security. The reason was there were many outages back then where people lost a lot of data, but that has changed. Whether you talk about physical security, where these data centers are governed 24/7 by physical resources or physical individuals, also to the fact that where people do not know where these data centers are actually located to visit. Yes, we know there's a data center in Mumbai, but you will not know where it is located. Very few people know about it. Apart from that, if you talk about network security, there are various practices, be it your IAM, where you can control identity and access management, be it running security checks through and through, or be it setting up shared security models where you as a consumer get to control certain security activities, and cloud as a vendor knows that, okay, these are the things that we need to control, and they also control those security aspects. So you get more security when you talk about cloud. Now, what are the things or what are the services that are there? Now, when you talk about cloud security services, there are plenty of security services that are there in the market. The major ones are, you have your Google Resource Manager, then you have your IAM, Security Scanner, and Platform Security. The others as well, as I've mentioned, but these are the core ones. If you talk about the Cloud Resource Manager, what a Cloud Resource Manager does is it lets you set up a structure, right? We've talked about that your projects hold all your resources. So it's a similar structuring that we are talking about. Since you put all your resources in a structure, it becomes easier for you to decide who gets to access what, and more importantly, how. Okay. Now this is where your IAM also comes into picture. What IAM does is basically IAM ensures that you as a user gets to control who gets to access what and how. So we'll see this in the demo part. I basically have some IAM users through which I can access my AWS account, which is very similar in Google Cloud Platform as well. I'll show you how that works. Okay. So basically, when you talk about Cloud IAM, what it does is it helps you create users to start with. So I can create, say, for example, 10 users for 10 different people. So I have an organization where I want these 10 different people to do different things. So I'll be creating 10 different accounts so that when these people access the cloud, they get to access this cloud from their account, and I can decide how much access to give to which individual, right? I as an admin, I have entire control, but others I can decide who gets to access what, right? To give you another example, let's assume that you have a set of developers who might be needing access to all the developer tools and activities that concern it. Next is your analytics team who needs access to more management tools and not the developer tools. So I can set up two groups, right? I can create two groups. This is another concept where you can create groups. And in these groups, I can decide who gets to access what in that group, and accordingly create users and put them in that user group. So basically they get to access only those resources first, right? Then you can create also policies where you can do some service related work where you can decide what service requests to throw and all those things. So that is where your policies and roles come into picture. So that is what Cloud IAM does. Basically it lets you govern the identity and access management to your cloud platform. Then you have your Cloud Security Scanner. Now what exactly is a Cloud Security Scanner? When you talk about a Cloud Security Scanner, basically let's assume that I have n number of virtual machines created. Now these virtual machines would be accessed through different URLs, right? The applications that are based on top of them would have certain URLs, and people would be accessing it from different resources. What Cloud Scanner does is it basically scans or crawls through all the links, all the websites and applications that are being accessed, and checks for security. When you talk about Google Cloud Platform security, on the other hand, it is a more generalized version which controls security on top of Google Cloud Platform. So this is what, or these are what the security services on Google Cloud Platform let you do. Okay. And what they are exactly. Let's now go ahead and understand something else, and then we'll probably again jump back into the demo part. So you have the management and developer tools. Instead, what I will do, guys, is I'll just go ahead and discuss all these services at a stretch, and then we'll explore them in the practical part of things. Okay. So let's try and understand the management and developer tools as well. Now, when you talk about the management and developer tools, management tools are something that let you govern all the management activities that are there on your cloud, right? So say, for example, you have your monitoring and logging services. So I don't know whether you checked it when I opened my GCP. There was a dashboard there. So it is something that can be created by using your monitoring and logging services. So I'll show you once we get into the demo part. So that is where you'll get data about all those logs, all the requests that you've made, right? All the services that you've launched and their CPU utilization and stuff like that. Apart from that, you have other services like your Cloud Shell, Cloud APIs, right? These let you control your applications more programmatically through command line interfaces where you can actually go ahead and code and then access these resources. Apart from that, you have your Cloud Console, which limits or reduces the amount of coding that you need to do in order to access these resources. And then you have your Cloud APIs, which basically, again, I believe I already discussed that, so let's not get into that. But APIs and CLIs, that is what they let you do, or Cloud Shell, that is what they let you do. Mobile Cloud App lets you basically monitor your data using your mobile applications that you can connect on your phone by using your Google Cloud. So your data would be residing on cloud, but you can monitor that data by using cloud mobile apps. And then you have your developer tools. Now, this is where your developers come into picture. When you talk about cloud, you are not gonna just go ahead and put your data there and manage that data, right? You'd also be building applications that you want to use. So can you do that on top of cloud? Definitely you can do that on top of Google Cloud as well. You have something called as Google SDKs, then you have your deployment manager, and you have your Google Cloud source repositories. So SDKs is something that lets you control your software development toolkits on top of cloud, and deployment manager is something that lets you control your container applications on top of Google Cloud. In terms of cloud source repositories, it is something that basically lets you have a version control device on top of cloud. So we all have heard about Git, right? So Git is nothing but your version control device. So using GCP Cloud Source Repository, you can create a similar version control on top of cloud, or you can even connect to Git to basically import those repositories, and then you can pull, push your data and work on top of it. Okay. So that is what your Google Cloud Source Repository lets you do. Next, we have our cloud tools for Android Studio, where you can do Android development here, right? And then there are other application-based tools as well. Something for your PowerShell implementation. You have tools for Visual Studio and plugin for Eclipse and other test labs as well. So that is what your developer tools let you do. Okay. So this is how the development and management tools on cloud work. Let's now go ahead and discuss some of the other tools as well. Then you have your big data services on top of cloud. Now, what do your big data services on cloud do? Okay. So there are plenty of services here. You have your BigQuery, you have your Dataproc, PubSub, you have your Dataflow, Data Lab, Genomics, and a number of other services. Now, BigQuery is nothing but a data warehouse that basically lets you analyze your data and process data at a very low latency. Dataproc is again another service that lets you deal with your Apache server, Apache Hadoop kind of infrastructures. Now, when you talk about big data, right, we are talking about Hadoop infrastructure. This is where we are talking about unstructured data being handled. And one of the easiest way to put your data there is by using something like a Hadoop ecosystem, and by using Spark that lets you stream process data at a very quick rate. So that is where your Dataproc service comes into picture. It basically lets you manage these kind of data on top of your cloud, and basically lets you manage your big data activities on top of cloud. Then you have your PubSub and Dataflow. Now these are your streaming services. So if you've heard of something like Kafka, that lets you do publish your data and basically lets you to subscribe to other topics as well. Say for example, you use Gmail, right? On Gmail, what we do, basically we have certain emails that we've subscribed to and we get them regularly, right? You can decide to unsubscribe as well. So when you talk about streaming data, if you want certain topics to be subscribed to, you can do that by using PubSub and Dataflow. So Dataflow does not let you subscribe, but it works on handling streaming data rather. And then you have your Genomics and Data Lab. Data Lab again is a tool that handles big data for you, and Genomics is something that lets you work with research kind of data. Now, what do I mean by research kind of data? Now I'm referring to that data that basically lets you deal with something like COVID that we had in 2019, right? So suppose that there were many people wanting to research on genomic data. the DNAs and stuff, right? To understand how did this virus evolve. So that kind of study falls under life sciences. And if you are a group of people who want to do it, you can do that on cloud. All your basic infrastructure and underlying aspects will be controlled by Google Cloud Platform. All you worry about is how do you work around that piece of data, that set of data. Moving on, you have something like your GCP machine learning services. Now, when you talk about GCP machine learning services, we are referring to practicing machine learning on top of GCP cloud. Now, machine learning, as we all know, has been trending a lot in last decade, and it will continue to trend because the importance of data has changed widely in recent times. And that is why we see people wanting to make a career in these domains. So can you do or perform data science activities and machine learning activities on top of Google Cloud? Definitely you can. How do you do that? You have these set of services to let you practice these things, right? So first and foremost, you have a cloud machine learning. So it is similar to AWS SageMaker, where you can actually go ahead and practice these things like building your Python, having a Python notebook configured readily on top of an instance, and then building a model. And with something like cloud machine learning, it becomes easier for you to deploy those models as well in the public environment or in the production environment rather. Then you have your APIs. Now these are cognitive services. What do I mean by APIs or these cognitive services? So let's assume that you want to process images. You want to understand what is this image specifying, right? Whether there's a person in it, there's a celebrity in it, does it match with other images and stuff like that. So you can use an API like Vision API. Speech API is something that lets you convert your text to speech, speech to text and stuff like that. Natural language APIs are something that let you work with your lexical data analysis or basically doing sentiment analysis and stuff like that. Then you have translation and job APIs as well that basically let you translate your data, and job APIs are something that again deal with data handling in general. So that is what these services let you do. Let's now go ahead and look at them practically. Let's see some of these services that we've discussed. We've talked about security services, right? We've gone ahead and discussed the big data ones, the machine learning ones as well. Let's try and understand them practically and see how do some of those work, or what can you do with these services rather. Okay, so I'm gonna quickly switch into my console. So there you go. I've gone back again, and now I'm gonna go ahead and you see this dashboard here. We talked about the management and developer tools as well. So this is how a dashboard, this is what it simplifies, right? What kind of data was being used. So initially when I started the server at 12:30 today, I had a spike there. Okay, so that is gone. That is when I started one of my services. So the CPU utilization rose there. So you can see that the CPU utilization and stuff will change here if you create your resources. Okay, you can monitor other resources, billing and stuff as well. You'd get to know what are the resources. You can see that there are two storage buckets that are there, one compute engine that we created a while ago, and one of the buckets that you saw how to create one, right? So all the information would be available in your dashboards, and this can be done by your monitoring and logging services that you have. Okay, what are the other things that we can do here? Let's just go ahead and take a look at those. Security services, IAM is one of those that I just mentioned, right? So you can create your IAM users here, and you can decide all those things, who gets to access what. So if you click on members roles, you can add those. You can just add users as well. Say for example, I add a user called as Vishal here. Okay, forget the spelling, it's not important. Okay, I can select what kind of role this individual needs to have. Okay, you have to enter the email address here for that. Okay, so you can add an email address, and post that you can decide who gets to access what. Is it an editor access, owner access, viewer access? And I can also add conditions here for durations, times, days, what kind of access and stuff like that. You can add more roles here, and then you can just say save. Once you do that, you can add them in groups as well. You can see that there are members here, right? So you can create groups as well, and then you can add them there. All the policy analyzers and stuff, you'll find all those things here. I mentioned the fact that I'll show you something in AWS as well. So you see, this is the company's account that we use, and I have an IAM user here. Okay, you see, this is signed in by this account. But when I member login, right? If I member login here, it will ask me to do a two-step authentication process. So when I enter the password, it will ask me for a number that would be generated by Google Authenticator on my phone. So it's a multi-factor authentication process, more than one step of authenticating that I am the right user. And since this is a pseudo user that I'm using, I do not have admin access to a lot of services. Say for example, if I open S3 here, it will not let me create a bucket here because I do not have access to that. You see, you don't have permissions to list buckets. So this is what you can control by using your IAM policies, and that is what your IAM services let you do. So I believe this little bit or this little gist of things is clear to you people. Okay, moving on. Let's try and understand other things as well. Okay, there are other services here as well which you might want to take a look at. If you say sign into the console, it will directly sign in right now because I'm already signed into it. If I wasn't, it would have asked me for all those passwords. And there are other services here as well, right? You have your IAM billing, or basically S3 is something that is similar to the buckets that I've already shown. EC2 is something that lets you create instances here. Okay. And then there are a plethora of services that deal in management and monitoring as well. So if you scroll down, you'll get information about those. You see, you have VPC here, you have CloudFront is one more that should be here or somewhere, which is equal to GCP CDN. And then you have your developer tools. Okay, so you have your code commit, which is similar to the Google repositories, cloud repositories that we saw. So that is what these services let you do, and these basically let you deal with all this data that is there for you to work with. Okay, let's now go back to this thing and take a look at other things as well. So I believe the security bit is clear, management bit is clear to some extent as well for you people. Big data services, we've discussed that there are a lot of big data services here as well. If you scroll down, or if you just go back here and click on services, you'll see that all the other services here. Okay, so we talked about pub/subs as well, right? If you remember. So these are the databases, right? The Bigtable data store, the NoSQL databases that we discussed. You also have your spanner, which is again a database service. SQL is something that stores your SQL data. Monitoring is few things we discussed. Code build is something that lets you develop your code. I've told you can build your code there, whatever pieces of code you have. And similarly, if you scroll down, this pops up, right? I talked about topics, subscriptions, and snapshots. You can do all these things by using these particular set of services here as well. Okay, so in terms of APIs as well, I've talked about that there are vision APIs, but again, when you want to use vision APIs and stuff like that, you need to basically activate those APIs, which I don't think are activated here right now. So I'm afraid I would not be able to show you a demo on that, but you can do that. Text to speech is what you can use. For that too, you'll need access, but you can actually go ahead and enable these APIs, and you can actually go ahead and work on these things practically then. Okay. Apart from that, there are other things that you can look into. Some of those are, if you go to AWS, you have services like Poly, which lets you convert text to voice and vice versa. Textract is another one that lets you do that. Then you have Rekognition, which lets you process images. Okay. So if you come here, you can actually go ahead and do all those things, right? Facial analysis, whether a person is happy or not, male or female, right? What could be the age? You can decide you can do face comparison or celebrity recognition as well. So you can compare two images and tell whether they match with each other or not, whether this is a celebrity face and does Google or Amazon know it, right? So these are the things that you can do with these APIs that we discussed. So these are few things that you need to look into. There are quite a few things that you can actually express when you talk about, or explore rather, when you talk about Google Cloud. What I will also do is, as we move further in future content, I will ensure that we come up with videos that talk about these services in detail, and where we'll focus more on each of these services individually. This being a tutorial video, I had to cover a lot of content here, so we could not discuss all those in detail. But in future, definitely we'll come up with more individual videos that talk about this content or those services in particular in detail.
So now let's first understand what infrastructure as a service, that is IaaS, is. So infrastructure as a service are online services that provide high-level APIs which are used to dereference various low-level details of underlying network infrastructure like physical computing, resources, location, data partitioning, scaling, security, backup, etc. A hypervisor, which is nothing but a physical host such as Xen, Oracle, VirtualBox, Oracle VM, KVM, or VMware, runs the virtual machines as guests. So pools of hypervisors within the cloud operational system can support large number of virtual machines and the ability to scale services up and down according to customers' varying requirements. Typically, IaaS involves the use of cloud orchestration technology like OpenStack, Apache, CloudStack, or OpenNebula. This manages the creation of a virtual machine and decides on which hypervisor to start it, which enables virtual machine migration features between hosts. Also, it allocates storage volumes and attaches them to virtual machines and track usage information for billing and more. Now let's get an overview of Google Cloud's compute engine. So Google's Compute Engine is Google's infrastructure as a service virtual machine offering. It allows customers to use virtual machines in the cloud as server resources instead of acquiring and managing server hardware. Google's Compute Engine offers virtual machines running in Google's data centers connected to the worldwide fiber network. The tooling and workflow offered by the Compute Engine enables scaling from single instances to global. Google Compute Engine enables users to launch virtual machines on demand. Virtual machines can be launched from the standard images or custom images created by users. The Google Compute Engine users must authenticate based on Auth 2.0 before launching the virtual machines. So what Auth 2.0 here is? So if you see, Auth is an open standard for access delegation, commonly used as a way for internet users to grant websites or applications access to their information on other websites but without giving them the passwords. The mechanism is used by companies such as Amazon, Google, Facebook, Microsoft, Twitter to permit users to share information about their accounts with third-party applications or websites. Now going back to Google Compute Engine, which can be accessed via the developer console or RESTful API or command line interface. Now let's have a look at some of its applications. So first one is a virtual machine migration to Compute Engine. So what it do is, as you can see in the diagram also, how it works. So it provides tools to fast track the migration process from on-premise or other clouds to Google Cloud Platform. If a user is starting with the public cloud, then they can leverage these tools to seamlessly transfer existing applications from their data center or AWS or Azure to Google Cloud Platform. Users can then have their applications running on Compute Engine within minutes while the data migrates transparently in the background. That's how virtual machine migration works. Then we have genomics data processing, as you can see in the chart that how it works. So processing genomic data is like computationally intensive process because the information is enormous with vast sets of sequencing. So with the compute engine's potentials, users can process such large data sets. So what it do is it processes petabytes of genomic data in seconds with compute engine and high performance computing sense solution. So Google Cloud's engines scalable and flexible infrastructure enables research to continue without disruptions. Okay. Also, like competitive pricing and discounts help you stay within the budget to convert ideas into discoveries or hypotheses into QOs and also like inspirations into products. Then we have BYOL, also known as bring your own license images. So in this, how the normal host and then we have a sole tenant node. You can see how this chart is given for its working. So what it do is a compute engine can help you run Windows apps in Google Cloud Platform by bringing their licenses to the platform as either license included images or sole tenant images as shown. So after you migrate to Google Cloud, optimize or modernize your license usage to achieve your business goals. Take advantage of the many benefits available to virtual machine instances, such as reliable storage options, the speed of the Google network, and also like auto scaling. Now let's look at some of the key features of Google Compute Engine. The first is machine types. It describes the virtual hardware that is attached to an instance, which also includes RAM and CPUs. There are like two types of machines. First is a predefined, and second is a custom machine types. So predefined machine types are like there are pre-configured virtual machine templates that can be used to set up the virtual machines. The configurations have been pre-optimized by Google and like meet most of the requirements. So the predefined machine types are further divided into four subcategories. So they are like standard virtual machines, which are like balanced between processing power and memory. And then we have high memory virtual machines. In this, like emphasis is put on memory over processing power for tasks that needed accessible non-disk storage quickly. Then we have high CPU virtual machines. So high CPU usage for like high intensity applications that require processing over memory. Then the fourth subcategory, that is the shared core virtual machines. So if you see a single virtual CPU backed by a physical CPU that can run for a period of time. These machines are like not for use cases that require an ongoing server or significant power. So the second main category under machine types is custom machine types. In this, the virtual machine can be configured manually for a compute engine virtual machine instance. So users can like select the number of CPUs and memory provided they are within Google's set limits. So the second one is a local SSD. So Google Compute Engine offers always encrypted local solid state drive block storage, which is physically attached to the virtual machine running it. It improves performance and also like reduces latency. Now the third one is persistent disk. So these are durable high performance block storage for virtual machine instances, which can be created in hard disk or SSD formats. So users can take snapshots and create a new persistent disk from the snapshot. If a virtual machine instance is terminated, the data is retained by the persistent disk, which can be attached to another instance. There are two types of persistent disk. First is shared, second is SSD. Then we have GPU accelerators. So GPUs are added to accelerate computationally intensive workloads like machine learning or virtual workstation applications, etc. Also, the fifth one is images. So an image contains the operating system of the root file system that uses leverage to run virtual machine instance. So Google Cloud Platform provides two main types of images. First one is public image and second is custom images. So public images are like collection of open source and proprietary options. This is the starting point for most virtual machine instances and come packaged with only the operating system. The second one is the custom images. So public images, if you see, are a good starting point, but they are designed to be built upon and turned into custom images to match the needs of the customers. Custom image has the software needed along with all the scripts necessary for the instance to work automatically without administrator intervention. These are automatically brought up and shut down for load balancing or recovery needs. So the last one is global load balancing. So it helps in distributing incoming requests across pools of instances across multiple regions so that users can achieve maximum performance, throughput, and availability at a cost. Similarly, there are many other features like Linux and Windows support container reservations, OS patch management, live migration for virtual machines, and many more. Google Compute Engine has many pros such as the input-output like access, like smooth integration with other Google services, and few cons as like most components are based on proprietary technologies and the choice of programming languages is limited. So now that you know the applications and features of Google Compute Engine, let's now look at some major advantages of it. Okay. So the first is storage efficiency. So the persistent is support up to 257 terabyte of storage, which is more than 10 times higher than what Amazon Elastic Block Storage can accommodate. The organizations that require more scalable storage options can go for Compute Engine. Then we have costs, as it is cost effective. So within the GCP ecosystem, users pay only for the computing time that have consumed. So the per second billing plan is what used by the Google Compute Engine. Then we have stability. Google Compute Engine offers stable services because of its ability to provide live migration virtual machines between the hosts. Also, Google Cloud Platform has a robust and inbuilt and redundant backup system. So the Compute Engine uses this system for flagship products like Search Engine and Gmail. Also, coming to security, so Google Compute Engine is a more secure and safe place for cloud applications. So now that you have a theoretical understanding of Google Compute Engine, let's practically try our hands on it. So you can just directly go to Google Cloud Platform. Just open it. First, let's go to the documents part. So in this, also you can open the console also. This one, this tab only we can open. Okay. So for support purpose, you can just go through this documentation part. Though I'm going to explain you, still if you need any support, you can go to this compute part, and here the compute engine is given. From here you can like much more understanding of Google Compute Engine. So let's come back here. We have opened the console. This is how the Google Cloud Platform dashboard looks like. You can either go from here to Compute Engine. From here we can open, or you can just search here Compute Engine. Okay. So these are the virtual machine instance templates. So these are different kind of virtual machines are given. Then we also have storage. Under that we have, just a minute, we have disks, snapshots or images. As I have told you, like there are built-in images also, and there are like custom images also. So here's the disks. These are the disks which have already been created, and then we also have snapshots. One of the snapshot is also there. So then we have images. So these are the built-in images. You can use any of them, or if you want to make your own custom type images, you can create image from here. Okay, now let's finally go to virtual machine instances and let's see how we can launch an instance. So these are the two instances which I've already created. So let's go and create a new one. Okay, so you can name your instance here, and here whatever configurations you're gonna give now, the price will change. Okay, like I can show you just for showing purpose. I'm just showing you if you change it to 4 virtual CPUs, see the price has changed, right? And again go to the small one. Okay, so you can also add label here and give it key environment. You can give testing. Okay, or you can add much more label than okay, you can add more labels like app, or you can give the value for it like app. Okay, you have to do that, and then you can like save it. Okay, then we have like, see, I'm changing the configuration, that's why the price is changing. Okay, and then we have to see the region also. Under that region and zone you have to select, and under that we have different services. Okay, like right now the under this these services are there: general purpose, compute optimized, memory optimized, and GPU. Okay, like you can see in this E2 series we have For general purpose, we have series, and we have machine types of 4 CPUs and 8 GB memory and all this like that. Then we also have compute optimized also. Under this, we have 4 CPU 16 GB, and then 8 CPUs we have 32 gig. For 16 CPUs we have 64 gig. These kinds of CPUs and memory is given. And if you come to memory optimized, these are the large ones. They are the ultra level ones. So there are like 96 CPUs and 1 4.0 TB of memory. Also 40 CPUs and 961 GB memory. And then we also have GPUs for it for different machine types. We have these kind of GPU for 24 virtual CPUs, 170 GB memory, and this weight is given. But remember that you don't get it in every region and zone. Like I can show you. Right now it is selected as US Central 1 and US Central 1A, right? And if we change it to Europe West, okay, let's see if we change it to Europe West. See, now you can see GPU is already gone. If we see for C1, now even the memory optimized is also gone. So that's how it works, okay? So let's go to the default one only, which V1, yeah, okay. Then we have boot disk also. You can change this boot disk also, like you can go to change. You can select a public image or anything. For a different one, you can use this. And then it has 07. Okay, let's go do it 50 also. We can do that. And then we can select it, okay. Or we can go to custom images. If you want to use any custom image of yours, you can use it here. If you have any snapshots taken, you can also use snapshots here. Also, if you have an existing disk or like if you have made some existing disk from a previous virtual machine, then you can use it. But right now we don't have one. Also, I've shown this, so you can select it here. Okay, you can change it again. You can just go to Debian only. Okay, Linux is selected. Balance persistent disk or SSD persistent disk, which one you can select. Give it 10 only. You can just select it. This is the default setting we have done again. And then you can come to this management security disk network household tenancy. You can just select it. Let's come to the networking part. If you already have a network tag or something, you can select it here. Also, you can change the host name or whatever host name you have created. You can give a different one also. Okay, and then we have disks. It's like if you are creating a virtual machine, you can, if you delete a virtual machine also, you can retain your disk also. There is an option here, delete boot disk when instance is deleted. So you can just deselect it. So if a virtual machine is deleted, then also a disk will be like retained. So again doing it. So let's create it. Well, I think there is a problem. There is some problem. Create virtual machine instance and its boot disk instance. Yeah, okay, they don't support. What you can do is, this is something, there are certain limitations of, I want to say, for free trial, because this is a free trial. Okay, so you can buy one, or there are certain limitations, you have to follow those limitations. So you can like simply create a default one with default settings. You can, like right now I'm not doing any customizations and everything, so you can just create that for now. So it will take a few time because I've changed some settings now, that's why it wasn't able to run. And there are certain limitations. I hope you understand. Yeah, now it's been created. Also, let me tell you this, like suppose if you have created this instance and you have working on it, you have created this on server, we have created this virtual machine, I mean, and you're working on it for a long time, you worked, and then suppose a teammate comes and he sees that and he feels like, okay, this is a lot of mess up. So he deletes the instance. Now what happens is it will be like, oh, your work is gone. All the work you have done is gone. But what you can do is, or you can go to disk only. Okay, so this is the instance too. What you can do is you can create a snapshot from here. Okay, or you can just snapshot is created, it will be created here. Okay, like another snapshot is here for instance 1. If you created for instance 2, it will be created here itself. So while creating the instance, what you can do is, if you have taken the snapshot, okay, so what you can do is from here you can change it and you can go and select a snapshot from here. Okay, like right now snapshot is given up, for instance 1 it is given. If you use it, all your work will be retained. So that's how it works. Also, you can, like, if you want to delete an instance, you can just go here and delete the instance from here. It will take a few seconds. Yeah, the instance got deleted. I hope you have understood now. This is the basic demo.
What is WordPress? WordPress is a web publishing software you can use to create a website or a blog. Technically, it could be defined as a free and open source content managing system written in PHP and paired with MySQL or MariaDB database. It can be used to not only create blogs and websites, but can also be used to create directory, forums, galleries, business website, online e-commerce website, and many more. It is the most popular website building platform in the world. Just to give you an idea about how popular WordPress is, WordPress powers about 35% of all internet websites. Bloggers, small businesses, and Fortune 500 companies use WordPress than all the options combined. Now, you do not need any coding knowledge to use WordPress. It enables you to build and manage your own full-featured website only by using your web browsers. Now, what makes WordPress so famous? To answer this, let us look at some of its features. The first feature is it is simple and easy to use. Creating content with WordPress is as simple as creating and using MS Word document. You can create posts and pages, format them easily, insert media, and with a click of a button, your content is live and on the web. And also, WordPress is available in more than 70 languages, so you can choose and create content with the language you're most comfortable with. The next feature is it is flexible. Now with WordPress, you can create various types of website like a personal blog, a website, a photo blog, a business website, a professional portfolio, a government website, a magazine, a news website, an online community, and many more. You can make your website visually pleasing using themes and extend it with plugins. With WordPress, you can also build your very own applications. The next feature is user management. WordPress uses a concept of roles, which are designed to give the site owner the ability to control what users can and cannot do within the site. The site owner can assign different roles to different set of users. Generally, WordPress has 6 predefined roles: the super admin, administrator, editor, author, contributor, and subscriber. Now, the super admin role allows a user to perform all possible capabilities or functions. The administrator manages the site, editor works with the content, author and contributor write the content, and subscriber has only the read capabilities. This lets you have a variety of contributors to your website and let others simply be a part of your community. The next feature is you can extend it with plugins. WordPress comes packed with a lot of features for every user. For every feature that is not in the WordPress core, there is a plugin directory with thousands of plugins. You can add complex galleries, social networking, forums, social media widgets, spam protection, calendars, fine-tuned controls for search engine optimizations, and forms. These were just some of the plugins which you could use with WordPress. The next feature is it has an easy theme system. You can select from thousands of themes to create a beautiful website from the theme directory. By default, WordPress comes bundled with 3 default themes, but you can upload your own themes with a few clicks. Now it only takes a few seconds for you to completely customize your website. The next feature is search engine optimization. WordPress is optimized for search engines right out of the box. If you want more fine-grained SEO controls, there are plenty of SEO plugins to choose from. Now these were just some of the features of WordPress. Now let us move on to our next topic and see the steps to host WordPress on GCP. The first step would be to sign in into your Google Cloud Console. If you're new to Google Cloud, you can just sign up for an account by providing your address and your credit or debit card details. It is a very simple process and it won't take you long. Next, after that, you have to first create a new project in the Google Cloud. You will find first project on the top left corner. From there, you can create your project. The next step is selecting a WordPress instance. For this, you have to go to the navigation menu, which is on the left-hand side, and under that, select Marketplace. Now, Google Cloud Marketplace will allow you to quickly deploy functional software packages that run on Google Cloud. Even if you're not familiar with services like Compute Engine or Google Cloud Storage, you can start up with familiar software packages without having to manually configure the software or the virtual machine, the storage or network settings. Next, you have to select your WordPress instance from the GCP Marketplace. Now, there are various deployments of WordPress in GCP. I will show you in the demo part. So in today's session, we'll select WordPress certified by Bitnami because it is quite simple and straightforward to install. You will find this under Blocks and CMS column. Next, it will ask you to configure your WordPress instance. You can make changes according to your convenience. After the configuration is done, you can simply click on Deploy, and after a few moments, your WordPress website is deployed on Google Cloud Platform. But this is not the end. Your site is only accessible via an IP address, so you'll have to map a domain to the IP address. This step is important because if somebody has to access your website, they will prefer to enter the domain name to your website rather than the IP address. You can just register for a new domain name if you do not have one and link it to your WordPress website. Next, you have to set up an SSL certificate, which stands for Secure Socket Layer. Now, this is a type of digital certificate that provides authentication for a website and enables an encrypted connection. This step is not mandatory, but it is recommended. Now let us move on to a next topic and see some of the benefits of hosting WordPress on Google Cloud Platform. The first benefit is uptime. Businesses such as big e-commerce stores, trading sites, and news sites rely heavily on optimal server uptimes. They would want their servers to be up and running always because even with a slight interruption in the service, it can cause them a lot of financial damage. But Google Cloud Engine is available for more than 99.9% of the time, so companies can be assured they won't have this problem. Next, it is simple to deploy. As I've told you in the previous topic how simple it is to deploy WordPress on the Google Cloud, I will also show you how simple it is. It also gives you complete liberty to make changes to any of your root files. With GCP hosting, you will get high performance consistently, no matter how much traffic you receive. The third benefit is reliability. Google Cloud Engine uses the same infrastructure as other Google apps like Gmail and YouTube, which means your website is hosted on the most well-maintained hardware which is controlled by Google. So you can be assured there would not be much downtime to your website. Google constantly works on improving the services so they can provide a better customer experience. The next benefit would be scalability. Google Cloud Engine servers are highly scalable and can handle unexpected traffic spikes with ease. So imagine there is a peak time and a lot of users are trying to access your website. Now, as your website is hosted on the Google Cloud, it will scale its servers up in order to match the incoming traffic. With GCP, you can also upgrade or downgrade your server size without changing the IP address. Now, these were some of the advantages of hosting your WordPress website on GCP. Let us move on to a demo part where we'll host our WordPress website on the Google Cloud Platform. So for our demo, I've logged in into a GCP account. It is very simple to create a GCP account. All you have to do is enter your debit card or your credit card detail and your address. Then you might be charged maybe 1 rupee, but even that will be refunded later. Now, as you sign in into your new account, GCP will provide you $300 free credit. Now you can use this $300 to explore Google Cloud services. You won't be charged until you choose to update, and it will be valid for 90 days. So the first step is creating a new project. So we'll go to my first project over here. I will just select a new project from here. We can name a project anything. So let us name it demo. We'll just create it. Now you can see our demo project is created. Now let us move on and select our WordPress instance. So for that, we'll go to navigation menu. Now here you have something called a marketplace. Now marketplace will allow you to quickly deploy functional software packages that run on Google Cloud. So we'll go to marketplace. Here you can see there are a few WordPress instances. But in today's session, we're going to use WordPress certified by Bitnami and Automatic. But let us take a look at WordPress Google Click to deploy. So we select this. Here you can see the overview of the instance and its details. The type of virtual machine, the version, the operating system, and the packages it contains. Here when we go to pricing, you can see how much will it cost you per month. So it will cost us 2,751 rupees per month. Now let us go back and see WordPress by Bitnami. It will be under blocks and CMS. So we'll just click on this. So here is our overview of our instance, its details, and the pricing. And you can see the pricing is 1,009 rupees. It is way more cheaper and it is very simple and straightforward to deploy. It also comes with a lot of preloaded packages which are very helpful for a WordPress website. So now we will go ahead and launch it. Now we have to configure our instance. First, we have to name our deployment. So we'll just name it WordPress demo. Next, we have to select a region. So for this, if you're using a free tier account, you should select a particular region only. If you go to the GCP free tier page, we can launch a F1 micro virtual machine for free only in this region, which is Oregon, US West 1, or Iowa, US Central 1, or South Carolina, which is US East 1. So we'll go back and we'll just select US East 1. Now you can select anything from B, C, D. These are just the zones available. We'll just select this. Next, we have to select the machine type. So for this demo, I won't be needing too much of compute capacity. Now here the default is small, with one shared virtual CPU and 1.7 GB memory. But for this demo, I'll go with micro, where I get one shared virtual CPU and 0.6 GB memory. You can select a compute capacity according to your website needs. Now the micro machine type will only cost me $5.13 per month. Next we have boot disk. The boot disk type can be either standard persistent or SSD persistent or balanced persistent. So let us just go with the standard persistent disk, and the boot disk size be 10 GB. We'll keep the networking at default itself. Next, we'll select both HTTP and HTTPS traffic from the internet. This basically means allowing network traffic to your website. This means anyone with the access of internet can visit your website. We'll accept the term and condition and just click on deploy now. You can go back and check how much would it cost you per month. For me, it would cost $5.13 per month. So just go ahead and deploy it. It will just take a few minutes for Google to deploy your WordPress website. During the process, software scripts is run, WordPress is configured, the username and password for your WordPress account is generated. Now you can see our WordPress website is successfully deployed. Now let us log into a WordPress website. We'll just click on admin URL. Our username is user. We'll just copy the password from here and we'll log in. And now we are in our WordPress website. Now let us just post something. Go to post, add new. We'll just type WordPress on GCP and we'll publish it. Now let us view our website. Here, WordPress on GCP. Now going back to our Google Cloud Platform, you will see the IP address which we used to log in will keep changing every time I restart my virtual machine. Now we have to make that static. So for that, we'll just go to navigation menu and we'll select VPC network, and from here we'll go to external IP addresses. Now the type here is ephemeral. We'll make it static. We'll just name it and we'll just reserve this. Now the IP address will be static and it won't change every time I restart my virtual machine. So this was today's demo. But after this, you still have to link a domain name to a static IP address and also set up a SSL certificate. Now, a SSL certificate is a bit of code on your web server that provides security for online communication.
What an app engine is. So let's have a little introduction to App Engine. It is a fully managed serverless platform for developing and hosting web applications at scale. You can choose from several popular languages, libraries, and frameworks to develop your apps. Then let App Engine takes care of provisioning servers and scaling your app instances based on demand. Now let's understand App Engine service provided by Google Cloud Platform, that is Google App Engine. If I talk about Google, then we all know that it provides an enormous range of tools, products, and services. In the running market, Google has scored high percentile and left a footprint in the list of world's top 4 companies. So Google App Engine, by the name only we can recognize that Google has created an app engine. The name is similar to a search engine, but its purpose is of course different. App Engine is a service and cloud computing platform employed for developing and hosting web applications. It is a platform as a service cloud computing platform that is entirely managed and utilizes inbuilt services to drive the apps. Once after downloading the SDK, that is software development kit, you can instantly start the development process, but for this, it is mandatory to use technical knowledge. If you don't know the technical terms, then there is no need to take tension, okay? As there are many IT industries in the market that are providing Google App Engine development services. App Engine lets you build highly scalable applications on a fully managed serverless platform. Also, you can scale your applications from 0 to planet scale without having to manage infrastructure, okay? Also, you can free up your developers with zero server management and zero configuration deployments. You can even stay agile with support for popular development languages and a range of developer tools with Google App Engine. Now let's look at some key features of Google App Engine. If you see the programming languages, the platform supports PHP, C, Java, Python, Go, Node.js, .NET, and Ruby applications, and apart from this, it also supports other programming languages through custom runtimes. The App Engine serves 350 plus billion requests per day. Now, if you see like how Google App Engine is actually open and flexible, so custom runtimes in Google App Engine allows you to bring any library and framework to App Engine by supplying a Docker container. So you can customize runtimes or provide your own runtime by supplying a customer Docker image or Docker file from the open source community. Then you can see like Google App Engine is actually fully managed. So Google App Engine's a fully managed environment which makes it easy to build and deploy an application that runs reliably even under heavy load and with large amounts of data, and which lets you focus on code while App Engine manages infrastructure concerns. Let's now see the architecture of Google App Engine. So this is how a simplified architecture looks like. Among the main services and structures available are Google Load Balancer, which manages the load balancing of the applications. Then we have Front-End App, which is responsible for redirecting requests for appropriate services. Then we have Memcache, that is a cache memory shared between instances of a Google App Engine, generating high speed in the availability of the information on the server. And task queues is used, which is like task queues, if you see, that is a mechanism that provides redirection of long tasks to backend servers, making front-end servers free for new users requests. In addition, Google App Engine also has static and dynamic storage solutions. The static storage solution provides the file storage service called cloud storage, whereas the dynamic storage solution provides relational database services such as Cloud SQL and no relational NoSQL such as Cloud Data Store. Now let's see the development cycle of Google App Engine. Here, if you see, test, build, and deploy is the software development kit, means SDK. So SDK is a set of software development tools that allows the creation of applications for a certain software package, software framework, hardware platform, computer system, video game console, also operating system or similar development platforms. The next one in the cycle is manage, which is an app engine administration control. And then we have upgrades, like all the upgrades are being provided for deployment to software development kit. Now let's look at the components of an application. The App Engine application is created under your Google Cloud project. When you create an application resource, the App Engine application is a top level container that includes the service, version, and instance resources that make up your app. When you create your App Engine app, all your resources are created in the region that you choose, including your app code, along with a collection of settings, credentials, and your app's metadata. Each App Engine application includes at least one service, the default service, which can hold many versions depending on your app billings status. The following diagram illustrates the hierarchy of an App Engine application running with multiple services. In the diagram, the app has two services that contain multiple versions, and two of those versions are actively running on multiple instances. So let's understand service inside is. So you can use services in App Engine to factor your large apps into logical components that can securely share App Engine features and communicate with one another. Generally, your App Engine services behave like microservices. Therefore, you can run your whole app in a single service, or you can design and deploy multiple services to run as a set of microservices. For example, an app that handles your customer request might include separate services that each handle different tasks, such as API requests from mobile devices, internal administration type requests, backend processing such as billing pipelines and data analysis. Each service in App Engine consists of the source code from your app and the corresponding App Engine configuration files. The set of files that you deploy to your service represent a single version of that service, and each time that you deploy to that service, you are creating additional versions within that same service. Then we have versions. Having multiple versions of your app within each service allows you to quickly switch between different versions of the app for rollbacks, testing, or other temporary events. You can route traffic to one or more specific versions of your app by migrating or splitting traffic. Then we have instances. So the versions within your services run on one or more instances. Okay. By default, App Engine scales your app to match the load. Your apps will scale up the number of instances that are running to provide consistent performance, or scale down to minimize idle instances and reduces costs. For more information about instances, see how instances are managed. Okay. I will explain you that in the demo. So now that you have a theoretical understanding of Google App Engine, let's implement a simple app through Google App Engine. So you can just go to Google Cloud Platform, open it. We have console and we have documents also. Open the console also. Yeah, remember that if you don't have an account on Google Cloud Platform, it's a very good platform to have your account on. Just create your account. It will ask for your some basic details of your name and phone numbers and address. And it will also ask for your credit and debit card details. It will just deduct ₹1 and that will also be refunded within a while. And free trial, you will get $300 credit for 90 days. And you can use that credit for, like, I'm showing you some exercises inside Google App Engine. You can perform those exercises using those credit. Okay. So you can just, we have opened the dashboard and let's go to the documents part. Inside this, we have to go to the compute product. Under compute, we have App Engine. So here it is. compute app engine, then go to standard environment to Python. We are going to implement a simple app of hello world using Python. Quick start. These are the table of contents for how we are going to implement the app. Okay, so inside this, the first step is you have to create a project in Google Cloud Platform. This is how the dashboard of Google Cloud Platform looks like. And you go here. This is the demo, means it's written because that's the name of my project. These are the some number of projects have been here, but you can also go to new project and create. Okay, so let's go to here. Second step is remember when you are creating the project, ensure that billing is enabled for that. Okay, then the third step is just open it from here, enable the API, open this and just enable the API. Then we just remember the next step, additional prerequisites it's not required. Okay, so yes, then we go to the hello world app. So what we have to do is we just have to go to the app engine here. Remember I explained you the application components inside which we have services, versions and instances. This is the same thing. When you create an app, the services will be provided and the versions will be created and also the instances will be created for that. So what we have to do is just open the Cloud Shell from here, activate Cloud Shell. So what we have to do is go to the documents part. Remember this, these steps are here. Download the hello world app. Yeah, how we have to implement it? You have to copy this. You have to clone a GitHub repository. Okay, inside which the hello world program is already present. So yeah, just have to clone it. So just paste it here. Just enter. Then we can go to the editor here. So yeah, we have to go to the hello world program. So we have to go to the Python doc samples. Then we have to go inside this to app engine, then to flexible, and then the hello world program. Where is yeah, hello world. Yeah, in hello world we have main.py. Yeah, this is the Python program. All the we are going to use Flask for it. So using Flask we are creating this. You don't have to code of it. We can just use it like this only. It's just a simple demo. And then we have app.yml file with all the specifics are being given here. So what you can do is you have understood the path here. Okay, so we can just go back to the terminal. The repository we have already cloned. What you can see here is that the repository is already cloned. But the thing is, when you're going to do it for the first time now, the directory won't be existing. So it will clone and it will take a little time. So it will get cloned. Okay. Mine is already showing that it already exists because I have already tried the demo here. Okay. So yeah. So what we can do is we can type here for, we have to input the path, right? So for inputting the path, we can just type ls, then cd. What was the location? Python docs, app engine. The further path will be given by again ls cd flexible. Sorry, hello world. Then we just have to deploy the app. So just give the command gcloud app deploy. Just authorize it. What happened here is it's asking for me to continue. But if you are going to do it for the first time, it will ask you to select your project. Like my project name is demo with the billing enabled. So remember that you have to, there will be a certain list of projects. So you have to select one project, and then there will be another option of you like press enter after that by selecting the project. It will ask for the region. So you have to select a region. Okay, like my region is Asia South. So you have to select your region, and then it will ask for you to continue. So you just have to type the Y here. It doesn't usually take this long, but today I think there's a little server problem. That's why it's taking this long. I hope you have understood till now the theoretical part also, and also the this implementation also till now. Remember those codes which I have told you, right? For the path one and also for the cloning one. Cloning one will be given. For the path one, you have to remember that. Okay. So you can see here, services and versions and instances are given. When you create this project, a service will be created, and yeah, this is a single service is being created. Inside that, the versions will be created. So I have created a new version in that, like this one through Cloud Shell. I have created a new version. This one it is serving right now, right? It's to a stopped. This I have already ran before. This one is ours, 2021. This 5441. This is the version we have created. Okay, so in instance, this is not showing right now, but this shows when it's get implemented now. When this app starts running, it shows all the information regarding that. Okay, so yeah, dashboard. So yeah, the service is updated. Yeah, it's almost done now. Yeah. So what you can do is, yeah, here is the link. You can just copy the link. Go to the tab. Yes, we got it. Hello world, right?
What exactly is Google Cloud Anthos? Anthos is a hybrid and multi-cloud application modernization platform. It was launched in June 2019 and can help in rapidly building hybrid and multi-cloud application without compromising on security as well as not increasing the complexity. Now, if you're wondering what Anthos can be used for, here are a few cases where you can use Anthos. Firstly, it helps in provisioning infrastructure in both cloud and on-premises as well. Next, it provides infrastructure management tooling, security, policy, and compliance solutions. It can also be used for streamlined application development, service management, and workload migration from on-premises to the cloud. Next, one of the core functionality of using Anthos is to easily deploy container-based application in a hybrid or multi-cloud environment in an easy and consistent way. Clients can choose from various deployment options such as on-premises, bare metal, Google Cloud Platform, AWS, or Kubernetes clusters. Google Cloud Anthos allows developers to focus on innovation and create new features, software, or products for the company instead of spending time on managing complex hybrid environment. This will be taken care of by Google Cloud Anthos. Now, I guess you have some idea about what Google Cloud Anthos can be used for. Now, in order to understand Google Cloud Anthos better, let us take a look at its components. Basically, Anthos is a platform composed of several technologies integrated together rather than a single product. It is powered by Kubernetes along with other technologies like Google Kubernetes Engine, Google Kubernetes Engine On-Prem, Istio, Service Mesh, and others. Now let us talk about each of these components one by one. Now the Google Kubernetes Engine and Google Kubernetes Engine On-Prem are the main computing components which enables Anthos. Now GKE is nothing but a managed environment for deploying, managing, and scaling containerized application using the Google infrastructure. Now if a company already have the data center or the IT infrastructure, they can use GKE on-prem, which will provide them all the benefits of GKE like auto updates, auto node repair, and many more. Then to connect the on-premises data centers and workloads on GCP, there is Google Cloud Interconnect. Now, Google Cloud Interconnect is a service which provides direct connectivity between on-premises data centers and the workloads on Google Cloud Platform with consistent latency and high bandwidth. Now, Google Anthos Service Mesh enables fully managed service meshes for complex microservices architecture, which would include traffic management, mesh telemetry, and securing service communications. And with Anthos Config Management, you can create configuration which will allow you to easily and consistently manage your resources globally across clouds and data centers. Next, the GKE Connect allows you to register GKE on-prem based clusters to the GCP console. This can help in securely managing the resources and workloads running on them together with the rest of the GKE clusters. This can be enabled by installing the GKE Connect agent. Organization can simultaneously migrate the virtual machine applications to Google Kubernetes Engine with Anthos Migrate. So the apps can be run and managed through GKE with Istio Service Mesh capabilities. So now I guess you have some idea about Anthos components and what is Anthos. Let us move on to the next topic and see some of the features of Google Cloud Anthos. The first feature is Google Cloud Anthos integrates security into each stage of application lifecycle, from developing to building and running. Anthos enables defense in-depth security strategies with a comprehensive portfolio of security control across all the deployment models. The next feature is it offers a fully managed service mesh with built-in visibility. Google Anthos Service Mesh unburdens the operational and the development team by empowering them to manage and secure traffic between services while monitoring, troubleshooting, and improving application performance. The next feature is it provides container orchestration and management service. Google Cloud Anthos enables you to run Kubernetes clusters anywhere in both cloud and on-premises environment. Anthos can also run on your existing virtualized infrastructure and bare metal servers without a hypervisor layer. It simplifies your application stack reduces the cost associated with licensing a hypervisor, and decreases time spent learning new skills. The next feature of Google Cloud Anthos is serverless computing. Anthos provides a flexible serverless deployment platform called Cloud Run for Anthos, which allows you to deploy your workloads to Anthos clusters running on-premises or on Google Cloud, all with the same consistent experience. Cloud Run for Anthos is powered by Native, which is an open source project that supports serverless workloads on Kubernetes. The next feature is migrating existing workloads to containers. You can use the Migrate for Anthos service that minimizes the manual effort required to move and convert existing applications into containers. With Migrate for Anthos, you can easily migrate and modernize your existing workloads to containers on a secure and managed Kubernetes service. These were some of the features of Google Cloud Anthos. Now let us move on to the next topic and see some of the benefits of using Google Cloud Anthos. The first benefit is it provides various business benefits. Now, according to a Forrester Research Anthos report, which was commissioned by Google, it was found that overall Anthos business benefits include operational efficiency, developer productivity, and security productivity. On an average, organizations saw 4.8 times return of investment within 3 years of adopting the Anthos Cloud Platform. The developers can use this platform to quickly and easily build and deploy existing container-based applications and microservices-based architectures. They can use Git compliance management and CI/CD workload for configuration as well as code using Anthos configuration management. It also supports for Google Cloud Marketplace to easily and quickly deploy functional software packages or products into clusters. The next benefits of Anthos is it provides enhanced security. Anthos protects apps with high standard for reliability, availability, and vulnerability from a security perspective. Anthos also offers a high level of control and alertness for your services' health and performance with a comprehensive view. Now, these were just some of the benefits of Google Cloud Anthos. Now, let us take a look at the pricing of Anthos. Anthos charges applies to all managed Anthos clusters and are based on the number of Anthos clusters virtual CPUs charged on an hourly basis. There are two types of pricing options for Anthos. The first one is pay-as-you-go pricing model, where you are billed for Anthos managed clusters as you use them. Now, if you want to try Google Anthos or use it infrequently, you can choose pay-as-you-go pricing model. The next type of pricing option is the subscription pricing, which provides a discounted price for a committed term. Your monthly subscription covers all Anthos deployment irrespective of environment at their respective billing rates. Any usage over your monthly subscription fees will show as an overage in your monthly bill at the pay-as-you-go price listed here. Now you can see in the image over here, there are three payment options. First one is pay-as-you-go in an hourly basis. The next one is pay-as-you-go in a monthly basis and the subscription for monthly. And you can see the rates for each virtual CPU in various deployment models, such as Google Cloud, AWS, multi-cloud, on-premises, VMware, and on-premises bare metal. The good news is if you're a new Anthos customer, you can try Anthos on Google Cloud for free up to $900 worth of usage or for a maximum of 30 days, whichever might happen earlier. Now during this trial period, you're only billed for the applicable fees and then credited at the same time for those fees up to $900. But you're still billed for the applicable infrastructure usage during the trial. This was about Google Cloud Anthos pricing. Now let us move on to the next topic and see a case study on Google Cloud Anthos. So for a case study, we'll be talking about UPC Polska. Now UPC Polska is a Polish telecommunication arm of Liberty Global Europe, which offers cable television, broadband internet, and other services to roughly 1.5 million customers in Poland. The problem they faced was they needed to balance their existing IT infrastructure, which took them 2 decades to build, with a faster and more flexible infrastructure. So when they were looking for the solution, they decided to opt for hybrid IT, which would give them the speed to market they needed, as well as maintain the existing infrastructure, which they value. Now deciding about the hybrid approach, they thought Anthos was the best solution for the company's specific needs because of the consistent experience across environment, agility enabled by modern CI/CD, and the ability to set policy and ensure security at scale. Then they partnered with Accenture and focused on the cultural and organizational element involved in rolling out a new solution. When they opted for Anthos, it provided them with the following benefits. Their various teams could focus on the core responsibility rather than infrastructure management. For example, developers could focus on writing greater codes while the operational team could use Anthos to effectively manage and run those applications anywhere. Also, the on-premises nature of the company's existing infrastructure made scaling and general maintenance difficult. By running Anthos in the data centers, the company gained the fully compliant Kubernetes experience necessary to avoid cluster orchestration and management issues, which included managing and scaling the containers. They also improved the scalability and resilience through containerized GKE clusters on Anthos. Now, this was a case study on Google Cloud Anthos. What is Google Cloud's Virtual Private Cloud? Google Cloud Virtual Private Cloud provides network functionalities to Compute Engine virtual machine instances such as Google Kubernetes Engine containers, App Engine Flexible Environment, and other Google Cloud products which are built on Compute Engine virtual machines. Basically, VPC provides networking for your cluster-based services that is global, scalable, and flexible. Now, Google VPC is quite different from the VPC of other cloud service providers. Now, in the traditional VPC or the VPC provided by other cloud service providers like AWS, the architecture would look something like this. Now, here in the first diagram, we can see that there is two VPC built with two different subnets in two different regions, which are US East and US West. Now, the virtual machine in one region can access the internet and communicate with the other virtual machine only through the VPC gateway, which acts as an interface. In the traditional VPC, one virtual machine cannot directly communicate with the other virtual machine. Now, in the Google version of the Virtual Private Cloud, it is a global construct, which means instead of creating a VPC in US West and the other one in US East region, you just create one VPC and put the subnet in different region within that VPC. Now, in this case, the virtual machine present in one region can directly communicate with the virtual machine in the other region without the help of the VPN gateway. Now, the communication between the virtual machines is handled by Google underlying network. This is the same network that Google uses for its search engine, YouTube, Gmail, and its other applications. Now, the Google version of VPC can be very helpful. Let's say for a large project, you use the traditional approach. Then you have to build multiple VPC and multiple gateways, which will be very hard to maintain and to keep a track of. Now, with Google VPC, you just have to create one VPC and a gateway and can create multiple virtual machines in multiple subnets. It is much simpler and easy to maintain. Also, if something goes wrong with the traditional network infrastructure, it would take a lot more time and cost to identify and resolve the issue. In Google VPC, there are fewer network constructs to break and troubleshoot. This would help in identifying the problem faster and solving it. Now, let us understand VPC networks. You can think of VPC network the same way as a physical network, except that is virtualized within the Google Cloud. A VPC network is a global resource that consists of a list of regional virtual subnetworks in data centers, which are called as subnets. And all these are connected by a global wide area network. Also, VPC networks are logically isolated from each other in the Google Cloud. Now, some of the functionalities offered by Google Cloud VPC networks are: it provides connectivity for your compute engine virtual machine instances, including Google Kubernetes Engine clusters, App Engine instances, and other Google Cloud products built on compute engine virtual machines. It offers built-in internal TCP UDP load balancing and proxy system for internal HTTPS load balancing. It can also help in connecting to on-premises network using Cloud VPN tunnels and Cloud Interconnect attachments. It distributes traffic from Google Cloud External Load Balancer to the backend. Now, to understand VPC network better, let us take a look at its architecture. Now, here you can see we have two regions, US West 1 and US East 1 in a VPC network. Now, a region is nothing but a specific geographical location where you can host your resources. And a region can have three or more zones. For example, US 1 region has three zones: US East 1A, US East 1B, and US East 1-3. Now, talking about zones, zones are independent of each other. They have completely separate physical infrastructure, networking, and isolated control planes. This is to ensure that typical failures event only affect that zone. Now, coming to subnets. A subnet or a subnetwork is a segmented piece of a larger network. The virtual machine instances can be created in the subnet, and the instances can communicate with each other in the same VPC network using the private IP addresses. Here you can see there are two virtual machines in US East subnet, and there are two virtual machines in US West subnet. Now, these virtual machines can access the internet through the VPC routing. VPC routing decides how to send traffic from the virtual machine instances to the destination. The destination could be either the other virtual machine instances or the internet. Moving on, let us understand a few important concepts in VPC like IP addresses, routes, and firewall rules. You will find all these concepts in Google Cloud VPC's console. So first, let us talk about IP addresses. Now, each virtual machine instances in GCP will have an internal IP address and typically an external IP address. The internal IP address is used to communicate between instances in the same VPC network, while the external IP address is used to communicate with instances in other networks or the internet. These IP addresses are ephemeral by default but can be statically assigned. Now, ephemeral means the IP address will keep changing every time the virtual machine restarts. Now, talking about the VPC routes. Route tells virtual machine instances and the VPC network how to send traffic from an instance to the destination. The destination can be either inside the network or outside of Google Cloud, which is the internet. You can also create custom static routes to direct some packets to specific destination. Now, each VPC network comes with some system-generated routes. There are two different system-generated routes. First is the default route. This route defines a path for the traffic to leave the VPC network. It provides general internet access to virtual machines that meets the requirement. It also provides the typical path for private Google access. Next, for communication within the network, there is subnet routes. It defines the path for sending traffic among instances within the network by using internal IP addresses. But for one instance to communicate with another, you must configure appropriate firewall rules because every network has an implied deny firewall rules for ingress traffic. Now, talking about firewall rules, each VPC network implements a distributed virtual firewall that you can configure. Firewall rules allow you to control which packets can travel to which destination. It lets you allow or deny connection to or from your virtual machine instances based on configuration that you specify. Now, when you're creating a VPC firewall rule, you must specify the VPC network and a set of configuration that defines what the rule does. The configuration enables you to target certain types of traffic based on the traffic protocol, destination port, sources, and destination. You can create and modify VPC firewall rules by using a Google Cloud Console, 𝐏𝐿 command line tool, and REST APIs. Now, these were some of the important topics in Google Cloud VPC. Now, let us move on to the next topic and see some of the benefits of Google Cloud VPC. First is, it is global. Using a VPC gives you managed global networking functionality for all your Google Cloud resources through subnetworks known as subnets, which are hosted on Google Cloud data centers. A single Google Cloud VPC and its subnets can span across multiple regions without ever connecting to the public internet. It remains isolated from the outside world and is not associated with any specific region or zone. Second benefit is, it is shareable. Now, an entire organization can use one VPC and share it across the various teams. Different teams can be isolated within projects with different billing and quotas, yet they can still maintain a shared private IP space and access to commonly used services. The next advantage is, it is expandable. Google Cloud VPC lets you increase the IP space of any subnet without any workload shutdown or downtime. This gives you flexibility and growth option to meet your needs. Now, I guess you have some idea about VPC. Now, let us move on to the next topic and see what is Google Cloud Load Balancer. Basically, a load balancer distributes user traffic across multiple instances of your application. By spreading the load, load balancing reduces the risk that your application experiences performance issues. Google Cloud offers 6 types of load balancer, which are external HTTPS load balancing, SSL and TCP proxy load balancing, external TCP UDP network load balancing, internal HTTPS load balancing, and internal TCP UDP network load balancing. Now, to decide which load balancer best suits your implementation, consider factors such as global and regional load balancing. You can use global load balancing when your backends are distributed across multiple regions. Your user needs access to the same application and content, and you want to provide access by using a single IP address. You can use regional load balancing when your backends are only in one region. The next factor is external and internal load balancing. Now, external load balancer distributes traffic coming from the internet to your Google Cloud VPC network. An internal load balancer distributes traffic to instances within the GCP network. And the last factor you need to keep in mind is the type of traffic that you need a load balancer to handle, such as HTTPS, TCP, or UDP traffic. Now, this was a brief information about Google Cloud Load Balancing. Let us move on to the next topic and understand what is Cloud DNS service. Google Cloud provides a scalable, reliable, and managed domain name service or DNS running on the same infrastructure as that of Google. But before we get into Cloud DNS, let us understand what DNS is. So DNS is a hierarchically distributed database that lets you store IP addresses and other data and look them up by names. In other words, DNS is a directory of easily readable domain name that translate to numerical IP addresses which are used by computers to communicate with each other. For example, when you type URL into a browser, DNS converts the URL into an IP address of a web server associated with that name. Like www.example.com is translated to IP address of 72.220.193.173. Then the DNS directories are stored and distributed around the world on domain name servers that are updated regularly. Now, Cloud DNS is a high-performance, resilient global DNS service that publishes your domain name to the global DNS in a cost-effective way. Cloud DNS lets you publish your zones and records in DNS without the burden of managing your own DNS servers and software. Cloud DNS offers both public zones and private managed DNS zones. Now, a public zone is visible to the public internet, while a private zone is visible only from one or more virtual private cloud networks that you specify. This was about Cloud DNS. Now let us move on to a demo part where I will show you how to create a VPC network in Google Cloud. So for our demo, I've logged into a GCP account. For people who are new to GCP, this is what the GCP console would look like. Now it is very simple to create a GCP account. All you have to do is enter your debit card or your credit card details and your address. Then you might be charged maybe ₹1, but even that would be refunded later. And after you sign into a new account, GCP will provide you $300 free credits. You can use this amount to explore Google Cloud services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. Now coming back to our GCP console, you can see we have the project info over here. Now you must have a project in order to use the GCP resources. And here will be the list of resources that your projects use. Here will be the billing, the monitoring dashboards. If you're new to GCP, you can explore the various services provided by Google Cloud. So demo is going to be very basic, where I will explain how to create a VPC and subnets. So the first step is to select a project. Now if you're using GCP for the first time, you can just create a new project from here. Click on new project, name your project anything you like, and just create it. Now for this demo, I'll just select from an existing project. So I'll let this be, and now let us search for VPC over here. And we'll select the VPC network. Now you can see here that Google Cloud comes with a default VPC. And this VPC has 25 subnets, each subnet having its own IP address and in a different region. As I mentioned before, GCP has 25 regions and 76 zones. So each subnet is created in 25 different zones. Next, you see something called mode over here. And you can see there are two types of mode, custom and auto. We will talk about this when we're creating a VPC. And there are 4 default firewall rules. So let us now create a new VPC. So I'll just go to create VPC network. And we can name our VPC anything we want. So I'll just name it demo VPC. And you can see only lowercase letters, numbers, and hyphens are allowed. Next, you can describe your VPC, but this is optional, so I'll just skip it. Now coming to subnets, we can create a subnet with 2 different methods. One is custom and the other one is automatic. If you select automatics, subnets are automatically created with different IPs in different regions. Now you can see in automatic, 15 subnets are created in 15 different regions. If you want, you can select any firewall rules from here. Now as I mentioned before, firewall rules allow you to control what packets can travel to which destination. Now with the demo VPC allow ICMP, it will allow only ICMP traffic from any source to any instances in a network. And with the allow internal firewall rules, it will allow connection for all protocols and ports among instances in the network. Next, the allow RDP firewall rules allows RDP connection from any source to any instances on the network using port 3389. The port is given over here. Next is the allow SSH traffic rule. This allows TCP connection from any source to any instances in the network with the destination port 22. Next, these two are the default firewall rules. And the default routing mode is set to regional. You see, Google Cloud makes it very simple for you to create a VPC. All you have to do is just name your VPC, select automatic and click on create button, and then your VPC will be created. But for this demo, we're going to select the custom subnet and create only a few subnets. So we'll just go to custom. Now we can name a subnet anything we want. We'll just name it demo VPC subnet. If you want, you can add description about your subnet. Next, we have to select a region. So these are the available regions. So we'll just select US East 1. and I have to mention the IP address range. So I'll just mention 10.0.1.0.24. Next, we have something called private Google access. This means I can set my virtual machines in the subnet to access Google services without assigning an external IP address. So I'll just on this. So now my virtual machines will be able to access Google services without an external IP address. I will let the flow logs be off. Flow logs are just to record the network flow. If you want, you can on it as well. I'm just going to click on done. Next, we can select regional or global routing mode. Regional routing will route only in the region they were created, and global routing will route to and from all the regions. So let it be default regional. Now let us create another subnet. We'll just name it demo VPC subnet 2, and the region will select US West 1. We'll give the IP range as 10.0.2.0/24. We'll let the private Google access be on and click on done. Now I'll just create my VPC. Now VPC has been created. This might take a couple of minutes. Now you can see a VPC is successfully created, and two subnets are created in US West 1 and the other one in US East 1.
Now let's have an introduction of database. First, let's understand why do we need a database. A good database is crucial to any company or organization. This is because the database stores all the pertinent details about the company, such as employee records, transactional records, salary details, etc. The various reasons a database is important are: it manages large amounts of data. A database stores and manages a large amount of data on a daily basis actually. This would not be possible using any other tools such as a spreadsheet, as they would simply not work. Second, its accuracy. A database is pretty accurate as it has all sorts of built-in constraints, checks, etc. This means that the information available in a database is guaranteed to be correct in most cases. Third, it's easy to update. So in a database, it is easy to update data using various data manipulation languages available. One of these languages is SQL. Fourth, the security of data. So databases have various methods to ensure security of data. There are user logins required before accessing a database and various access specifiers. These allow only authorized users to access the database. Fifth is data integrity. So this is ensured in databases by using various constraints for data. Data integrity in databases makes sure that the data is accurate and consistent in a database. Last one, that is easy to research database. So if you see, like, it's very easy to research and access the data in database. This is done using a data query language, which allows searching of any data in the database and performing computations on it. Now that you have understood the need of a database, let's briefly understand what actually it is. So a database is an organized collection of structured information or data typically stored electronically in a computer system. A database is usually controlled by a database management system. Together, the data and the database management system, along with the applications that are associated with them, are referred to as a database system, often shortened to just database. Data within the most common types of databases in our operation today is typically modeled in rows and columns. In a series of tables to make processing and data querying efficient, the data can then be easily accessed, managed, modified, updated, controlled, and organized. Most databases uses structured query language, means SQL, for writing and querying data. Databases are used to support internal operations of organizations and to underpin online interactions with customers and suppliers. Databases are used to hold administrative information and more specialized data such as engineering data or economic models. Examples include computerized library systems, flight reservation systems, or computerized parts inventory system, and many content management systems that store websites as collections of web pages in a database. Now that you have an overview of Google Cloud Platform as well as of a database, now let's understand the different types of GCP databases. So the first is relational databases. A relational database is a type of database that stores and provides access to data points that are related to one another. Relational databases are based on relational model, an intuitive, straightforward way of representing data in tables. In a relational database, each row in the table is a record with a unique ID called the key. Columns of the table hold attributes of the data, and each record usually has a value of each attribute, making it easy to establish the relationships among data points. In a relational database, all data is stored and accessed via relations. Relations that store data are called base relations, and in implementations are called tables. Other relations do not store data, but are computed by applying relational operations to other relations. These relations are sometimes called derived relations. In implementations, these are called views or queries. Derived relations are convenient in that they act as a single relation, even though they may grab information from several relations. Each relation or table has a primary key, this being a consequence of a relation being a set. A primary key uniquely specifies a tuple within a table. While natural attributes, I mean attributes used to describe the data being entered, are sometimes good primary keys. A foreign key is also there in a relational database management system. So a foreign key is a field in a relational data table that matches the primary key column of another table. It relates the two keys. Foreign keys need not have unique values in the referencing relation. A foreign key can be used to cross-reference tables, and it effectively uses the values of attributes in the reference relation to restrict the domain of one or more attributes in the referencing relation. Second is key value databases. So a key value database or key value store is a data storage paradigm designed for storing, retrieving, and managing associative arrays, and a data structure more commonly known today as a dictionary or hash table. Dictionaries contain a collection of objects or records which in turn have many different fields within them, each containing data. Okay, so these records are stored and retrieved using a key that uniquely identifies the record and is used to find the data within the database. So key value databases work in very different fashion from the better known relational databases. Relational databases predefine the data structure in the database as a series of tables containing fields with well-defined data types. Exposing the data types to the database program allows it to apply a number of optimizations. In contrast, key value system treats the data as a single opaque collection which may have different fields for every record. This offers considerable flexibility and more closely follows modern concepts like object-oriented programming. Because optional values are not represented by placeholders or input parameters, as in most relational databases, key value databases often use far less memory to store the same database, which can lead to large performance gains in certain workloads. Because optional values are not represented by placeholders or input parameters, as in most relational databases, key value databases often use far less memory to store the same database, which can lead to large performance gains in certain workloads performance. A lack of standardization and other issues limited key value systems to niche uses for many years. But the rapid move to cloud computing after 2010 has led to a renaissance as part of the broader NoSQL movement. Now, the third one is document database. So, a document-oriented database or document store is a computer program and data storage system designed for storing, retrieving, and managing document-oriented information, also known as semi-structured data. Document-oriented databases are one of the main categories of NoSQL databases, and the popularity of term document-oriented database has grown with the use of the term NoSQL itself. XML databases are a subclass of document-oriented databases that are optimized to work with XML documents. Graph databases are similar but add another layer, the relationship, which allows them to link documents for rapid traversal. Document-oriented databases are inherently a subclass of the key value store, another NoSQL database concept. So the difference lies in the way the data is processed. In a key value, the data is considered to be inherently opaque to the database, whereas the document-oriented system relies on internal structure in the document in order to extract metadata that the database engine uses for further optimization. Although the difference is often negligible due to tools in the systems, conceptually, the document store is designed to offer a richer experience with modern programming techniques. So, document databases contrast strongly with the traditional relational database. Like relational databases generally store data in separate tables that are defined by the programmer, and a single object may be spread across several tables. So document databases store all information for a given object in a single instance in the database, and a very stored object can be different from every other. This eliminates the need for object relational mapping while loading data in the database. So the fourth we have is in-memory database. And in-memory database, IMDB, also a main memory database system, or MMDB, you can say it like a memory resident database, is a database management system that primarily relies on main memory of a computer data storage. It is contrasted with the database management systems that employ a disk storage mechanism. So in-memory databases are faster than disk optimized databases because disk access is slower than memory access. The internal optimization algorithms are simpler and execute fewer CPU instructions. So accessing data in memory eliminates seek time when querying the data, which provides faster and more predictable performance than disk. Applications where response time is critical, such as those running telecommunication, network equipment, and mobile advertising networks, often main memory databases. So in-memory databases have gained much traction, especially in the data analytics space started in the mid 2000s, mainly due to multi-core processors that can address large memory and due to less expensive RAM. A potential technical hurdle with in-memory data storage is the volatility of RAM. So specifically in the event of a power loss, intentional or otherwise, data stored in the volatile RAM is lost. With the introduction of non-volatile random access memory technology, in-memory databases will be able to run at full speed and maintain data in the event of power failure. Now the last one is additional NoSQL databases. Like a NoSQL database provides a mechanism for storage and retrieval of data that is modeled in means other than the tabular relations used in the relational databases. So there are additional NoSQL databases present in GCP like MongoDB and others. So now that you have understood the types of databases, let's now understand services under these types of databases. So first we have is relational databases, under which we have Cloud SQL and Cloud Spanner. So Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational MySQL databases on cloud platform. The Cloud SQL for MySQL connector allows you to access data from Cloud SQL for MySQL databases within Data Studio. So its key features are like fast and easy migration. So database migration service makes it easy to migrate databases from on-premises compute engine and other cloud to Cloud SQL with minimal downtime. So second is secure access and connectivity. So Cloud SQL data is encrypted when on Google's internal networks and when stored in database tables or temporary files and backups. So Cloud SQL supports private connectivity with virtual private cloud. And every Cloud SQL instance includes a network firewall allowing you to control public network access to your database instance. Third is easy integration. So access Cloud SQL instance from just about any application. Easily connect from App Engine, Compute Engine, Google Kubernetes Engine, and your workstation. Open up analytics possibilities by using BigQuery to directly query your Cloud SQL databases. Then fourth is standard APIs. So build and deploy for the cloud faster because Cloud SQL offers standard MySQL or PostgreSQL and SQL Server databases, ensuring application compatibility. So use standard connections drivers and build migration tools to get started quickly. Then fifth is application compatibility. So build and deploy for the cloud faster because Cloud SQL offers standard MySQL or PostgreSQL and Microsoft SQL Server databases, ensuring application compatibility. Then the last one is automatic storage increment. So Cloud SQL can automatically scale up storage capacity when you are near your limit. This way you don't have to spend time estimating future storage needs or spend money on capacity until you need it. Now the question is when to choose Cloud SQL. From lift and shift of on-premise SQL databases to the cloud to handling large-scale SQL data analytics to supporting CMS data storage and scalability and deployment of microservices, Cloud SQL has many uses and is a better option when you need relational databases capabilities, but don't need storage capacity over 10 TB. I mean 10 terabytes. Now coming to Cloud Spanner. So Spanner is a distributed SQL database developed by Google. Spanner is a globally distributed database service and storage solution. It provides features such as global transactions, strongly consistent reads, and automatic multi-site replication and failover. Its key features are first, auto sharding. Cloud Spanner optimizes performance by automatically sharding the databases on request load and size of the data. As a result, you can spend less time worrying about how to scale your database and instead focus on scaling your business. So second is it is fully managed, which means easy deployment at every stage and for any size databases. Synchronous replication also synchronous replication and maintenance are automatic and built in. The third one is it has regional and multi-regional configurations. No matter where your users may be, apps backed by Cloud Spanner can read and write up-to-date, strongly consistent data globally. Additionally, when running a multi-region instance, your database is able to survive a regional failure and offers industry-leading 99.99% availability. So fourth is built on Google Cloud Network. Cloud Spanner is built on Google's dedicated network that provides low latency, security, and reliability for serving users across the globe. Fifth is it provides multi-language support. So client libraries in C, C++, Go, Java, Node.js, PHP, Python, and Ruby, JDBC drivers for connectivity with popular third-party tools. Last is backup and restore. Backup and restore recovers the database to the last state when the backup or the export was taken. PITR provides continuous data protection with the ability to recover your past data to a microsecond granularity. Now the question is when to choose Cloud Spanner. So Cloud Spanner should be your go-to option if you plan on using large amounts of data, more than 10 terabyte, and need transactional consistency. It is also a perfect choice if you wish to use sharding for higher throughput and accessibility. Now the next is a key value database, under which Google provides Bigtable service. So Bigtable is a compressed high-performance proprietary data storage system built on Google File System, Chubby Log Service, SST table, and a few other Google technologies. Some of its key features are: it is built for use cases such as personalization, edtech, fintech, digital media, and IoT. Second is it gives better prediction. Designed with a storage engine for machine learning applications, leading to better prediction. Third is high throughput at low latency. So Bigtable is ideal for storing very large amounts of data in a key value store and supports high read and write throughput at low latency for fast access to large amounts of data. Throughput scales linearly. You can increase QPS, means queries per second, by adding Bigtable nodes. So Bigtable is built with proven infrastructure that powers Google products used by billions such as search and maps. Then fourth is the cluster resizing without downtime. It scales seamlessly from thousands to millions of reads or writes per second. Bigtable throughput can be dynamically adjusted by adding or removing cluster nodes without restarting, meaning you can increase the size of a Bigtable cluster for a few hours to handle a large load, then reduce the cluster's size again, all without any downtime. Like, it's flexible and automated replication to optimize any workload. So write data once and automatically replicate where needed with eventual consistency, giving you control for high availability and isolation of read and write workloads. No manual steps needed to ensure consistency or repair data or synchronize writes and deletes. Benefit from a high availability SLA of 99.999% for instances with multi-cluster routing across 3 or more regions, 99.9% for single cluster instances. So next is it easily connect to Google Cloud services such as BigQuery or the Apache ecosystem. Last is it seamlessly scaled to match your storage needs, so no downtime during reconfiguration. Now the question is when to choose Bigtable. So Cloud Bigtable is a good option if you are using large amounts of single key data and is preferable for low latency, high throughput workloads. Moving on to the next type of services, that is document database services, under which we have Cloud Firestore and Firebase. So Cloud Firestore is a cloud-hosted NoSQL database that your iOS, Android, and web apps can access directly via native SDKs. Cloud Firestore is also available in native Node.js, Java, Python, Unity, C++, and Go SDKs in addition to REST and RPC APIs. It is a flexible, scalable database for mobile, web, app, and server development from Firebase and Google Cloud. Some of its key features are: first of all, it is serverless, which helps you in focusing on your application's development using a fully managed serverless database that effortlessly scales up or down to meet any demand with no maintenance windows or downtime. Second is live synchronization and offline mode. Built-in live synchronization and offline mode makes it easy to build multi-user collaborative applications on mobile, web, and IoT devices, including workloads consisting of live asset tracking, activity tracking, real-time analytics, media, and product catalogs, communications, social user profiles, and gaming leaderboards. Third is powerful query engine. Firestore allows you to run sophisticated ACID transactions against your document data. This gives you more flexibility in the way you structure your data. Fourth is libraries for popular languages. Focus on your application development using Firestore client-side development by libraries for web, iOS, Android, Flutter, C++, and Unity. The Firestore also supports traditional server-side development libraries using Node.js, Java, Go, Ruby, and PHP. Fifth is security. The Firestore seamlessly integrates with Firebase authentication and identity platform to enable customizable identity-based security, access controls, and enables data validation via a configuration language. So the last one is data store mode. Firestore supports the data store API. You won't need to make any changes to your existing data store apps, and you can expect the same performance characteristics and pricing with the added benefit of strong consistency. Existing cloud data store databases will be automatically upgraded to Firestore in the next year of 2022 also. So now the question is when to choose Firestore. When your focus lie on app development and you need live synchronization and offline support. Now coming to Firebase real-time database. Over the last few years, Firebase has grown to become Google's app development platform. It now has 16 products to build and grow your app. If you have used Firebase before, you know it already offer a database which is the Firebase real-time database. So the Firebase real-time database with its client SDKs and real-time capabilities is all about making app development faster and easier. Since its launch, it has been adopted by hundreds of thousands of developers, and as its adoption grew, so did usage patterns. Let's discuss some of its key features. So first of all, it provides real-time synchronization for JSON data. So developers began using the real-time database for more complex data and to build bigger apps, pushing the limits of the JSON data model and the performance of the database at scale. The Firebase real-time database is a cloud-hosted NoSQL database that lets you store and synchronize data between your users in real time. In its new update, Cloud Firestore enables you to store, synchronize, and query app data at global scale. Second is like collaborate across devices with ease. So real-time synchronization makes it easy for your users to access their data from any device, web or mobile, and it helps your users collaborate with one another. Third is build serverless apps. So real-time database ships with mobile and web SDKs, so you can build applications without the need of servers. You can also execute backend code that responds to events triggered by your database using cloud functions for Firebase. Fourth is optimized for online use. So when users go offline, the real-time database SDKs use local cache on the device to serve and store changes. When the devices come online, the local data is automatically synchronized. The last one is strong user-based security. The real-time database integrates with Firebase authentication to provide simple and intuitive authentication for developers. You can use Google's declarative security model to allow access based on user identity or with pattern matching on your data. So the use cases for Firebase real-time database involve development of applications that work across devices, advertisement optimization and personalization, and third-party payment processing. Now moving on to the next type of service, that is in-memory database services, under which Google provides memory store. So memory store reduces latency with scalable, secure, and highly available in-memory service for Redis and Memcached. Memory store automates complex tasks for open source Redis and Memcached, like enabling high availability, failover, patching, monitoring, so you can spend more time coding. Start with the lowest tier and smallest size and then grow your instance with minimal impact. Memory store for Memcached can support clusters as large as 5 terabytes, supporting millions of QPs at very low latency. So memory store for Redis instances are replicated across two zones and provide a 99.9% availability SLA. Instances are monitored constantly and with automatic failover. Applications experience minimal disruption. Some of its key features are choice of engines. So choose from the two most popular open source caching engines to build your applications. Memory Store supports both Redis and Memcached and is fully protocol compatible. Choose the right engine that fits your cost and availability requirements. Second is security. So memory store is protected from the internet using virtual private cloud networks and private IP and comes with the IAM integration, all designed to protect your data. Systems are monitored 24/7 and 365 days, ensuring your applications and data are protected. Third is it's fully managed. So provisioning, replication, failover, and patching are all automated, which drastically reduces the time you spend doing DevOps. Fourth is monitoring. So monitor your instance and set up custom alerts with cloud monitoring. You can also integrate with the open census to get more insights to client-side metrics. Fifth is it's highly available. So standard tier memory store for Redis instances provide a 99.9% availability SLA with automatic failover to ensure that your instance is highly available. You also get the same availability SLA for Memcached instances. Last is migration. So memory store is compatible with open source protocol, which makes it easy to switch your applications with no code changes. You can leverage the import and export feature to migrate your Redis and Memcached instance to Google Cloud. Now the question is when to choose a memory store. If you are using key value datasets and your main focus is transaction latency, then you can go for memory store. Now moving on to the last type of database services, that is additional NoSQL database services, under which we have MongoDB Atlas and Google Cloud Partner Services. So MongoDB is a source available cross-platform document-oriented database program classified as a NoSQL database program. MongoDB uses JSON-like documents with optional schemes, and MongoDB Atlas is the best way to deploy, manage, and grow MongoDB on Google Cloud. Engineered and run by the same engineers that build the database, Atlas incorporates best practices developed from supporting thousands of distributed deployments into an easy-to-use, fully automated service that grants you the power and freedom to focus on what really matters, building and optimizing your applications. Its key features are: first, its database operations are automated, as database operations take time, and so MongoDB Atlas lowers your stress by orchestrating the moving parts, deploying clusters in minutes, modifying them on demand with zero downtime, and taking advantage of automated patches. So the second is highly scalable. So add storage, scale up, scale out, or scale down with the push of a button or a simple API call. MongoDB Atlas allows you to easily tweak the dimensions of your deployment with no impact to your applications. Third is comprehensive disaster recovery. So MongoDB Atlas includes an optional fully managed backup service that provides continuous backups with point-in-time recovery. Query your backup snapshots and restore granular datasets in a fraction of the time. Easily restore snapshots to different projects to rapidly spin up developer or test environments. Fourth, it's highly available backed by uptime SLAs. Each cluster is distributed across the zones in a Google Cloud region, ensuring no single point of failure. Should your primary fail, MongoDB Atlas will automatically trigger the election and failover process with no manual intervention required. Production databases are backed by 99.95 uptime SLA. Fifth is global clusters. So global clusters in MongoDB Atlas allow you to deploy a geographically distributed database that provides low latency, responsive reads and writes to users anywhere with strong data placement controls to satisfy emerging regulations. And the last one is full performance visibility and optimization. So MongoDB Atlas includes optimized dashboards that highlight key historical metrics, view performance in real time, customize alerts, or dig into the details with ease. So built-in tools such as the Performance Advisor highlight flow running queries and suggest indexes to help optimize your database. Now the next we have is Google Cloud Partner Services. So you can choose Google Cloud Partner Service on the basis of regions, specialization, expertise, initiatives, and products. But why work with a Google Cloud partner? So first of all, it's flexible. So Google Cloud's global network means you can work with a Google Cloud partner that best fits your organization's needs. The second is for the knowledge purpose, like collaborate with a partner that has the right industry background to unlock your next level of business growth. And the third and the last one is experience. So have the confidence to tackle your toughest business challenges with the support of a partner with proven success. So one more thing is like Google partners are the ones you can trust actually. So partners that have certified their teams, earned expertise, and achieved specialization have the Google validated skills to help you achieve your goals. So partners are divided in three forms. So first is the specialization. So specialization is the highest technical designation a partner can earn. Partners who have achieved a specialization in a solution area have an established Google Cloud Service practice, consistent customer success, and proven technical capabilities vetted by Google and a third-party accessor. Like there is a specialization in application development, cloud migration, data analytics, data management, Internet of Things, machine learning, marketing analytics, etc. Second is expertise. So partners with the expertise designation have demonstrated proficiency and have exhibited customer success through the combination of experience in a specific industry, workload, or product. So for example, like there's an expertise in industry and expertise in Google Cloud product or technology and workload. Third is certification. So partners with teams of Google Cloud certified individuals have the validated technical knowledge and advanced skills to address your business's needs through implementing Google Cloud technologies. There are a lot of certifications like Foundational Digital Cloud Leader, Associate Cloud Engineer, Professional Cloud Architect, Professional Cloud Developer, Professional Data Engineers, and various others. Now let's look at some solutions provided by the GCP database. So the first one is database migration. Database migration is the process of selecting, preparing, extracting, and transforming data and permanently transferring it from one computer storage system to another. With Google Cloud, you can simplify your database migration at every step of your cloud journey. So migrate to Google Cloud databases to run and manage your databases at global scale while optimizing for efficiency and flexibility. There are two database migration strategies. First one is move to the same type of database. So lift and shift databases to Google Cloud using databases like Cloud SQL for MySQL, Cloud SQL for PostgreSQL, Cloud SQL for MySQL Server, Cloud Memory Store for Redis, and Cloud Bigtable, along with Google's open source partner databases like MongoDB, DataStax, Elastic, Neo4j, Influx Data, and Redis Enterprise. Database migration service for Cloud SQL can help to minimize downtime during migration. Second strategy is move to a new type of database. Whether you are moving from proprietary to open source databases or modernizing from traditional databases to scalable cloud native databases, we have a solution for you. Leverage your serverless change, data capture, and replication service data stream to synchronize data across databases, storage systems, and applications. Google's migration assessment guides and partners can help you get started. Now, moving on to the next solution, that is database modernization. So database modernization is primarily about changing applications to work around functional discrepancies between old and new databases. With Google Cloud, you can modernize underlying operational databases to make your apps more secure, reliable, scalable, and easier to manage. Our fully managed solutions reduce complexity and increase agility so you can focus on innovation. So you can upgrade the databases on which your applications are built on by being prepared for growth with quick seamless scaling, which means scale Google Cloud databases seamlessly and build cloud native apps that are prepared to handle seasonal surges or unpredictable growth. Second, move faster and focus on business value, which means enable developers to ship faster and perform less maintenance with database features like serverless management, auto scaling, and deep integrations. And the third one is build more powerful applications with Google Cloud. To transform your business with robust ecosystem of services like Google Kubernetes Engine, easily access data for analytics and AI ML with BigQuery and Google Cloud AI. So the third database solution is open source databases. An open source database allows users to create a system based on their unique requirements and business needs. It is free and can also be shared. The source code can be modified to match any user preference. So open source databases address the need to analyze data from a growing number of new applications at lower cost. With Google Cloud fully managed, open source database promote innovation without vendor lock-in or high licensing fees. Google Cloud and our partners help you deploy secure open source databases at scale without managing infrastructure. So make the most of Google Cloud's commitment to open source by first line support. So Google provide first line support for open source databases so you can manage and log support tickets from a single window. Second is simple billing. So whether you are using NoSQL or relational databases, you will only see one bill from Google Cloud. Third is a single console. You can provision and manage partner open source database services straight from your Google Cloud console. Now, the last major GCP database solution is SQL Server on Google Cloud. So SQL Server is a relational database management system developed by Microsoft. As a database server, it is a software product with the primary function of storing and retrieving data as requested by other software applications, which may run either on the same computer or on other computer across a network. Its key features are lift and shift SQL Server. So migrate your existing workloads to Cloud SQL or Cloud Server running on Compute Engine with full compatibility. SQL Server running on Google Cloud works with all of your familiar tools like SSMS and Visual Studio. Connect your existing workloads to the best of what Google Cloud has to offer. Second is reduce operational overhead. So Cloud SQL for SQL Server is a fully managed database service with a 99.95% SLA. Being fully managed includes upgrades, patching, maintenance, backups, and tuning regional availability in various virtual machine shapes with memory from 3.75 GB up to 416 GB and storage up to 30 TB for all workloads. Provide flexible scaling options to eliminate the need to pre-provision or plan capacity before you get started. Now, the last one is a live migration for underlying virtual machines. When you run SQL Server on Compute Engine, the virtual machines can live migrate between host systems without rebooting, which keeps your applications running even when host systems require maintenance. Now let's understand the methods of deploying databases on Google Cloud Platform. So GCP predominantly offers three types of reference architecture model for Google data distribution. In that, the first one is single cloud deployment. The simplest of all deployment models, one can deploy databases by creating new cloud databases on Google and or by lift and shift or pre-existing workloads. So the second is hybrid cloud deployment. These types of deployments are useful when one has applications in the cloud that needs to access on-premises databases or vice versa. There are three primary factors to be considered when deploying a hybrid model, with some data on cloud platform and some on-premises. So that's why it's been shown like a public cloud and private cloud. And so in primary factors, first one is a master database. First and foremost, you need to decide whether your master database is stored on premises or on the cloud. Once you choose the cloud, GCP resources act as a data hub for on-premises resources, whereas if you choose on-premises, your in-house resources synchronize data to the cloud for remote use or backup. Second is managed services. So available for resources in the cloud, these services comprise scalability, redundancy, and automated backups. You, however, have an option of using third-party managed services. Third is portability. So based on the type of data store you choose, the portability of your data is affected too. To ensure reliable and consistent transfer of data, you need to consider a cross-platform store such as MySQL. So the third kind of deployment is multi-cloud deployment. These types of deployments can help you effectively distribute your database and create multi fail-safes, as it enables you to combine databases deployed on Google Cloud with database services from other cloud providers, thereby giving you an advantage of a wider array of proprietary cloud features. And there are two primary factors to be considered when deploying this model. First is integration. So, ensuring that client systems can seamlessly access databases regardless of the cloud they are deployed on. For instance, use of open source client libraries to make databases smoothly available across clouds. Second is migration. So, since there are multiple cloud providers, one may need to migrate data between clouds with the help of database replication tools or export or import processes. So, Google Storage Transfer Service is one such tool to help you with database migration. Now that you have a theoretical understanding of GCP Database Services, let's now deploy a database service on Google Cloud Platform. So you can just go to search for Google Cloud Platform. Just open this link and go to the console. You can also go to the documents part and you can understand more about the database services quite briefly. But right now, because we are going to demonstrate it practically, let's go to the console. So this is how the Google Cloud Platform console looks like. Also, if you don't have an account on Google Cloud Platform, then create one. Like Google Cloud Platform is a very nice platform to have your account on. You get a free trial in it. Like you can see here, my free trial has like 4711 credits and 23 days left in it. What happens is you get a free trial of 90 days in which you get the 300 US dollars of credit. So you can use that credit like doing the exercise I'm going to explain you in this. Also, like when you create this account, it will just debit 1 rupee and it will also get refunded to you quite soon. So you just have to give your credit and debit card details also for it. Okay, so let's start. You just go to my demo. This place, this demo is just the name of my project. You have to create your own project. You can just go to new project and create your project, give it a name, and that's it. I have this demo and several other projects, so I will go with demo only. So that's the name of my project. So these are the project name, project ID, project number is given. So what I'm going to explain here today is like this database services Cloud SQL. So Google Cloud SQL service. So where I will be creating an SQL instance and also like the database also I will be creating in it and also a user account. Okay. So you can just go here and go to databases. From here you can go to SQL or you can search from here. Just you can search here SQL. So yeah, we are here. Let's go to SQL. Okay, this is like one of the instance which I have already created. So that's why it's showing like this. But when you open it for the first time, it asks for what kind of instance you want to create, like MySQL or the PostgreSQL or any other. So because I have already created one, so it's not asking me. I will just go and create the instance from here. Yeah, this page you will get. Okay, that's what I was saying from SQL Server, PostgreSQL or MySQL. Okay, so I will be creating MySQL. So you can give a name. One more thing, it should be unique. It should cannot repeat the name of an instance again and again. Okay, so give it a unique name. So I will just give database service demo. Also there should be one number. So yeah, database service demo 1. Okay. Also give the password if you want to, because right now we are just it's demo. So I will choose no password. Also choose the version from here for it. Right now I'm going with MySQL 5.7 only. Also select your region. Like I have this region nearest to you. Like I have region nearest to me is Asia South 1. Also select your zone. So we like Asia South 1. Okay. Also you can like do further customizations. So let's see the machine type. So select whichever is suitable for you. Like right now I don't require quite a high one. Like so I will go for a standard one. But like here we have like in high memory we have 4 virtual CPUs and 26 GB memory or 52 GB memory with 8 virtual CPUs and then 16 virtual CPUs and 04 GB memory. Then you can customize it by yourself also. So you can just give by yourself whatever you wanna select. Okay. But right now I will go with the standard one. So that's more than enough because the more higher the features you will choose, the more it will cost. Okay. So remember that. So I will just remember the standard virtual CPUs 3.75 GB and then you can choose SSD or HDD whatever you want to choose. So I will just choose 10 GB. It's more than enough for me right now. It was just for demo purpose. So yeah, then we can also go for connections, public, private, whatever IP is there. You can choose for that. Select that. Okay, and you can then just go to backups. Like at what time you want to get your backup. So you choose the time. Yeah, you can select the region also. That's just okay. Multi region is okay. Then For maintenance purpose, you can on which day it gets serviced, okay, for maintenance. So that's it. And also you can select your flag, labels, or whatever you want to choose, okay. So everything is done now. So let's create the instance. Okay, use lowercase letters. Okay, remember that to use the lowercase letters, okay. Also use lowercase letters, numbers, and hyphens. Start with a letter, okay. Strings are given. Keep that in mind. So let's create the instance now. So as you can see here, the instance has been created. So here it is, and here you can see the overview of it, like the things are being given. You can see here the public ID is given, and this is just the CPU utilization it's given. And now right now it's not utilizing, so it's not showing anything. So the configurations are given and everything. One more suggestion for a service account and everything is given. But one cool thing let you know about this instances, you can connect it through Cloud Shell. So just click here. So it's getting connected with Cloud Shell. So Cloud SQL Connect database. So it will show here. Just enter, authorize it. It will take some time. A few minutes it will take. Yeah, not more than that. So you can see it's asking for password, but I haven't created password, so I will just enter. But if you created the password, just enter the password and go for the next step. So now you can see the databases. So just type for it show databases. These are the databases, and if you want to create a database in it, you can just type create database demo, or you can just give test database service. Okay, so yeah, okay, just don't give hyphen or anything like that. Okay, just say create database test. Okay, yeah, so it's got features. You can just show databases, and you can see here test is being created. Okay, so now you can just exit from here. So exit. So you have to exit again. Now it will be exited from Cloud Shell. Okay, so now you can come to databases. So under database SE demo 1, that's the instance name of our SQL database. So yeah, you can see this is the name of our SQL instance, database SE demo 1. So here you can see test is also being created. Okay, and also you can come to users also. Here also default one is the root. So you can create a database from here also. Just have to click here, create database, give it a name, test 1. Okay, yeah, just create it from here. Similarly, test 1 is created. Okay, similarly you can go to users, you can create a user account with the name group 66. That's it. And give a password also, it's optional, but we can just give one. So 662, just create. So the user account will be created. Yeah, okay, that's how users and databases are being created. I hope you have understood it now, how to create it through Cloud Share and everything. That's how the instance are being created through Cloud SQL. Now, what actually is Bigtable? Let's understand that. First of all, Google Bigtable is a key value database. A key value database is a data storage paradigm designed for storing, retrieving, and managing associative arrays and a data structure more commonly known today as dictionary or hash table. So Google provides the key value database service in the form of Bigtable. It is a distributed storage system for structured data. Also, it is compressed high-performance proprietary data storage system which is built on Google File System, Chubby Log Service, XSTable, and few other Google technologies. You can see here how many of the world's leading companies are choosing Google Cloud to help them innovate faster, make smarter decisions, and collaborate from anywhere. Now, moving ahead, let's understand some of the key features of Google Bigtable. So first of all, it has high throughput at low latency. So Bigtable is ideal for storing very large amount of data in a key value store and supports high read and write throughput at low latency for fast access to large amounts of data. Throughput scales linearly. You can increase QPS, means queries per second, by adding Bigtable nodes. Bigtable is built with proven infrastructure that powers Google products used by billions such as search and maps. Second is cluster resizing without downtime. Scale seamlessly from thousands to millions of reads and writes per second. Bigtable throughput can be dynamically adjusted by adding or removing cluster nodes without restarting, meaning you can increase the size of a Bigtable cluster for a few hours to handle a large load, then reduce the cluster size again, all without any downtime. Third is flexible and automated replication to optimize any workload. Write data once and automatically replicate where needed with eventual consistency, giving you control for high availability and isolation of read and write workloads. No manual steps needed to ensure consistency, repair data, or synchronize writes and deletes. Benefit from a high availability SLA of 99.999% for instances with multi-cluster routines across 3 or more regions. Now let's understand the architecture of Cloud Bigtable. So we will understand it step by step. So first of all, you can see here like how client requests go through a front-end server, and then nodes are organized into a Cloud Bigtable cluster of a Cloud Bigtable instance. Each node in the cluster handles a subset of the requests to the cluster. And then nodes are added to increase the number of simultaneous requests to handle maximum throughput. The table is shaded into blocks of contiguous rows called tablets. Similar to H-based regions, tablets are stored on Colossus Google's file system in SS table format. An SS table is an ordered immutable map from keys to value, and both are byte strings. Tablet is associated with a specific node, like writes are stored in Colossus shared log as acknowledged. Then data is never stored in nodes themselves. Nodes have pointers to a set tablets stored on Colossus. Rebalancing tablets from one node to another is very fast. Recovery from the failure of a node is very fast. When a Cloud Bigtable node fails, no data is lost. I hope you have understand the architecture. Let's now have a look at the data model of Google Bigtable. A Bigtable is a sparse, distributed, persistent, multidimensional sorted map. The map is indexed by a row key, column key, and a timestamp. Each value in the map is an uninterpreted array of bytes. I settled on this data model after examining a variety of potential uses of a Bigtable-like system. As one concrete example that drove some of our design decisions, suppose we want to keep a copy of a large collection of web pages and related information that could be used by many different projects. Let us call this particular table the web table. In web table, we would use URLs as row keys, various aspects of web pages as column names, and store the contents of the web pages in the contents column under the timestamps when they are fetched as illustrated in the figure. So in this figure, you can see a slice of an example table that stores web pages. The row name is a reversed URL. The contents column family contains the page contents, and the anchor column family contains the text of any anchors that reference the page. Okay. CNN's home page is referenced by both the Sports Illustrated and the My Look home pages. So the row contains columns named anchor cnnsi.com and anchor mylook.cm. Each anchor cell has one version. The contents column has 3 versions at timestamps T3, T5, and T6. Now let's understand the keys in the data model. So first is row key. So the row keys in a table are arbitrary strings, currently up to 64 KB in size. Through 10 to 100 bytes is a typical size for most of the users. Every read or write of data under a single row key is atomic, regardless of the number of different columns being read or written in the row. A design decision that makes it easier for clients to reason about the system's behavior in the presence of concurrent updates to the same row. Bigtable maintains data in lexicographic order by row key. The row range for a table is dynamically partitioned. Each row range is called a tablet, which is the unit of distribution and load balancing. As a result, reads of short row ranges are efficient and typically require communication with only a smaller number of machines. Clients can exploit this property by selecting their row keys so that they get good locality for their data accesses. Then the second key is for the column family. So column keys, I mean. So column keys are grouped into set called column families, which form the basic unit of access control. All data stored in a column family is usually of the same type. We compress data in the same column family together. So a column family must be created before data can be stored under any column key in the family. After a family has been created, any column key within the family can be used. It is our intent that the number of distinct column families in a table be small, in the hundreds of at most, okay? And that families rarely change during operation. In contrast, a table may have an unbounded number of columns. A column key is named under the syntax family is to qualifier. So column family names must be printable, but qualifiers may be arbitrary strings. An example for column family for the web table is language, which stores the language in which a web page was written. We use only one column key in the language family, and it stores each web page's language ID. Another useful column family for this table is anchor. Each column key in this family represents a single anchor as shown in figure. The qualifier is the name of the referring site, the cell contents is the link text. Access control and both disk and memory accounting are performed at the column family level. In our web table example, we can see like their controls allow us to manage several different types of applications, some that add new base data, some that read the base data and create derived column families, and some that are only allowed to view existing data, and possibly not even to view all of the existing families for privacy reasons. Now, the third key is timestamps. Each cell in a Bigtable can contain multiple versions of the same data. These versions are indexed by timestamp. Bigtable timestamps are 64-bit integers. They can be assigned by Bigtable, in which case they represent real time in microseconds, or be explicitly assigned by client applications. Applications that need to avoid collisions must generate unique timestamps themselves. Different versions of cell are stored in decreasing timestamp order so that the most recent versions can be read first. To make the management of version data less onerous, we support two per column family settings that tell Bigtable to garbage collect cell versions automatically. The client can specify either that only the last n versions of a cell be kept, or that only new enough versions be kept. Example, only keep values that were written in the last 7 days. In our web table example, we set the timestamps of the crawled pages stored in the contents column to the times at which these pages versions were actually crawled. The garbage collection mechanism described above lets us keep only the most recent 3 versions of every page. Now let's understand the use cases for Cloud Bigtable. You can use Google Cloud Bigtable to store and query all of the following types of data. The first is marketing data such as purchase histories and customer preferences. Second is financial data such as transaction histories, stock prices, and currency exchange rates. Then Internet of Things data such as usage reports from energy meters and home appliances. Also the time series data such as CPU and memory usage over time for multiple servers. And last, like graph data such as information about how users are connected to one another. First, let's understand why did Google release BigQuery and why would you use it instead of a more established solution. So Google BigQuery was designed as a cloud-native data warehouse. It was built to address the needs of data-driven organizations in a cloud-first world. BigQuery is GCP's serverless, highly scalable, and cost-effective cloud data warehouse. It provides both batch and streaming modes to load data. It also allows importing data directly from certain software as a service applications using BigQuery Data Transfer Service. Second, ease of implementation. So building your own is expensive, time consuming, and difficult to scale. With BigQuery, you need to load data first and pay only for what you use. Third, it's speed. It processes billions of rows in seconds and handle real-time analysis of streaming data. Now that you have understood why we need BigQuery, let's now understand what actually it is. So BigQuery is a fully managed serverless data warehouse that enables scalable analysis over petabytes of data. It is platform as a service that supports querying using ANSI SQL. It also has built-in machine learning capabilities. So you can build and operationalize machine learning solutions with simple SQL. You can easily and securely share insights within your organizations and beyond as datasets, queries, spreadsheets, and reports. BigQuery allows organizations to capture and analyze data in real time using its powerful streaming ingestion capability so that your insights are always current, and it's free for up to 1 terabyte of data analyzed each month and 10 GB of data stored. BigQuery service manages underlying software as well as infrastructure, including scalability and high availability. Now let's look at some of the key features of BigQuery. So first of all, it's serverless. So serverless data warehousing gives you the resource you need when you need them. With BigQuery, you can focus on your data and analysis rather than operating and sizing computing resources. So second is petabyte scale. BigQuery is fast and easy to use on data of any size. With BigQuery, you will get great performance on your data while knowing you can scale seamlessly to store and analyze petabytes more without having to buy more capacity. Third is real-time analytics. So BigQuery's high-speed streaming ingestion API provides a powerful foundation for real-time analytics. BigQuery allows you to analyze what's happening now by making your latest business data immediately available for analysis. Fourth is flexible pricing models. So BigQuery enables you to choose the pricing model that best suits you. On-demand pricing lets you pay only for the storage and computation that you use. Flat rate pricing enables high volume users or enterprises to choose a stable monthly cost for analysis. Fifth is automatic high availability. Free data and compute replication in multiple locations means your data is available for query even in the case of extreme failure modes. BigQuery transparently and automatically provides durable, replicated storage and high availability with no extra charge and no additional setup. So sixth one is data encryption and security. You have full control over who has access to the data stored in BigQuery. BigQuery makes it easy to maintain strong security with fine-grained identity and access management with cloud identity and access management, and your data is always encrypted at rest and in transit. Seventh is standard SQL. So BigQuery supports a standard SQL dialect, which is ANSI 2011 complaint, reducing the need for code rewrite and allowing you to take advantage of advanced SQL features. BigQuery provides free ODBC and JDBC drivers to ensure your current application can interact with BigQuery's powerful engine. This is a savage for less knowledgeable people like me who hates learning new stuffs every day. Eighth is foundation for AI. So BigQuery provides a flexible, powerful foundation for machine learning and artificial intelligence. Besides bringing ML to your data with BigQuery ML, integrations with Cloud ML Engine and TensorFlow enable you to train powerful models on structured data. Moreover, BigQuery's ability to transform and analyze data helps you get your data in shape for machine learning. Ninth and the last one is foundations for BI, that is business intelligence. So BigQuery forms the data warehousing backbone for modern BI solutions and enables seamless data integration, transformation, analysis, visualization, and reporting with tools from Google and its technology partners. Let's now deep dive into BigQuery and have an architectural understanding of it. Under the hood, BigQuery employs a vast set of multi-tenant services driven by low-level Google infrastructure technologies like Dremel, Colossus, Jupyter, and Borg. It takes more than just a lot of hardware to make your queries run fast. BigQuery requests are powered by the Dremel query engine, which orchestrates your query by breaking it up into pieces and reassembling the results. Dremel turns your SQL query into an execution tree. The leaves of the tree it calls slots and do the heavy lifting of reading the data from Colossus and doing any computation necessary. The branches of the tree are mixers, which perform the aggregation. In between is Shuffle, which takes advantage of Google's Jupyter network to move data extremely rapidly from one place to another. The mixers and slots are all run by Borg, which doles out hardware resources. Dremel dynamically apportions slots to queries on an as-needed basis, maintaining fairness amongst multiple users who are all querying at once. A single user can get thousands of slots to run their queries. Dremel is widely used to at Google from search to ads from YouTube to Gmail, so there's great emphasis on continuously making Dremel better. BigQuery users get the benefit of continuous improvements in performance, durability, efficiency, and scalability without downtime and upgrades associated with traditional technologies. Also, BigQuery relies on Colossus, which is Google's latest generation distributed file system. Each Google data center has its own Colossus cluster, and each Colossus cluster has enough disks to get every BigQuery user thousands of dedicated disks at a time. Colossus also handles replication, recovery, and distributed management. Colossus is fast enough to allow BigQuery to provide similar performance to many in-memory databases, but leveraging much cheaper yet highly parallelized, scalable, durable, and performant infrastructure. BigQuery leverages the column input-output storage format and compression algorithm to store data in Colossus in the most optimal way for reading large amounts of structured data. Colossus allows BigQuery users to scale to dozens of petabytes in storage seamlessly without paying the penalty of attaching much more expensive compute resources, typically with most traditional databases. To give you thousands of CPU cores dedicated to processing your tasks, BigQuery takes advantage of Borg, which is Google's large-scale cluster management system. Borg clusters run on dozens of thousands of machines and hundreds of thousands of cores, So your query, which used 3300 CPUs, only used a fraction of the capacity reserved for BigQuery. And BigQuery's capacity is only a fraction of the capacity of a Borg cluster. Borg assigns server resources to jobs. The job in this case is the Dremel cluster. Machines crash, power supplies fail, network switches die, and a myriad of other problems can occur while running a large production data center. Borg routes around it, and the software layer is abstracted. At Google scale, thousands of servers will fail every single day, and Borg protects us from the failures. Someone unplugs a rack in the data center in the middle of running your query, and you will never notice the difference. Besides obvious needs for resource coordination and compute resources, big data workloads are often throttled by networking throughput. Google's Jupyter network can deliver 1 petabit per second of total bisection bandwidth, allowing us to efficiently and quickly distribute large workloads. Jupyter networking infrastructure might be the single biggest differentiator in Google Cloud Platform. It provides enough bandwidth to allow 1 lakh machines to communicate with any other machine at 10 GBs. The network bandwidth needed to run our query would use less than 0.1% of the total capacity of the system. This full duplex bandwidth means that locality within the cluster is not important. If every machine can talk to every other machine at 10 Gbps, racks don't matter. Traditional approaches to separation of storage and compute include keeping data in an object store like Google Cloud Storage or AWS S3 and loading the data on demand to virtual machines. This approach is often more efficient than co-tenant architectures like HDFS, but is subject to local virtual machine and object storage throughput limits. Jupyter allows us to bypass this process entirely and read terabytes of data in seconds directly from storage for every SQL query. In the end, these low-level infrastructure components are combined with several dozen high-level technologies, APIs, and services like Bigtable, Spanner, and Stubby to make one transparent, powerful analytics database, BigQuery. The ultimate value of BigQuery is not in the fact that it gives you incredible computing scale, it's that you are able to leverage this scale for your everyday SQL queries without ever so much as thinking about software, virtual machines, networks, and disks. BigQuery is truly a serverless database, and BigQuery's simplicity allows customers with dozens of petabytes to have a nearly identical experience as its free tier customers. Now that we have reviewed the high-level architecture of BigQuery, we now need to look at the BigQuery storage organizations and format. Let's dive right into it. In this, first let's understand BigQuery resource model. BigQuery organizes data tables into units called datasets. These datasets are scoped to your GCP project. These multiple scopes, project, dataset, and table helps you structure your information logically. You can use multiple datasets to separate tables pertaining to different analytical domains, and you can use project level scoping to isolate datasets from each other according to your business needs. So in this, the first one are projects. So projects are root namespaces for objects which contain multiple datasets, jobs, access, control lists, and IAM roles. It also control billing, users, and user privileges. Second is datasets, which is a collection of related tables or views together with labels and descriptions. It allows access control at dataset level and define location of data that is multi-regional or regional. That is like if it is multi-regional, it can have like US or European Union or any other multi-regions. And if it is just or like regional, so it can be like Asia Northeast. It specifically goes into region, right? So that's how. Then there are tables, so which are collections of columns and rows stored in managed storage and defined by a schema with strongly typed columns of values and also allow access control at table level and column level. The next is views, so which are virtual tables defined by a SQL query and it allows access control at view level. And the last one is jobs. These are actions run by BigQuery on your behalf, like load data, export data, copy data, or query data. Jobs are like executed asynchronously. The next in this we have is storage management. Now let's review how BigQuery manages the storage that holds your data. Traditional relational databases like MySQL store data row by row, means record-oriented storage. This makes them good at transactional updates and OLTP, means online transaction processing use cases. Then we have is BigQuery. BigQuery, on the other hand, uses columnar storage, where each column is stored in a separate file block. This makes BigQuery an ideal solution for OLAP, means online analytical processing use cases. You can stream data easily to BigQuery tables and update or delete existing values. BigQuery supports mutations without limits, mutations like insert, update, merge, or delete. BigQuery uses variations and advancements on columnar storage. Internally, BigQuery stores data in a proprietary column format called capacitor, which has a number of benefits for data warehouse workloads. BigQuery uses a proprietary format because the storage engine can evolve in tandem with the query engine, which takes advantage of deep knowledge of the data layout to optimize query execution. Each column in the table is stored in a separate file block, and all the columns are stored in a single capacitor file, which are compressed and encrypted on disk. BigQuery uses query access patterns to determine the optimal number of physical shards and how data is encoded. The actual persistence layer is provided by Google's distributed file system, Colossus, where data is automatically compressed, encrypted, replicated, and distributed. Colossus ensures durability using erasure encoding to store redundant chunks of data on multiple physical disks. This is all accomplished without impacting the computing power available for your queries. Separating storage from compute allows you to scale to petabytes in storage seamlessly without requiring additional expensive compute resources. There are a number of other benefits of decoupling compute and storage. You can also take advantage of long-term storage. You can load data into BigQuery at no cost because BigQuery storage costs are based on the amount of data stored, like first 10 GB is free each month, and whether storage is considered active or long-term. If you have a table or partition modified in the last 90 days, it is considered as active storage and incurs a monthly charge for data storage at BigQuery storage rates. If you have a table or partition that is not modified for 90 consecutive days, it is considered long-term storage, and the price of storage for that table automatically drops by 50% to the same cost as cloud storage nearline. Discount is applied on per table per partition basis. If you modify the data in the table, the 90 days counter resets. A best practice when optimizing costs is to keep your data in BigQuery. Rather than exporting your older data to another storage option, such as cloud storage, take advantage of BigQuery's long-term storage pricing. This means not having to delete old data or architect or data archival process. Since the data remains in BigQuery, you can also query older data using the same interface at the same cost levels with the same performance characteristics. Let's now learn how to load or ingest data into BigQuery and analyze them. There are multiple ways to load data into BigQuery depending on data sources, data formats, load methods, and use cases, such as first one as batch ingestion, second streaming ingestion, third one we can say as data transfer service. So the first one is batch ingestion. So batch ingestion involves loading large bounded data sets that don't have to be processed in real time. They are typically ingested at specific regular frequencies, and all the data arrives at once or not at all. The ingested data is then queried for creating reports or combined with other sources, including real time. BigQuery batch load jobs are free. You only pay for storing and querying the data, but not for loading the data. For batch use cases, cloud storage is the recommended place to land incoming data. It is a durable, highly available, and cost-effective object storage service. Loading from cloud storage to BigQuery supports multiple file formats like CSV, JSON, Avro, Paraquet, and ORC. Second one is streaming ingestion. So streaming ingestion supports use cases that require analyzing high volumes of continuously arriving data with near real-time dashboards and queries. Tracking mobile app events is one example of its pattern. The app itself or the servers supporting its backend could record user interactions to an event ingestion system such as Cloud Pops Up and stream them into BigQuery using data pipeline tools such as Cloud Dataflow. Or you can go serverless with Cloud Functions for low volume events. You can then analyze this data to determine overall trends such as areas of high interaction or problems and monitor error conditions in real time. BigQuery streaming ingestion allows you to stream your data into BigQuery one record at a time by using the tabledata.insertAll method. The API allows uncoordinated inserts from multiple producers. Ingested data is immediately available to query from the streaming buffer within a few seconds of the first streaming insertion. It might take up to 90 minutes for data to be available for copy and export operations, however. One of the common patterns to ingest real-time data on Google Cloud Platform is to read messages from Cloud PubSub topic using Cloud Dataflow pipeline that runs in a streaming mode and writes to BigQuery tables after the required processing is done. The best part with Cloud Dataflow pipeline is you can also reuse the same cloud for both streaming and batch processing, and Google will manage the work of starting, running, and stopping compute resources to process your pipeline in parallel. The best part with Cloud Dataflow Pipeline is you can also reuse the same code for both streaming and batch processing, and Google will manage the work of starting, running, and stopping compute resources to process your pipeline in parallel. This reference architecture, which you can see here, is like this covers use case in much detail. I hope you have understood till now, like Cloud Dataflow and Cloud PubSub, how and what is cloud storage, how it does it work for making a pipeline through Cloud Dataflow, right? So please note that you have options beyond Cloud Dataflow to stream data to BigQuery. For example, you can write streaming pipelines in Apache Spark and run on a Hadoop cluster such as Cloud Dataproc using Apache Spark BigQuery connector. You can also call the streaming API in any client library to stream data into BigQuery. Then the third one is data transfer service. The BigQuery Data Transfer Service (DTS) is a fully managed service to ingest data from Google Software as a Service apps such as Google Ads, external cloud storage providers such as Amazon S3, and transferring data from the data warehouse technologies such as Teradata and Amazon Redshift. DTS automates data movement into BigQuery on a scheduled and managed basis. DTS can be used for data backfills to recover from any outages or gaps. Think of data transfer service as an effortless data delivery service to import data from applications to BigQuery. Let's now look at the pricing criteria and models of Google's BigQuery. So BigQuery pricing has two main components. So the first is analysis pricing, which is the cost to process queries, including SQL queries, user-defined functions, scripts, and certain data manipulation languages and data definition language statements that scan tables. Second is storage pricing, which is the cost to store data that you load into BigQuery. Each project that you create has a billing account attached to it. Any charges incurred by BigQuery jobs run in the project are billed to the attached billing account. BigQuery storage charges are also billed to the attached billing account. You can view BigQuery costs and trends by using the Cloud Billing Reports page in the Cloud Console. So let's discuss the first one, that is analysis pricing models. BigQuery offers a choice of two pricing submodels for running queries under this model. So the first one in this is on-demand pricing. With this pricing model, you are charged for the number of bytes processed by each query. The first 1 terabyte of the query data processed per month is free. Second is flat rate pricing. With this pricing model, you purchase slots, which are virtual CPUs. When you buy slots, you are buying dedicated processing capacity that you can use to run queries. Slots are available in the following commitments plans. Like flex slots, you commit to an initial 60 seconds. Second is monthly plan, you commit to an initial 30 days. Then there's annual plan where you commit to 365 days. With monthly and annual plans, you receive a lower price in exchange for a longer term capacity commitment. You can combine both models to fit your needs. With on demand pricing, you pay for what you use. However, your queries run using a shared tool of slots, so performance can vary. With flat rate pricing, you purchase guaranteed capacity with a discounted price for a longer term commitment. Let's briefly understand the first one, that is on-demand analysis pricing. So by default, queries are built using the on-demand pricing model. With on-demand pricing, BigQuery charges for the number of bytes processed. You are charged for the number of bytes processed, whether the data is stored in BigQuery or in an external data source such as cloud storage, Drive, or Cloud Bigtable. On-demand pricing is based solely on usage. So this is how the on-demand pricing structure looks like. You can see like queries on demand are there. Then they are charged for $5 per TB. The first 1 TB month is free. And if you pay in a currency other than like US dollars, the price is listed in your currency on cloud platform SKUs apply. Like here you can see the SKUs, like how you need to choose your currency, and you can filter it by product SKU name or SKU ID or service region or service. Okay. Now let's discuss the second one briefly, that is flat rate pricing, which is also available for high volume customers that prefer a stable monthly cost. BigQuery offers flat rate pricing for customers who prefer a stable cost for queries rather than paying the on-demand price per terabyte of data processed. To enable flat rate pricing, use BigQuery reservations. When you enroll in flat rate pricing, you purchase dedicated query processing capacity measured in BigQuery slots. Your queries consume the capacity and you are not billed for bytes processed. If your capacity demands exceeded your committed capacity, BigQuery will queue up slots and you will not be charged additional fees. So there are flex slots which have like short-term commitments. So flex slots are spatial commitment type. So commitment duration is only 60 seconds. You can cancel flex slots anytime thereafter. You are charged only for the seconds your commitment was deployed. So flex slots are subjects to capacity availability. When you attempt to purchase flex slots, success of this purchase is not guaranteed. However, once your commitment purchase is successful, your capacity is guaranteed until you cancel it. The following table shows the cost of a flex slot commitment. Here you can see like how it hourly cost. You can see like $4 for number of slots 100 and monthly charge is 2920 US dollars based on average of 730 hours per month. Then there are monthly flat rate commitments. Following table shows the cost of your monthly slot commitment. You can see like $2,000 it is given for 100 slots. Then there's also annual flat rate commitments. The following table you can see here, which shows the cost of your annual slot commitment. With you can see like monthly cost, it's $1,700 only for number of slots 100. All this for US and it's for multi-region. Okay. Let's now move on to the second major pricing category, that is storage pricing. So storage pricing is the cost to store data that you load into BigQuery. You pay for active storage and long-term storage. So active storage includes any table or table partition that has been modified in the last 90 days. And long-term storage includes any table or table partition that has not been modified for 90 consecutive days. The price for storage for that table automatically drops by approximately 50%. There is no difference in performance, durability, or availability between active and long-term storage. Here you can see like the first 10 GB of storage per month is free, and operation you can select like if it's active storage or long-term storage. Then pricing is given for like per GB pricing is given. Like you can see for active storage it is $0.020 per GB, and for long-term storage it is $0.010 per GB. So that's how you can see like for long-term like how the price is saved. And in both of them you can see like the first 10 GB is free each month. Now that you have a theoretical and architectural understanding of Google BigQuery service, let's now see a practical implementation it by trying our hands on running it on Google Cloud Platform. So you can just go to Google Cloud Platform console. We are at console now. So I already have a Google Cloud Platform account. So if you don't have one, create one. It's a very good platform to have your account on. Also, you have to give your credit or debit card details. It will debit 1 rupee and that will also be refunded instantly. And you will get $300 free credit for 90 days. And you can use that credit for like the demo I'm showing you, you can use for that also, and for using various other services on Google Cloud Platform. You can see like my free trial is over, but it's still like what the demo I'm going to show you, it doesn't cost anything. So yeah, let's start. So we can go to BigQuery. So Google BigQuery, with you will find it under Big Data Services. So let's see Big Data. Yeah, here's Big Data, and this is BigQuery. Let's open it. So what you have to do is you have to create a data set. So you can just click here, and you can create a data set from here. That's a project name you can say, and under that we are creating a data set. So you can give a name for data set like dataset ID. So you can give it like demo underscore BigQuery. Create dataset, and then create a table in it. Yeah, here's the option. Click on this dataset created, then create table. So by clicking here, so yeah, everything is given. This project name, dataset name, project name. Yeah, this project name is different. Okay, I will show you just a second. So this is the first step. I have to create a project from here, and it's a Google Cloud Platform project. Like I have demo name project. I have different other projects also. You can create a new project from here. Okay, then only start with BigQuery. Okay, so you can create table under the dataset. So this is the project name demo, and then dataset name demo underscore BQ means BigQuery. Then the table name we can give like what we are going to do today is we are going to import a public dataset named Stack Overflow. I hope you might be knowing about this Stack Overflow website, which have all the technologies, like the questions are posted and answers are given to that, like people do engage in that. So what we are going to find out is in last decade, like which technology has been posted the most, means the questions are being posted the most related to which technology. Okay, so you can just give it a name, table name like top underscore. We are going to find the top 10 technologies. So top underscore 10 underscore tech. We can give create a table in it. So yeah, table is being created. So here it is. Inside the project we have demo. In the demo we have top 10 technologies. Okay. Now what we have to do is we have to add data. So we can go here, add data. You can pin a project or you can insert a data set if you have an external data set, a very big, like very small or big, it depends on you. Okay, what kind of data set you want to work. But right now we are going with public data set, so we can just import a public data set. There are various data sets provided here, you can see. So you can see the latest one is about the COVID-19 public data set, where you have all the information about the patients and how the cases are increasing and how the infected cases are increasing, or if they are going down, whatever the analytics is there regarding all the statistics and analytics, whatever is provided with the data of the COVID-19, all those are provided here. In which state or which country wise, all those data are provided here. Okay. So, but we are going with Stack Overflow, so we will just type here Stack Overflow. Yeah, here it is. So you can see the whole overview is given, like what Stack Overflow is the largest online community for programmers to learn, share their knowledge and advance their careers. We know all these things. Okay. Then there are samples, like here are many examples of SQL queries you can run on the data. These are just the samples which are given, the questions posted and the answer, and all these things are there. Now we have to do is view the data set. It will take us to another BigQuery window, back to the query page. So yeah, so we are here now. The data set is being imported. Stack Overflow is here. So we can just go into Stack Overflow, and if you open it, there are certain tables are there, like badges, commands, post links. There are multiple tables are there, but we have to go for the questions, like how many times the questions is posted. So we will choose this table name, post questions. So as you open this, let's extend this a little. Yeah. So if you see this, first of all, the schema will be shown for the table. Like you can see, like the features are given, like the column names, you can say column names of features, you can say it. So all these features are given, and their data types are given, and they are like nullable or it's not nullable. Everything is given. Okay. Then there are the details of the data set. You can see like the size of the data set is like really huge. It's not small in any sense. 33.14 GB is a lot. And there are, like you can see, number of rows, like 20 million rows are there. Then you can see the date for it, like date it's got created on, last modified, and every data location, everything is given here. And then you can see the preview also. What does these column features name actually? Okay. So just a second. Previous slide. So you can see everything is given, body and everything, like except answer ID, comment account. These are all the features. Okay, the column names. But the most important is the text. So we have this text. You can see the data explorer. The view count for data explorer keyword is 2. So in that way, we have to write a query for it to find out the top 10 technologies. Okay. So let's start. So what we have to do is we have to query the table first. Now what we have to do is we have to select. So let's split tags. We have to split first the tags. So working on this tag column, so we have to split the tags from query probability. All this limit we can remove from here. 10,000 limit is given, so that we can remove. And then we can give, like, from where we have to extract it. So like if there is any date column is given, so because we are finding for the last decade, right? So we find from the creation date. Okay, there is this creation date, so we have to extract from the year. We want to extract only the from the year, so we are just choosing the year here. Here from creation date we are extracting creation date. We have to give the flattened text also, so we have to select the flattened text. So you can choose it from here, select tags, and then we can choose the tag count. So tag underscore count, and then we will join it below. Okay, from creation date we have to give, so that's the problem. Now it won't be flattened tags. Now we can just cross join it. So cross join, you can use the unnest for it. So you join the text with flattened joins, so that works out like a self join, you can say. So tags can group by flattened text, so we have to group by, and then we have to order by tag count.
in descending because we need the keyword with the technology name with the maximum count, so that will come first if we order by descending order. So descending, then we'll limit it to 10 because we want the top 10, right? So limit 10. Now it can be done. So the query will process 703.9 MB it is showing, so we can just run the query. Now you can see all the queries are here now, like all the technologies are given. So you can see like the JavaScript is topping the list. So then there's Java, then there's Python. You can see like there are 21. So you can see like 21 means I would say like 2.1 million counts are there, tag counts are there. CSS at 10, C++ at 9. Last decade you can see their tag counts, like how many times they are searched. So we are successful here. Now we can see the job information is given, everything is given. So what we can do is we can just save this, save results. Okay, you have to save this in a table, like the table we have created. You can also save it as CSV or JSON file and everything like Google Sheets also, but we will save it as BigQuery table. So table name was job underscore 10 underscore tech, saved as a table. So now you can see like job history one running to show the job history, like it has been created, the table has been created, like the result is being saved as a table, so that table has been successful. So now we can see if you go here the project, we have this data set, then we have this tag. Yeah, so you can see the details for it, like patent tax and tag count are there in the table. Then we can see the details like 148 byte, it takes the total space, table size. Then preview, if you see like this table is saved here. Okay, before saving the view, let's understand this. Like you can also share this table, or you can copy the table and delete table, or you can like export it to Data Studio, like export with Data Studio, and also you can like export it to Google Cloud Storage also. All these things you can do, and then you can like save view also. If you save this view, like it shows on the view like how the table is working and how output it shows, everything that can be done. And then you can schedule the query how you want to run it, weekly or daily or monthly, however you want to schedule it. You can schedule it that way. Okay, and then there is like you can also do the query settings. So query engine you can choose for it, like Cloud Data Flow, BigQuery engine. And also if you are like querying it and if you forgot to save it, yeah, it can get saved in a template table. That template table you can create it from here. Okay, you can see here in that after this, like all these things have been there, job priority, everything, and destination table with preference, all the things you can choose. One more cool feature I want to show you, and that can show you only if I run the query again. So let's run this query again. So come down to execution details. What you can see here is how your queries are further split into multiple queries to get the results. So first thing is you can say these are like the working nodes, which is like a different concept of another different concept of Hadoop file system or Google file system to discuss about. But that's how it divides into multiple queries. So here you can see like first how it's wait, read, and compute and write, everything is being divided. And then you can see like first thing was like there are 20 million rows. Okay, first step in input. And then when it comes to sorting, it decreases down to 20 million to it decreases down to 2 million rows. And then finally when the output comes, you can see it been reduced down to 130. Okay, in the final stage when you have ordered by descending order everything, and when you limit it to 10, it comes down to top 10 technologies, right? So this is how it's been done. I hope you have understood it now. You can see how everything it provides at the dashboard. Only everything is, every service, it doesn't take time. That's the thing about BigQuery, that it's very fast. Let's now understand some of the use cases for BigQuery. So the first one is migrating data warehouses to BigQuery. So you can like solve for today's analytics demands and seamlessly scale your business by moving to Google Cloud's modern data warehouse. Streamline also, you can like streamline in the sense you can also streamline migration path from Netezza or Oracle Redshift, Teradata or Snowflake to BigQuery and accelerate your time to insights. You can like also streamline your migration path from Netezza, Oracle, Redshift, Teradata, or Snowflake to BigQuery and accelerate your time to insights. And the second use case is predictive analytics. So predictive analytics helps you predict future outcomes more accurately and discover opportunities in your business. So the Google's smart analytics means BigQuery's Google BigQuery's smart analytics reference patterns are designed to reduce time to value for common analytics use cases with small code and technical reference guides. You can like learn how BigQuery and BigQuery machine learning can help you build an e-commerce recommendation system, but also like predict customers and lifetime value and design propensity to purchase solutions.
Also, you can bring any data into BigQuery, make analytics easier by bringing together data from multiple sources in BigQuery for seamless analysis. You can upload data files from local sources, Google Drive or cloud storage buckets, take advantages of BigQuery data transfer service, data fusion plugins, or you can say like leverage Google's industry leading data integration partnerships. You have ultimate flexibility in how you bring data into your data warehouse. Let's now see a case study for Google BigQuery. It's the final topic we are discussing. Then we will wrap up. So, Safari Books Online uses BigQuery to solve a few key challenges, like building detailed business dashboards to spot trends and manage abuse, improve sales team effectiveness through sales intelligence, and enable ad hoc querying to answer specific business questions. So all these things we will understand step by step. So what they did is, means the Safari, what they did is they choose BigQuery over other technologies because of the speed of querying using a familiar SQL-like language and the lack of required maintenance. So Safari Books Online has a large and diverse customer base, constantly searching for accessing a growing library of over 30,000 books and videos from an increasing array of the desktop and mobile devices. This activity stream contains powerful knowledge which we can use to improve our services and increase profitability. Locked up in the mountains of usage data are trends such as top users, top titles, and connecting the dots for sales inquiries. Safari's usage data was much too massive to query online in its entirety with the previous toolset. Analysis could be done with the third-party web analytics tools such as 𝐿nature, but those tools lacked the ability to query and explore record-level data in real time. In addition, they didn't have a great backend for developing visualizations. SQL-like querying had to be done on smaller chunks of the data and was labor-intensive and slow. They were impatient waiting for MySQL queries to finish and were often in doubt or as to like whether or not they should finish at all. Once you reach a database client timeouts of 10 minutes, you are in the realm of not being able to do like ad hoc analysis. Answering operational questions can be like time sensitive, so speed is important. Of course, it's very important. So we played with Hadoop, but we in the sense, I mean, Safari organization has actually like played with Hadoop, but it proved to take a lot of resources to maintain. So they ended up putting it on the back burner for future projects. Then they learned about Google BigQuery through a video from Google Input and Output determined it seemed perfect for their use case, so they decided to try it out. So first step is like you can see here this diagram. This tells you how Safari get the data into BigQuery. So no matter what database platform you use, the extract, transform, load step can be a challenge depending on your data sources. BigQuery is no exception, I would say. Then this diagram shows an overview of how the data flowed through the landing and ETL servers leading up to BigQuery. The usage data comes from content delivery networks, means CDN, and web application server logs. This data was packaged into time-based batched chunks automatically copied into a landing directory. It needed some transformation to load into BigQuery in a format where we could get the most use out of it. Here are the basic steps Safari went through. So it got a list of all source files they have previously loaded into BigQuery. Then validate the list of source files waiting to be loaded into BigQuery, then transform the files and copy the files to BigQuery cloud storage, then load the files into BigQuery, and finally using the data once it is in BigQuery. So BigQuery proved to be a good platform for dashboard data and offers the capability of drilling into the data in the dashboard further with the BigQuery browser based UI for ad hoc analysis. So here you can see like his dashboard used internally by Safari's operations team to monitor top users. If anything raises any questions, you can get more information about a user, a title, an IP address by querying with the BigQuery browser tool. Now you can see here the dashboard Safari uses internally to keep an eye on trending top titles. Again, if anything raises any questions in the dashboard, BigQuery can answer them for you. The data is fed to these dashboards by an intermediary scheduled job which is executed via cron. This script queries BigQuery with the BigQuery command line tool, gets the result in JSON, and then contacts some other web services to get more information which is not stored in BigQuery, such as the user data and book thumbnail images. Then it is all matched up and presented in the dashboard. This is a good pattern as you wouldn't want to query BigQuery every time the dashboard was loaded as it could get expensive. It is best to do the analytical heavy lifting with BigQuery, then store the results in something like a cheap LAMP stack for mass consumption. And then the second advantage that Safari got through BigQuery is sales intelligence, which is another use case BigQuery was great for. scouring Safari's web logs for leads which came into their sales department. This allowed them to relate a lead to other accounts in their system or gauge the level of interest someone may have in Safari by the number of previous books they had read in the past month on their site. Lead is created in Safari's CRM system, and the BigQuery asynchronously searches through its logs like this. So you can see this in query, like you can see this query written. So the result is written quickly and reattached to the lead recorded, allowing Safari's sales department to gain intelligence and contact the lead without having to wait around the information. This gives them a nice summary of the users. The IP address of the lead has done. While IP address are not perfect identifiers, they are much better than nothing. You can see someone from this leads ID. You can see in usage history this how it is given. So you can see someone from the leads IP address has anonymously viewed user ID 0 to 32 pages of our books, and some other users who have accounts with Safari already are active on that IP. Rather than use the BigQuery command line interface, this use case was better suited for server to server, or we can say auth with OAuth, which is like the authorization tool Google uses. So with the Google API's client library for PHP, this enabled them to create web service which matches up with data from different sources and returns the result to their CRM. One of those sources is BigQuery. One amazing testament to the speed of BigQuery is that I didn't even have to implement the web service asynchronously. It returns the results from BigQuery within the timeout period of the web service that the CRM requests. Other use case of Safari which they took advantage of through using BigQuery is pure ad hoc querying, which aren't driven by dashboards but rather specific business questions. When Safari released the Android apps, it was easy to run a query on our usage data, so on Safari's usage data, to see the Android page grouped by day. In the Google BigQuery browser tool, it was easy to export the query results as a CSV file and load them into Google spreadsheets to make a chart. So you can see here how this shows when they release their Android apps. This is the graph, and then here's an example of looking at their top users by number searches during a particular hour of the day. There really is no limit to the kinds of insights you can gain from investigating your data. From an ad hoc perspective, there is a huge sense of power being able to answer any question about your billions of rows and data in seconds. For example, you can find out if that strange traffic on your site is a forum spam bot or a malicious user. As recommended by Google, they divided their data up into years. You can see this in the table. Normally, this would be a bit of an inconvenience to have to do a union statement between the tables, but BigQuery has a nice shortcut for this. So you can give this shortcut, and what it will do is it will create a union between the tables. So they just tag on as many years back as they need to go into their time shaded tables and union them together, since they have made their schemas the same. At the end of each year, they archive of active tables and start a new one. This is the best of both worlds, as it provides the accessibility of having all your data in one big table. With the performance of having them separate as they grow, it will make sense to further share the data into monthly increments instead of yearly. Now, the summary of this case study is like Safari generated meaningful knowledge out of a massive amounts of data in a timely manner, which is a challenge for Safari Books Online, like many businesses needed to solve. Being able to keep on top of trends as they happen while you can still do something about them instead of month after the fact is very valuable. This leads to lower abuse problems and top line revenue increases by gathering marketing intelligence on trending topics and collecting lead intelligence to close sales more effectively. So that was a summary of case study.
What is Google Kubernetes Engine? Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized application using the Google infrastructure. The GKE environment consists of multiple machines, specifically compute engine instances, which are grouped together to form a cluster. Now, a cluster is the foundation of Google Kubernetes Engine. The Kubernetes objects that represent your containerized application all run on top of your cluster. Now, to understand GKE better, let us understand its architecture and its working. As you know, all Kubernetes objects that represent your containerized application run on top of a cluster. It is a foundation of GKE. A cluster consists of at least one control plane and multiple worker machines called nodes. These control plane and node machines run on Kubernetes cluster orchestration system. The control plane runs the control plane processes, including the Kubernetes API servers, scheduler, and core resource controllers. The control plane is responsible for deciding what runs on each and every node. This can include scheduling workloads like containerized applications and managing the workload's lifecycle, scaling, and upgrades. The control plane also manages network and storage resources for those workloads. Now all the interaction with the clusters are done via Kubernetes API calls, and the control plane runs the Kubernetes API server processes to handle those requests. You can make Kubernetes API calls directly via HTTP/gRPC or indirectly by running commands from the Kubernetes command line client, that is 𝐄𝐝𝐶TL, or interacting with the UI in the Cloud Console. Now coming to the nodes. Now nodes are the worker machines that run your containerized application, which is your containers and other workloads. They run the services that are necessary to support the containers running in your workloads. Each node is managed from the control plane, which receives update on each node's self-reported status. Next, we have something called the user pods. Now pods are the most basic and smallest deployment object in Kubernetes. It can contain one or more containers. So now when the pod runs multiple containers, the containers are managed as a single entity, and it shares the pod's resources such as networking and storage. They're connected to various GCP services such as VPC networking, persistent disk, load balancer, and other cloud operations. This was the architecture of GKE. Now let us understand its working. GKE works with containerized applications. These containers, whether for application or batch jobs, are collectively called as workloads. And before you deploy these workloads on GKE, you must first package it into a container. Now to create a continuous integration and continuous delivery pipeline, you can use Cloud Code to write your application, then send the code to a repository which launches a build process in Cloud Build. This build process builds container images from a variety of source code repository. These container images are stored in container registry and are ready to be deployed in the Google Kubernetes engine. You can then create a GKE cluster using Cloud Console UI, gcloud command line interface, or the APIs. After this, with a few clicks, you can deploy your application on GKE. Now I guess you have some idea about Google Kubernetes engine. Now let us move on to the next topic and see some of the advantage of Google Kubernetes engine. With Google Kubernetes engine, you gain the benefits of advanced cluster management features that Google Cloud provides. First is load balancing for compute engine instance. Google Cloud offers server-side load balancing so you can distribute incoming traffic across multiple virtual machine instances. Load balancer can scale your application, support heavy traffic, detect and automatically remove unhealthy virtual machine instances using health checks, and route traffic to the closest virtual machine. This is a managed service, which means its components are redundant and highly available. So if a load balancing component fails, it is restarted or replaced automatically and immediately. The next benefit is auto scaling. GKE's cluster autoscaler automatically resizes the number of nodes in a given node pool based on the demand of your workloads. You don't need to manually add or remove nodes or over-provision your node pools. Instead, you specify a minimum and maximum size for the node pool, and the rest is automatic. The next benefit is auto updating. Auto updates will help you keep the nodes in your cluster up to date with the cluster control plane version when your control plane is updated. With auto update, you don't have to manually track and update your nodes when the control plane is updated on your behalf. It also provides better security by automatically ensuring that security updates are applied and kept up to date with the latest Kubernetes features. The next benefit is monitoring and logging. Google Kubernetes engine includes native integration with cloud monitoring and cloud logging. When you create a GKE cluster running on the Google Cloud, cloud operations for GKE is enabled by default and provides a monitoring dashboard specifically tailored for Kubernetes. With cloud operations for GKE, you can control whether or not cloud logging collects application logs. You also have the option to disable the cloud monitoring and cloud logging integration altogether. These were some of the benefits of Google Kubernetes engine. Now let us move on to a demo part and see how to deploy a containerized application on Google Cloud Platform. So in a demo, we are going to package a sample web application into a Docker container image and then run that container image on a GKE cluster. So for that, I've logged in into a GCP account. Now it is very simple to create a new GCP account. All you have to do is enter your debit card or credit card detail and give your address. Then you might be charged maybe ₹1 for it, but even that will be refunded later. Now as you sign into a new account, GCP will provide you $300 of free credit. You can use this amount to explore Google Cloud Services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. So first, let us create a new project. So we'll just go here, select a new project. We can name a project anything we want. So we'll just name it Kubernetes. Let the rest be same and we'll just create it. Now our project is created. We'll just select it. So for our demo, we're going to use Cloud Shell. Now Cloud Shell is an online development and operational environment. It can be accessed from anywhere with the browser. The reason we're using Cloud Shell is we do not have to install any command line tools for our demo. So we'll just click on Activate Cloud Shell over here. Then you can see a Cloud Shell terminal which is being created at the bottom of your screen. So the first step, as I've mentioned before, is to build a container image. For this tutorial, we're going to deploy a sample web application called 𝐿𝐿𝐴pp, which is a web server written in Go programming language. It responds to all requests with the message Hello World on port 8080. But before we deploy the 𝐿𝐿𝐴pp to GKE, we must package the 𝐿𝐿𝐴pp source code as a Docker image, and to do that, we need the source code and the Docker file. Now the Docker file contains information about how the image is built. So first, let us download the source code and Docker file for the 𝐿𝐿𝐴pp application. Git clone https github.com Google Cloud Platform Kubernetes engine samples. So the 𝐿𝐿𝐴pp application is available in this website. So we've just mentioned the website URL over here. Just click on enter. So it says that the directory already exists. So we get a message saying the directory already exists. So we'll just change the directory. Next, we have to set the project ID environment variable to the Google Cloud project ID. You can find the project ID over here. But I guess my project ID is the project ID environment variable. So let's just confirm it. So for that, we'll just type echo $. Next, you have to set project ID environment variable to your Google Cloud project ID. So for that, you have to type export project ID is equal to, you can find your project ID over here. So you can just copy it from here and paste it over here. The project ID variable associates the container image with your project's container registry. Now to confirm a project ID, we'll just type echo $project ID. Here you can see this is a project ID. After confirming the project ID, it is time to build Docker image for the 𝐿𝐿𝐴pp. So for that, we'll type docker build space -t space gcr.io/$ project ID /𝐿𝐿𝐴pp version 1. Now this is the name given to a Docker image, and GRE refers to the container registry. Oh, we just forgot one more thing over here. That is space a dot. Now it will ask you to authorize Cloud Shell. You can just select authorize over here. Now you can see a Docker image is being created. We'll just extend this. Now you can see our Docker image was successfully built. Now to just confirm if a Docker image was built, we'll just type Docker images. Now you can see a Docker image is built. It was created a minute ago and the size of it. After this, we have to push our Docker image to the container registry so GKE clusters can download it and run the container image. So for this, we are going to enable the container registry API. We'll just type gcloud services enable container registry dot googleapis.com. Next, we have to authenticate to container registry by configuring the Docker command line tool. For that, we're going to type gcloud authenticate configure docker. Now this is just a warning message saying that we have a lot of credential and it might be slow. So now we have authenticated our container registry. Now we have to push the Docker image to the container registry. So for that, we're going to type docker push the name of our Docker image. Now a Docker image is being built in the container registry. Now you can see a Docker image is pushed to our container registry. Now the next step is to create a Google Kubernetes engine cluster. So for this, we're just going to minimize it and just go to Kubernetes. You can either select Kubernetes engine from here, or you can just type Kubernetes over here. Kubernetes engine. We'll just click on enable over here. Now this might take a couple of seconds. You can scroll down and read an overview about it. You can read about Google and the various other products which are offered by them. Now this is what the Google Kubernetes engine console would look like. So it will ask us to first create a Kubernetes cluster. So we'll just go ahead and create one. Now we have two options over here. One is standard and the other one is autopilot. In standard, you manage your cluster's underlying infrastructure, which will give you node configuration flexibility. And in autopilot, GKE provisions and manages the cluster's underlying infrastructure. So we'll just go with standard over here and click on configure. So we can name our cluster whatever we want. We'll just name it cluster hello app. You can select any zone from here. These are the available zones. So we'll just select maybe US West one. Now you can select the zone which is nearest to you. You can select the version. We'll just go to static version and just create a cluster. Now creating a cluster might take a couple of minutes. So we'll wait for some time and refresh it to see if it is created or not. You can see there is a green tick over here, which means our cluster is successfully created. We have already pushed the Docker image to a container registry. The next step is deploying the sample application to Google Kubernetes engine. For this step, you have to create a Kubernetes deployment to run the application on the cluster and also create something called the horizontal pod autoscaler, which scales the number of pods. It can be anywhere from 1 to 5 based on the CPU load. So for that, we'll go to workloads and click on deploy. We have an existing container image, so we'll just select it. Go to select. This is our project ID and this is the name of the Docker image. So we'll just expand it and select this. Our Docker image is selected. We click on continue. Now we have to configure it. So we can name our application anything we want. So we'll just name it demo application. We'll let the namespace be default. Next we have label, which is basically for identification. So we'll let the key be app and the value be demo application. We'll not make any changes in that. And this is our cluster on which the demo application is going to be deployed. Now when we see the 𝐿𝐴𝐻, okay, so we have an error here. We cannot use uppercase. So we'll just make it lowercase, demo application. Now when we see the 𝐿𝐴ML file, you can see two Kubernetes API resources about to be deployed into your clusters. The first one is deployment, and next is the horizontal pod autoscaler. Next, we'll just click on deploy, and our deployment is being created. Now this might take only a couple of seconds. Here you can see the CPU usage, memory usage, and a disk usage, but as of now there is no data available. Now if you go to details, you'll see a cluster name, the namespace which I have mentioned, when was it created and at what time, the labels, how many replicas were made. There were 3 replicas which were made. So after the deployment, we're going to expose the sample application to the internet. So for that, we have an option here called as expose. So we'll just click on this. In the target port, we'll select 8080. Now this is the port the Hello app container listens to, as I had mentioned at the starting of the demo. The service type, let it be load balancer itself. And we can name our service anything we want. Let it be demo application service itself. And we're just going to click on expose over here. Now a new service has been created and it is waiting for a load balancer with an external IP to be created. Now this might also take a couple of seconds. Now a service has been created. So when we go to details, you can see the cluster name, the namespace, when was it created, the label, the ports, the type load balancer, and external endpoint. So we'll just click on this, or you can just copy this and paste it in a new tab. So when we click on this, we are directed to a sample application. So here is a sample web application. Now you see our sample application is exposed to the internet through Kubernetes service. And here is the hello world message with the version and the host name.
Let us now see the reasons why one should consider Terraform. So Terraform lets you define infrastructure in configuration code and will enable you to rebuild and track changes to infrastructure with ease. So Terraform provides a high level description of infrastructure, which means it's infrastructure descriptive. Second, it has a lively community and is open source. There is a massive community developing around this tool. Many people are already using it, and it's easier to find people who know how to use it, like plugins, extensions, professional support, etc. This also means Terraform is evolving at a much faster rate. They do releases very often. So third is like speedy operations. So Terraform's speed and operations are like exceptional. One cool thing about Terraform is its planned command lets you see what changes you are about to apply before you apply them. Code reuse features and Terraform tends to make most changes faster than similar tools like CloudFormation. Also, it is like the right tool for infrastructure management, as many other tools have a severe impedance mismatch from trying to wrangle an API designed for configuring management to control an infrastructure environment. Instead, Terraform matches correctly with what you want to do. The API aligns with the way you think about infrastructure. Also, like Terraform is the only sophisticated tool that is completely platform agnostic as well as supports other services, while there are a few alternatives, but they are focused on a single cloud provider. There's a declarative code. So Terraform enables you to implement all kinds of coding principles, like having your code in source control, the ability to write automated tests, etc. Now that we have understood why one must choose Terraform, now let's briefly understand what Terraform actually is. Terraform is a configuration orchestration tool designed to provision the servers themselves. It refers to arrangement and coordination of automated tasks resulting in a consolidated process or workflow. So it is also an like open source tool, means open source software tool created by HashiCorp. So HashiCorp created Terraform to manage present as well as popular service along with the custom in-house solutions. So Terraform lets you provision Google Cloud resources with declarative configuration files, resources such as virtual machines, containers, storage, and networking. Terraform's infrastructure as a code, that is the IAC approach, supports DevOps best practices for change management, which lets you manage Terraform configuration files in source control to maintain an ideal provisioning state for testing and production environments. Terraform manages external resources with providers, external resources like public cloud infrastructure, private cloud infrastructure, network appliances, software as a service, and platform as a service. HashiCorp maintains an extensive list of official providers and can also integrate with community developed providers. Users can interact with Terraform providers by declaring resources or by calling data sources. Rather than using imperative commands to provision resources, Terraform uses declarative configuration to describe the desired final state. Now let's look at some tools for using Terraform with Google Cloud. We will briefly understand these tools. So there are like variety of tools you can use to optimize your Terraform experience. So first, let's explore the Cloud Foundation Toolkit, which provides a series of reference modules for Terraform. The modules reflect Google Cloud best practices, and using these modules help you get started with Terraform more quickly. The modules are documented in the Terraform registry and open sourced on GitHub. So these are some of the features of Cloud Foundation Toolkit. So first is ready-made templates. So the Cloud Foundation Toolkit provides a series of reference templates for Deployment Manager and Terraform, which reflect Google Cloud best practices. These templates can be used off the shelf to quickly build a repeatable enterprise-ready foundation in Google Cloud. This frees you to focus on deploying your applications in this baseline secure environment, and with infrastructure as a code, you can easily update the foundation as your needs change. Second, like you can treat your infrastructure like software. So through the open source templates, you can automate repeatable tasks and provision entire environments in a consistent fashion. Plus, your teams can collaborate on the infrastructure by participating in code reviews and suggesting source code changes. Third, it's built for enterprise. So the Cloud Foundation Toolkit is designed especially to meet the compliance and security needs of enterprises. By creating a foundational environment using these templates, you can be confident that best practices are implemented out of the box, including key security and governance controls. Also, you can maintain consistency easily. By adopting the toolkit, you can be confident that different teams are deploying their applications and environments using a consistent set of tools and patterns. This reduces the potential for misconfigurations and inconsistencies while allowing easier collaboration across different teams. Also, you can choose your adoption strategy. Each template from the Cloud Foundation Toolkit can be used independently. You can choose which patterns make sense for your organization and add new ones as your environment evolves. The open source templates can easily be forked and modified to suit your organization's needs. Lastly, you can save time and resources with pre-built templates. With the Cloud Foundation Toolkit, you don't need to spend time developing your own templates and patterns for Google Cloud. Instead, you can build an open source templates and focus only on the customizations which are required to your company and workloads. Developers can move faster and migrations are less time consuming because of it. So the second tool is Terraform Validator. So leverage Terraform Validator to enforce policies on Terraform configurations for Google Cloud. So Terraform Validator is a tool for validating compliance with organizational policies prior to applying Terraform plan. It can be used either as a standalone tool or in conjugation with Forseti or other policy enforcement tooling. Terraform Validator relies on policies that are compatible with Config Validator. Note that using Terraform Validator does not require an active installation of Forseti. Terraform Validator is a self-contained binary. So you can see the Forseti config validator shown here, which is the newest addition to the Forseti security toolkit. So config validator helps cloud admins put guardrails in place to protect against misconfigurations in Google Cloud Platform environments. This allows developers to move quickly and give security and governance teams the ability to enforce security at scale. So how does a Terraform validator works? So cloud admins write security and governance constraints as YAML files once and store them within their company's dedicated Git repo as a central source of truth. Then Forseti ingests constraints and uses them as a new scanner to monitor for violations. Then Terraform Validator reads the same constraints to check for violations before provisioning in order to help prevent misconfigurations from happening. That's how the whole process of Terraform Validator works. The next tool we have is Terraformer. So by importing existing Google Cloud resources into Terraform with Terraformer, it is a command line interface tool that generates TF or JSON and TF state files. Terraform already has existing resources in your environment, performing the reverse of what Terraform is designed to do. This tool can be thought of as infrastructure to code. Next and the last tool is a Cloud Shell. So Terraform is integrated with Cloud Shell, and Cloud Shell automatically authenticates Terraform, letting you get started with less setup. Using Cloud Shell, you can manage your infrastructure and develop your applications from any browser. Cloud Shell is an online development and operations environment accessible anywhere with your browser. You can manage your resources with its online terminal preloaded with utilities such as the gcloud command line tool. You can also develop, build, debug, and deploy your cloud-based apps using the online Cloud Shell editor. So some of the features of Cloud Shell are full power access from anywhere. You can manage your Google Cloud resources with the flexibility of a Linux shell. Cloud Shell provides command line access to a virtual machine instance in a terminal window. Then it has a developer ready environment, so you can develop your apps directly from your browser with the Cloud Shell editor. Is streamlined to increase your productivity with features such as Go, Java, Node.js, Python, and C language support. An integrated debugger, source control, refactoring, and a customizable interface. Run your app on the Cloud Shell virtual machine or in the Minikube Kubernetes emulator. Preview it directly in your browser, then commit changes back to your repo from your Git clients. Then the next feature is your favorite tools pre-installed and up to date. So many of your favorite command line tools from Bash and SH to Emacs and Vim are already pre-installed and kept up to date with Cloud Shell. Admin and development tools such as command line tool, MySQL, Kubernetes, Docker, Minikube are configured and ready to use. No more hunting around for how to install the latest version and all its dependencies. Just connect to Cloud Shell and go. So the last feature is cloud code tools for maximizing development productivity. With this, you can easily develop cloud-based applications with the tools provided by our cloud code extensions, allowing you to develop and deploy your Kubernetes and cloud run applications, manage your clusters, and integrate Google Cloud APIs into your project, all directly from the Cloud Shell Editor. So now let's understand like the support that Terraform provides for GCP. The core Terraform command line interface is developed by HashiCorp. Use the following resources for support, like for provider related issues, open an issue on GitHub. For questions about Terraform in general and common patterns, check the HashiCorp community portal. For general troubleshooting advice, see Terraform's debugging documentation and join in the Google Cloud Community Slack Terraform channel. If you haven't already, you can like register for the Google Cloud Community Slack. Now that you have a theoretical understanding of Terraform with GCP, let's demonstrate it practically with an example of launching a virtual machine instance in GCP through Terraform. So the first step is to download the Google Cloud SDK installer. So just search out Google Cloud SDK. So go here. So you can just directly go to the install section here. Yeah. So yeah, here like if you have a Linux OS, you can go to Linux and follow the steps to download, or you can go for Mac OS also. Because I have Windows, so I will start download directly from here. So I got it downloaded. Okay, open. Takes a few seconds. Yeah, let's go next. So I already have a SDK installed, so I don't have to continue. But if you don't have SDK installed, so do continue, like get the installation complete. So yeah, the next step is to download the Terraform. So you can just directly go to releases.hashicorp.com/terraform. So HashiCorp, as I've told you, is the company that created Terraform. So from here, like all the versions are given, a lot of versions are there. So you can just go and download one. Yeah. If you have a Linux OS, you can just copy the address from here and unzip it. Okay, that's what you have to do. So if you're a Windows user, you can just download it from here. Yeah, it got downloaded twice, so you can delete this one. Yeah, so you can just extract it from here. Yeah, you got it. Just copy it and paste it somewhere where you are going to like place other files like separately. Like I have a different place to copy, so I will just go to my section, like not here, just a second. Okay, I will just go to my place, like because I am going to provide the path also. I will keep that in mind to place it separately. The demo section in the Terraform. Yeah, like this one I have got it before, so I will delete this one and I will paste the new one. Yeah, and I will name it as Terraform only. So the next step is to go to the build infrastructure. So here, go to the HashiCorp website. From here, you will go to the tutorial section of the Google Cloud. Okay, the prerequisites are given, like you have to create the account on Google Cloud platform. So if you don't have an account, create one. It's a very good platform to have your account on, and it provides a free trial, like it's given the free trial. So free trial account is provided for 90 days with $300 credits, and when you're going to register it, you'll ask for your debit or credit card details, and it will just debit 1 rupee, and that will also be refunded very soon. Also, like $300 credit is provided, so that is like a lot of credits. Even means the exercise which I'm going to provide you, it's like it doesn't cost anything. It will only cut around $15-20, not more than that, or maybe maximum $50. That's it. So that's how you can use it. So next, Cloud Shell. Cloud Shell I've already explained you how it works and what are its features. Then is set up the GCP. So what you have to do in the GCP is you have to create a project, then you have to create a service account, and you have to generate a key. Okay. So let's go to the GCP console. So this is how the GCP console, like Google Cloud Platforms console, looks like. Okay, from here you go here and create a project. So you can create a project from here, but I already like created the project. My project name is demo, so I will use this project only. So now what I have to do is I have to make a service account. So I will type service account, and yeah, this is the default one, and this is the one I have created recently. So I will create a new one with the name TF demo. For service account, we will name it as SA. Okay, so create and continue. Now for access purpose, you have to give the role. So like different access options are provided for, like different services are here. You can provide like for a specific service, you can provide the access like App Engine or AI notebooks and everything, AutoML, CA service, cloud asset, cloud data labeling. For specific service, which for whatever purpose you want to give, you can give it specifically. For this service account, I want a complete access, so I will just go to the project, and in project I will give the owner to get the complete access. So yeah, continue, done. So yeah, the service account is created for TF demo SA. Okay. For the next step, you can go to the registry Terraform that I've already opened. Okay, in this way you have to go to the getting started with Google Cloud Provider. You will get the code for here, the basic code for virtual machine launching the instance. It's simple, this one. And it's the basic code of Terraform. Okay, so if you're going to use AWS now, so in AWS you will just use, instead of Google, you will use AWS. That's it. All the things will be same. And similarly, the provider code is provided below. So just copy this code also and make a provider file. And for this, create a VM file. Like I have created one. So this is how I have copied it here. Like this is the VM, the basic codes, and then the provider code is provided here. So you can see in VM, like the credentials are given, project and then region is given, everything. And similarly, like the provider in this, the name, like with the virtual machine instance that will be created now, that will be named by Flask VM, and whatever the ID it will be there. So in that name, the virtual machine will be created. Similarly, machine type is given and zone is given. Also, one more thing. So I have to generate a key in this, like this I have created now. I have to generate the key. I have, like, remember I told you in this, like the third step is to create a service account key. So you can go here, like the service account we have created. In that we have to create a key. So manage keys and add key, create new. So in JSON file you have, will be created from here. So yeah, got created. So we can just go to downloads. Yeah. So it is here. So we can just copy here and you will just paste it where we have all the Terraform files, and name it as tf underscore authorization underscore, sorry, tf underscore demo underscore authorization. This is what I have named in the code also. That's why I'm naming this. So yeah, tf underscore demo underscore authorization.json. So that's what it is. Same. So coming back. So yeah, all the codes and everything is done. So now what we have to do is take that. So it's the key is active now, you can see. So what we have to do is now open the command prompt. You just have to provide the path first. So the path is cd demo slash terraform. So yeah, the path is here. Then we have to revoke the authorization. So gcloud authorization purpose, for gcloud authorization revoke. One more thing I will show you, the JSON file. If you see, everything is given like privately. For project ID is given private, key ID is also given. From the name, the virtual machine will be launched now, the key will be given this Flask ID and the key. Then private key is given, then client email, client ID, authorization token, everything is given in this. Okay, so we got this authorization revoke, credentials are here. So after that we have to configure. So gcloud config configurations list. So yeah, though everything is right in my account, but if you want to change, so what you can do is you can initialize this. So first clear this one. So you can initialize it for changing anything in your configuration list. Okay, so gcloud, oh sorry, gcloud initialize init. So yeah, for reinitialize, give the one choice number, numeric number one. It's been done. Then would you like to log in? Yes, I want to log in. Just have to log in from here. Allow, and it's authenticated. It will be done now. So you can just come back. You can choose the project from here. So your project name is, if you remember, it's Chrome Sensor 313404. Okay, so it is Chrome Sensor. So it's second, and I think then yeah, the zone and region we have to select. So yeah, we want to select. So my region is South Asia. Yeah, so I will select 37 South Asia 1A. So yeah, everything is done now. So we can just again configure now. So yeah, everything is at place. Account, yeah. So last time, if you see, like I was saying, like everything is right, but last time also like everything wasn't right, because in the place of account now, my account wasn't selected, so it wouldn't have worked. Do check it properly. Then just clear this. Then let's start with the Terraform initialization. Terraform init. We have to go with, I think, yeah, it's getting initializing. So yeah, it's got initialized, and we go with plan. So Terraform Sorry, caps lock. Initialize. I have already initialized that. Sorry. So Terraform plan now. So yeah. So it will be like create. So if you like got done, but you can go. So you can see like Google Compute instance will be created now. Okay. So what we have to do is we just have to apply. So here the command is Terraform apply. Only yes will be accepted. So yeah, yes. Yeah, so it's got created. So let's check. Let's go to the virtual machine instance, pure engine, virtual machine instances. The flask will be created with the name flask or some ID will be given again. Flask VM ID something. I hope it get created. It will be created because it's showing, so of course it got created. Yeah, flask VM in the private ID. So yeah, that's how it got created. And if you want to delete it, you can just give the command of destroy. Okay, so you can just come here. You can give terraform destroy. Only yes is accepted. So yes, it takes a few seconds. So yeah, so it got destroyed. Let's check. Now it is here. So we will just refresh it. You will find that it will get deleted from here. Yeah, so it got deleted.
Let us move on to the next topic and understand what exactly is GCP Security Command Center. Security Command Center is a security and risk management platform provided by Google Cloud. It is an intelligent risk dashboard and analytics system for surfacing, understanding, and remediating Google Cloud security and data risks across an organization. In simple words, it is an established security and risk database for Google Cloud. Now, the Security Command Center helps security teams gather data, identify threats, and act on them before they result in business damages or loss. It offers deep insight into application and data risks so you can quickly reduce the threats to your cloud resources across your organization and evaluate the overall health. Security Command Center provides a single centralized dashboard so you can view and monitor an inventory of your cloud assets. Now, assets are nothing but your resources like organizations, your projects, your instances, and your applications. It can also help in scanning storage system for the sensitive data. It can be used to detect common web vulnerability and anomalous behavior. With Security Command Center, you can also review the access rights to the critical or important resources in your organization. And along with that, you can follow the recommended actions to resolve the vulnerability present. Now, I guess you have some idea about what exactly is the Security Command Center. So now let us see how does the Security Command Center work in order to understand it better. Security Command Center enables you to generate curated insight, which provides a unique view of incoming threats and attacks to your Google Cloud resources, which are called as assets. Now, assets are nothing but resources like organization, projects, instances, and application. The Security Command Center asset discovery runs at least once a day. You can also manually rescan on demand from the Security Command Center assets display. Then the Security Command Center displays possible security risks that are associated with each asset. The possible security risk is called as findings. Now, this findings comes from security sources that include Security Command Center's built-in services, third-party partners, and your own security detectors and finding sources. Now, this was the working of Security Command Center. Now, let us take a look at some of its prominent features. The first one is you can gain centralized visibility and control. Security Command Center gives you a centralized visibility of the number of projects you're using, what resources are deployed, and you can also manage which service accounts has been added or removed. The second feature is you can fix misconfiguration and compliance violation. With Security Command Center, you can identify security misconfigurations and a compliance violation in your Google Cloud assets. After you've identified these vulnerabilities, you can resolve them by following the actionable recommendation which is provided by Google Cloud Platform. The third prominent feature is threat detection. You can detect threats using the logs running in the Google Cloud at scale. You can detect some of the most common container attacks, including suspicious binary, suspicious library, and reverse shell. You can also identify threats like cryptography mining, anomalous reboots, and suspicious network traffic with built-in anomaly detection technologies which are developed by Google itself. Next, after threat detection, we have threat prevention. With Security Command Center, you understand the security state of your Google Cloud assets. You can uncover common web application vulnerabilities such as cross-site scripting or outdated libraries in a web application that are running on either Google App Engine or Google Kubernetes Engine or Google Compute Engines. Then you can quickly resolve this misconfiguration by clicking directly on the impacted resources and following the procedure steps on how to fix it. The last feature is sensitive data identification. With Security Command Center, you can find out which storage bucket contains sensitive and regulated data using Cloud DLP. You can also prevent unintended exposure to these storage buckets and let only the authorized person access it. So these were some of the features of Cloud Security Command Center. Let us move on to the next topic and see what is Cloud Armor. Google Cloud Armor protects your application and website against denial of service and other web attacks. You can use Google Cloud Armor security policies to protect your application running behind a load balancer from distributed denial of service or DDoS and other web-based attacks, and your application could be deployed anywhere, whether on the Google Cloud or in a hybrid deployment or in a multi-cloud architecture. So this was the definition of Cloud Armor. Now let us understand how does Cloud Armor works. Google Cloud Armor's DDoS protection is always on inline, scaling to the capacity of Google's global network. So it is able to instantly detect and reduce network attacks in order to allow only well-formed requests through the load balancing proxies. With Google Cloud Armor security policies, you can also allow or deny access to your external HTTPS load balancer at the Google Cloud Edge, which is as close as possible to the source of incoming traffic. This helps you prevent unwanted traffic from consuming resources or entering your VPC network. Now let us take a look at some of the features of Google Cloud Armor. The first feature is IP-based and geo-based access control. You can filter your incoming traffic based on IPv4 and IPv6 addresses or CIDRs. You can also enforce geographic-based access control to allow or deny traffic based on source geographical location using Google GeoIP mapping. The next feature is adaptive protection. Cloud Armor automatically detects and helps reduces high-volume DDoS attacks with a machine learning system trained locally on your applications. The last feature is pre-configured web application firewall rules. Cloud Armor comes with the out-of-the-box rule set based on industry standards to reduce the common web application vulnerabilities and help provide protection from various web attacks. So this was about Cloud Armor.
First, let's understand what Google Cloud IAM is. So IAM, which means Identity and Access Management, lets you grant granular access to specific Google Cloud resources and helps prevent access to other resources. IAM lets you adopt the security principle of least privilege, which states that nobody should have more permission than they actually need. Let's now understand how Google Cloud IAM works. First, let's take a real-time example or say real-life scenario. Suppose if you enter a company and you got the visitor card, so you have a very limited access through it. Like you can access reception, you can access cafeteria, you can access a lobby where you can rest. Okay, now suppose you got selected in that company. Okay, you got selected as a fresher, as in the position of junior analyst, you can say. Now you have much more access than cafeteria, reception and lobby. Now you have access to certain databases, you have access to certain maybe cloud resources also, a little bit whatever is required for you for analysis purpose. Also you can have access to various analytical tools also, but you don't have complete access to all of them. Suppose now you are working under a senior research analyst. This senior research analyst, or you can say senior analyst, have much more access than you because you are a junior analyst. Senior analyst have much more access to more cloud resources. He has more access to much more Excel sheets also, you can say, and also like various other analytical tools also. Now suppose there's another person who isn't an analyst team, he's in cloud team, say he's a cloud engineer. So now you can see he might having the access of a lot of cloud resources compared to you, but he won't be having access to certain database services which you have access to, certain databases also which you have access to, a certain analytical tools also which you have access to, he might not be having that access. So that's how a certain rights and certain accesses are being provided to different teams and depending on their work. This is just, you can say it as a real-time example. Okay, that's how access and identity management works. So now let's understand how IAM works in Google Cloud. With IAM, you manage access control by defining who means identity has what access means role for which resource. For example, Compute engine virtual machine instances, Google Kubernetes engine clusters, and cloud storage buckets are all Google Cloud resources. The organizations, folders, and projects that you use to organize your resources are also resources. In IAM, permissions to access a resource isn't granted directly to the end user. Instead, permissions are grouped into roles, and roles are granted to authenticated members. An IAM policy defines and enforces what roles are granted to which members, and this policy is attached to a resource. When an authenticated member attempts to access a resource, IAM checks the resources policy to determine whether the action is permitted. You can see this following diagram illustrates permission management in IAM. This model for access management has three main parts. The first part is member. So a member can be a Google account, you can say, for end users, and a service account, you can say, for apps and virtual machines. And then there is a Google group or a Google workspace or cloud identity domain that can access a resource. The identity of a member is an email address associated with a user, service account, or Google group, or a domain name associated with Google workspace or cloud identity domains. Then there is a role. So a role is a collection of permissions. Permissions determine what operations are allowed on a resource. When you grant a role to a member, you grant all the permission that the role contains. Okay. And then there is policy. So the IAM policy is a collection of role bindings that bind one or more members to individual roles. When you want to define who has what type of access, means role, on a resource, create a policy and attach it to the resource. Now let's understand the concepts in IAM. First, let's understand the concepts related to identity. So in IAM, you grant access to members, and members can be of the following types. Like, it can be a Google account, which represents a developer, an administrator, or any other permission who interacts with Google Cloud. Account can be an identity, including gmail.com or other domains. New users can sign up for a Google account by going to the Google account sign up page. Then there is service account. A service account is an account for an application instead of an individual end user. When you run code that's hosted on Google Cloud, the code runs as the account you specify. You can create as many service accounts as needed to represent the different model components of your application. Okay. Then there is Google Group. So a Google Group is a named collection of Google accounts and service accounts. Okay. And every Google group has a unique email address that's associated with the group. You can find the email address that's associated with the Google group by clicking about. There is this option about on the home page of any Google group. Google groups are a convenient way to apply an access policy to a collection of users. You can like grant and access controls for a whole group at once instead of granting or changing access controls one at a time for individual users or service accounts. You can also easily add and remove members from a Google group instead of updating an IAM policy to add or like remove users. Google Groups don't have login credentials, and you cannot use Google Groups to establish identity to make a request to access a resource. Then there is Google Workspace domain. Google Workspace domain represents a virtual group of all the Google accounts that have been created in an organization's Google Workspace account. Then Google Workspace domains like represent your organization's internet domain name, such as example.com. You can just for example. So I'm just naming it as example.com. And when you add a user to your Google Workspace domain, a new Google account is created for the user inside the virtual group, such as like you can take it as username at the example.com. Like Google Groups, Google Workspace domains cannot be used to establish identity, but they enable convenient permission management. Then the fifth one is cloud identity domain. A cloud identity domain is like Google Workspace domain because it represents a virtual group of all Google accounts in an organization. However, cloud identity domain users don't have access to Google Workspace applications and features. Then the next one is all authenticated users. So the value all authenticated users is a spatial identifier that represents all service accounts and all users on the internet who have authenticated with a Google account. So this identifier includes accounts that aren't connected to a Google Workspace or cloud identity domain, such as personal Gmail accounts. Users who aren't authenticated, such as anonymous visitors, aren't included. And the last one is all users. So the value all users is a spatial identifier that represents anyone who is on the internet, including authenticated and unauthenticated users also. Now moving ahead to the concepts related to access management. When an authenticated member attempts to access a resource, IAM checks the resource's IAM policy to determine whether the action is allowed or not. So the first one in this is resource. If a user needs to access to a specific Google Cloud resource, you can grant the user a role for the resource. Some examples of resources are projects, compute engine instances, and cloud storage buckets. Some services support granting IAM permissions at a granularity finer than the project level. For example, you can grant the storage admin role to a user for a particular cloud storage bucket, or you can grant the compute instance admin role to a user for a specific compute engine instance. In other cases, you can grant IAM permissions at the project level. The permissions are then inherited by all resources within that project. For example, to grant access to all cloud storage buckets in a project, grant access to the project instead of each individual bucket. Or to grant access to all compute engine instances in a project, grant access to the project rather than each individual instance. And the next one is permissions. So permissions determine what operations are allowed on a resource. In the IAM world, permissions are represented in the form of service.resource.verb. For example, if you are using PubSub, then you can give it as pubsub.subscriptions.consume. That becomes service.resource.verb, right? Permissions often correspond one-to-one with REST API methods. That is, each Google Cloud Service has an associated set of permissions for each REST API method that it exposes. The caller of that method needs those permissions to call that method. For example, if you use PubSub and you need to call the topics.published method, you must have the PubSub topics published permission for that topic. You don't grant permissions to users directly. Instead, you identify roles that contain the appropriate permissions and then grant those roles to the user. So the third one is roles. A role is a collection of permissions. You cannot grant a permission to the user directly. Instead, you grant them a role. Then when you grant a role to a user, you grant them all the permissions that the role contains. So there are several kinds of roles in IAM, like there are basic roles. Roles historically believe in the Google Cloud Console. These console are owner, editor, and viewer. Cautiously remember that basic roles include thousands of permissions across all Google Cloud services. In production environments, do not grant basic roles unless there is no alternative. Instead, grant the most limited predefined roles or custom roles that meet your needs. Then there are predefined roles, so roles that give finer grained access control than the basic roles. For example, the predefined role PubSub publisher provides access to only publish messages to a PubSub topic only. Then there are custom roles, so roles that you create or tailor permissions to the needs of your organization when predefined roles don't meet your needs. Like you can see here, an example of role is given, like the role is assigned as a compute.instance admin. Like the role is assigned compute.instance admin. So under this role, you have permissions to access all the resources under this role, like compute.instance.delete or like compute.instance.get. Everything is you can access. Now the next one is IAM policy. So you can grant roles to users by creating an IAM policy, which is a collection of statements that define who has what type of access. A policy is attached to a resource and is used to enforce access control whenever that resource is accessed, as you can see here. So an IAM policy is represented by the IAM policy object. An IAM policy object consists of list of role bindings. A role binding binds a list of members to a role. IAM provides a set of methods that you can use to create and manage access control policies on Google Cloud resources. These methods are exposed by the services that support IAM. For example, the IAM methods are exposed by the resource manager, PubSub, and Cloud Life Sciences APIs. Just to name a few, like the IAM methods are set IAM policy, which sets policies on your resources. Then there is get IAM policy, which gets a policy that was previously set. Then there is test IAM permissions that sets. Then there are test IAM permissions, which test whether the caller has the specified permissions for a resource or not. Now, moving on to the next and the last one, that is resource hierarchy. So, Google Cloud resources are organized hierarchically. Like the organization is the root node in the hierarchy. Then there are folders, which are children of the organization. Then projects are children of the organizations or of a folder. And the last one, like resources for each service, are descendants of projects. Each resource has exactly one parent. So this following diagram is an example of a Google Cloud resource hierarchy. You can set an IAM policy at any level in the resource hierarchy, the organization level, the folder level, the project level, or the resource level. Resources inherit the policies of all their parent resources. The effective policy for a resource is the union of policies set on that resource and the policies inherited from higher up in the hierarchy. This policy inheritance is transitive. In other words, like a resource inherit policies from the project, which inherit policies from folders, which inherit policies from the organization. Therefore, the organization level policies also apply to the resource level. For example, in this diagram, topic underscore A is a pub/sub resource that lives under the project example prod. Suppose there is a account name Mika@example.com, and if you grant the editor role to Mika@example.com for resources for example production, and grant the publisher role to song@example.com for topic underscore A, you effectively grant the editor role for topic underscore A to Mika@example.com and the publisher role to song@example.com. The policies for child resources inherit from the policies for their parent resources. For example, if you grant the editor role to a user for a project and grant the viewer role to a same user for a child resource, then the user still has the editor role grant for the child resource. If you change the resource hierarchy, the policy inheritance changes as well. For example, moving a project into an organization causes the project to inherit from the organization's IAM policy. Now let's understand the practical actionable settings you can modify in the IAM, which will greatly improve the security of your project. So the first one is you can enforce multi-factor authentication. You can say it as MFA, which is a method where not only is one piece of information used to authenticate a user, example password, but there's also at least one additional source of proof needed to establish that the right person is accessing a system. On Google Cloud Platform, users authenticate themselves using Google accounts. These can be individual email addresses registered as a Google account, or more commonly like accounts of a Google suite domain. On the Google Cloud Platform side, you cannot enforce that the Google accounts that have access to your project must have multi-factor authentication enabled, means MFA enabled. But if you only grant access to users from your Google suite domain, then the Google suite domain administrator can set up MFA on the Google suite domain in a way that forces everyone to use it. If you need to give access to people without accounts in your Google suite domain, then you can create accounts for them in your Google suite domain for the sole purpose of accessing your project. This way you can enforce settings on their accounts. If you combine both these rules, then you can be certain that every user who has access to the Google Cloud Platform project needs to validate themselves using MFA, means multi-factor authentication. This makes it much harder to compromise your project, even if the password for an email address leaks from another source. Second thing is you can set up password policy for users. The password policy settings are technically not inside the Google Cloud Platform, but at the discretion of the Google Suite domain administrator. If you only allow users from your domain and the domain is set up with the right password policy, then these two things combined will result in the password policy being enforced on all your Google Cloud Platform users. Third one is give the necessary but the least possible privileges. So it is a good practice in general to only give the minimum necessary privileges to all of your users. If all of the previously discussed account protection methods fail, your attackers will still have fewer services to break into or steal information from. The actual implementation of this principle will vary based on your usage patterns. For example, if your database administrators only need to do Google Cloud SQL administration tasks, don't give them project editor role, give them a Cloud SQL admin role instead. Also, what you can do is you can set up quotas. Like default quotas are set for every newly created project on Google Cloud Platform. This is a least resort security control to avoid unexpected runaway spending. For example, if you have a faulty script creating resources in a recursive manner, it will only be able to create them up to the quota limits. It can also protect against compromised account creating a lot of new resources for the attacker's purposes. The quotas can be changed on the quotas page, but it requires the service usage.quotas.update permission, which is only included in the following predefined roles like owner, editor, and quota administrator. So if a compromised account or faulty script does not have the permission, then the spending can only increase up to the quota limits. Last thing is check and rotate service account keys. There is another type of account on Google Cloud Platform besides the user accounts, that is service accounts. So service accounts are meant for programmatic use cases. They cannot be used to access the Google Cloud Console because they are only valid for Google Cloud API access. The most frequent use case is to run applications or instances inheriting the rights of a specific service account so they can access other cloud service without extra authentication. Service account use keys for authentication. One service account can have multiple keys associated with it. it is a good practice to regularly rotate the keys of the service account. This can be achieved by creating a new key for the service account, then overwriting the current key with the new one everywhere it was saved, and then deleting the old key associated with the service account. This way, even if an application where the key was stored is compromised without your knowledge, the attacker will only have a limited time window to use the key. Now that you have a theoretical understanding of Google Cloud Identity and Access Management working and concepts, let's now see a practical demonstration of it on Google Cloud Platform. So we are at Google Cloud Console now. This is how the dashboard of Google Cloud Platform looks like, means console looks like. You can see the ID dhruv.pandey@edureka.co. So what we are going to do is we are going to see the identity and access management. So let's move on to IAM and just click here and go to IAM and admin. And here you can see all the permissions the accounts have. So we are going to provide a new access to the, like you can also see the project here, it's demo billing. So from this project I will be giving the access. So let's add account. So you can add it from here. I'm going to add like the other account of mine in it. So yeah, it will be at project level. You are going to give a role now. So select it, go to project, give editor. As I have explained you how we have to give the editor role here, editor. Now you have to give another role at resource level. That's what is given in the policy, right? I have explained you the policy of access management. Choose a resource for it. So we are going to choose cloud storage. We can choose. So cloud storage, where it is. Yeah. So we are just going to choose the viewer option. Okay. So yeah, save it. But at the project level, we have the editor option. Remember that. Okay. So yeah, it's been added now. Now you can just go to, like, because you have the editor permissions at the project level, so you can just simply see how, like, we can go to virtual machine also. So here you can go and you can see if there is any virtual machine is there. Oh, just a second. Right now I am logging in the same account. So what I can do is I can go to another account that is which I have given permission to, right? So I'll go to this account. Sorry. So now I'm logged into my other account, that is dhruv.pandey2595@gmail.com. You can see now. So in this account, I have been to the VM instance now. So in this, you can see like there is no VM created now, but I can create an instance from here. And similarly, if you go to cloud storage, you can access other services also through this account because you have the editor option at project level. Okay. Let's go to cloud storage. And you can see there is this demo store cloud is here. So you can even create a new bucket, or you can just go to this one and you can upload any file into it also. Like I'll show you how upload files. Say okay, you can just upload this. So you can see how upload has been done because you have all the rights of editor. Okay, you can delete it also. So you can just select this one. So you can just delete it from here. Yeah, action is summary and it will get deleted. Now go back. You can even delete this one also. You can just select it and you can delete it from here. Okay. Now let's move back to our own IAM permissions. This is the main account I am opening. You can see here. From here I will go to the IAM roles and everything. So IAM access management means identity and access management. And what I can do here is I can edit the roles. So what I can do is I can delete it from here. Like okay, I will not delete it at project level. No, I will delete it the editor. Okay, but the resource level it will remain, but it won't be completely be deleted. Okay, so I'm just deleting this one. So just select here, delete role one, and save. Okay, now if you refresh it, you will see like you won't be having access to it. Now we have deleted the editor role. What we can do is we can choose the other account. Okay, now access to the secondary account, and then we will go to storage. Sorry, just a second. Cloud storage. So you can see the permissions are being limited, so you don't have sufficient permissions to view this. Even though the other way to view this is because you have the viewing option and don't not at the project level but at the resource level. So you can view it from the Cloud Shell. There are certain codes being given in the documentation part of identity and access management in Google Cloud. You can see the codes and you can just type it here at the command line interface of the Google Cloud. It is Cloud Shell, which is this. You can activate it from here and you can just access means so you can view the files from here. Okay. but not at the console. You can only be able to see it from command line interface, that is Cloud Shell. Now let's move back to this my main account. Now I can even delete these roles, like the roles I provided now. So I can delete this role completely. Okay, so I will just remove it from here, confirm. Okay, so that's how the role has been deleted. I hope you have understand how identity and access management in Google Cloud works. Now let's take a look at some building blocks of AI in Google Cloud. So there are four major building blocks. First one is site, second is language, then conversation and structured data. So under site, we have multiple products. That is, first one is Vision API. With Vision API and machine learning model, which helps you in reading images. Suppose if I upload an image under Vision API, by just reading that image, the Google Cloud Platform can help you identify the data points which are related to the particular image. So it's very efficient for data processing. I mean, image data processing. Now the next one, that is Cloud Video Intelligence, which has pre-trained machine learning models that automatically recognize a vast number of objects, places, and actions in storing and streaming video, which offers like exceptional quality out of the box. Also, it's highly efficient for common use cases and improves over time as new concepts are introduced. Now the next is AutoML Vision, which enables you to train machine learning models to classify your images according to your own defined labels. Then AutoML Video Intelligence, which has a graphical interface that makes it easy to train your own custom models to classify and track objects within videos. Even if you have like minimal machine learning experience also, then also it can work very efficiently. It's ideal for projects that require custom labels that aren't covered by the pre-trained video intelligence API. Second category is language. So under language, we have the first product as a Cloud Translate, which like helps you in convert one particular language to another. Okay. So suppose you have something written in Japanese, you can feed that in Cloud Translate and it can get converted into English or like any other language of your choice. So the next one is like Cloud Natural Language, which is like a very famous product to send for doing sentiment analysis. Okay. Then we have with AutoML translation, like AutoML translation. So with AutoML translation, developers, translators, and localization experts with limited machine learning expertise can quickly create high quality and production ready models. So just upload translated image pairs, and like AutoML translation will train a custom model that you can scale and adapt to meet your domain specific needs. Last is AutoML natural language, which enables you to build and deploy custom machine learning models that analyze documents and like categorize them, identify entities with them, or assessing attitudes with them. Now the third main category is conversation. So under conversation, we have the first product as Dialogflow, which is a natural language understanding platform that makes it easy to design and integrate a conversational user interface into your mobile app, web application, or device, bot, interactive voice response system, and so on. So using Dialogflow, you can provide new and engaging ways for users to interact with your product. And Dialogflow can analyze multiple types of input from your customers, including text or audio inputs, like from a phone or voice recording. So it can also respond to your customers in a couple of ways, either through text or speech. Then we have speech to text API in under conversation, which helps in converting your speech. So suppose someone is speaking and at the same time you want that particular speech to be converted into text. Then in that case, this particular API and machine learning model comes handy and it helps you do that analysis. Similarly, we have text to speech API, which helps in converting given text to the speech at the same time. Now comes to the last building block, that is structured data. So first product in the structured data is AutoML tables, which enables your entire team of data scientists, analysts, and developers to automatically build and deploy state-of-the-art machine learning models on structured data at massively increased speed and scale, which in turn transform your business by leveraging your enterprise data to tackle mission critical tasks like supply chain management, fraud detection, lead conversion, optimization, and increasing customer lifetime value. Now coming to Cloud Inference API. So if you see, time series analysis is essential for day-to-day operation of many companies. Most popular use cases including analyzing foot traffic conversion for retailers, detecting data anomalies, identifying correlations in real time over sensor data, or generating high quality recommendations. So with Cloud Inference API, you can gather insights in real time from your typed time series datasets. So moving on to the last product, that is the recommendations AI, which draws on the experience and expertise in machine learning to deliver personalized recommendations that suit each customer's taste and preferences across all your touchpoints. Now, finally, let's look at some of the solutions of AI provided by GCP. The first one is Contact Center AI, With this, you can lower cost and increase customer satisfaction with the best of Google AI technology. So customer service is being improved with AI that understands, interacts, and talks. So with Contact Center AI, you can create agents that are superheroes of your customers. Also, you can enable natural interactions with virtual agents and empower your teams with actionable insights. Moving on to the next one, that is AI Platform Unified. So AI Platform Unified brings AutoML and AI Platform Classic together into a unified API client library and user interface. With AI Platform Unified, both AutoML training and customer training are available options. So whichever option you choose for training, you can save models, deploying models, and request predictions with AI Platform Unified. Now the last major solution, that is Document AI. With Document AI, you can automate data capture to scale to reduce document processing costs. It is built on decades of AI innovation at Google, bringing powerful and useful solutions to these challenges. Under the hood are Google's industry-leading technologies like computer vision and natural language processing that create pre-trained models for high-volume documents. Document AI has already processed 10 billions of tens or billions of pages of documents across lending, insurance, government, and other industries. So now let's have a better understanding of Google Cloud AI Platform by trying our hands on it. If you don't have an account on Google Cloud Platform, then create one. GCP is like a really good platform to have your account on. It will ask for your credit and debit card details just for the verification purpose, and you will get a free trial for 90 days with $300 credited in GCP account, and you can use that for the demo I'm showing you, for the exercises I'm showing you. Practice with that. So this is the dashboard of Google Cloud Platform, and we have to go for AI Platform. So you can just type here AI Platform. So basically, AI platform is used to train your machine learning model and then scale your machine learning model, and then you can take your trained model and deploy it on your AI platform. This is the dashboard where you can, if you upload your model or anything, so it will show all the predictions for it. Also, it will predict traffic on it and everything. Error rate will also show. Prediction latency it will also show. These kind of things are there. Right now, there's no model uploaded, so it's just showing the basic headings for it. So the first one, the first feature in this one is you can say we can come to notebooks. It is how to generate a notebook instance, just like you have Jupyter notebook, right? In that way only, you can just go to new instance here, and you can go to TensorFlow. These kind of options are there. Like you can upload your simple Python notebook also, which have scikit-learn or pandas or numpy, anything. Simple visualization or things are done, data analysis is done. Under that, you can upload, or you can go for the heavy notebooks also, like TensorFlow or for PyTorch, another like Kaggle bit, like this IDE and Kaggle Python also. You can use a different kind of GPU in that. And here we are going with TensorFlow like enterprise with 2.1 with without GPU, and you also have option of NVIDIA Tesla. Okay, so without GPU and NVIDIA Tesla you can go for, but right now we are going with without GPUs. So here you can create your instance name and everything, or you can also go to the advanced options. Here you can choose the default one have four virtual CPUs, and the standard one, standard one has four virtual CPUs, 15 GB RAM. And if you want more, you can select more RAM, and or if you want the less one, you can select for the less one. And then you can also select for GPU whichever you want. Okay, like Tesla K80, P100, V100, various options are there. Okay, and you can just and then create it. Okay, it takes time. So what I did is I already created one. So we can just go back and launch from here. Can just open Jupyter Notebook here. So naturally it comes with all the built-in packages of TensorFlow and everything. But if you want to install some specific package, you can just go to terminal. Here you can type pip install XGBoost. You can install okay. So it's downloading. Install that. Okay. We have this multiple options here. Launching a notebook or a simple Python console or everything. So we can just go to notebook right now. You can select, or there are multiple languages you can select. Okay, you can also select Python to other languages also. Right now I've chosen Python, so we can check the version of XGBoost we have installed. Okay, so we can type just we can import XGBoost as XGB, then XGB for checking the version, XGB dot double underscore version double underscore. Okay, then we can also launch simple Python console also. So what you can do here is it's come as a simple Python. So what you can do, you can go for checking the TensorFlow version also. So just import TensorFlow as TF, and then For checking the version, same df dot underscore underscore version underscore underscore. So this is the 2.1.3 version of TensorFlow. So this is how you can play with your Jupyter with this notebook, just like you play with a manual Jupyter notebook, right? So yeah. Now coming to the next service, that is AI Hub. So what AI Hub generally does is, if there is a like Google Cloud AI team is there, and Google Cloud team now they just post the content here, the latest contents or whatever kind of content, whichever is useful for you, you can take that, and you can, like, if you want to understand any model, you can get it from here, or if you want to run any RNN or something, you can understand and get a research content from here. So that's just one thing. Second thing AI Hub does is, if you working in an organization, they have separate teams or something, you can share your model here, and it will be, you can put the limitation of it, it will completely be private to your team or certain to multiple teams. If you want to share your model with, that will be completely private. So that's a very good thing with AI Hub. Okay, you can get your model uploaded here and share it with the people you want to, with your customizations. Okay, so that is AI Hub. Then we have data labeling. So in data labeling, what happens is, you put your data set, be it of image or videos, in whichever manner, it gets annotated by the human annotators. So you can just create it here. You can insert your data set, whichever, like image, video, text, or you can create, and then you can give your parameters or descriptions, whichever way you want your data to get annotated. So you can give a better description, it will give you a better results on the basis of that. The more your description is accurate, the more accurate will be the annotations. Okay, so that's how it can be done. Then we can go back to the other service, that is, you can go to jobs. The jobs here is, you can like create a new training job from here. We have option of built-in algorithm training, then a custom code training. Like custom code training, you can write your model, create your model, and you can upload it here, and whichever way you want to upload, or you want to give any kind of model, that is custom code. But its plus point is in built-in algorithm training. With built-in algorithm training, we get the option of, like, you can select any kind of algorithm. These option all the algorithms are given: XGBoost, distributed XGBoost, linear learner, wide and deep learner, image classification, image object detection. These are the new ones which Google Cloud introduced, like tabnet and ncf, all these things. You choose your algorithm, then you can give your training data, you can give, and then you can give your algorithm arguments also, and you can provide the split ratio also you can give other parameters also. On the basis of that parameter, the model will be analyzed and prepared. So that's a very plus point, as it like saves a lot of time. Instead of making the whole model, it just directly creates a model for you. You don't have to code and do everything. So that's a very plus point. And then we have pipelines. So what pipeline does is, pipeline addresses all your MLOps life cycle, starting from acquiring data, preparing data, analyzing data, and training the model, analyzing the model, deploying the model, and then tracking your like model artifacts, evaluating the model. It is like built on Kubeflow pipelines and TensorFlow extended modules. So it basically allows you to build an end-to-end pipeline, and at the same time deploying the end-to-end pipeline. So this is what the pipeline, AI platform pipeline is. So then we have like models. Models is something, if you want to do code wise, like command line programming, you have to do like command line model you have to make, or analyze it or deploy it. That's where model is used. We can discuss that later. That's actually a big process. So yeah. So I just wanted to show you the demo thing for this. So this is how the Google Cloud AI platform works. So this is the general description for it. So let's start with having a brief overview of a resource in Google Cloud. So the first question that arises while having an overview of a resource in Google Cloud is, what is actually a resource? In the context of Google Cloud, a resource can refer to the service level resources that are used to process your workloads, virtual machines, databases, and so on, as well as to the account level resources that sit above the services such as projects, folders, and the organization. Now, the next thing we need to understand in the resource overview is, what is resource management? So resource management is focused on how you should configure and grant access to the various cloud resources for your company or team, specifically the setup and organization of the account level resources that sit above the service level resources. Account level resources are the resources involved in setting up and administrating your Google Cloud account. Now, the third and major thing is resource hierarchy. Google Cloud resources are organized hierarchically. This hierarchy allows you to map your organization's operational structure to Google Cloud and to manage access control and permissions for groups of related resources. The resource hierarchy provides logical attach points for access management policies like identity and access management and organizations policies also. Both identity and access management and organization policies are inherited through the hierarchy. And the effective policy at each node of the hierarchy is the result of policies directly applied to the node and policies inherited from its ancestors. So this following diagram shows an example of resource hierarchy illustrating the core account level resources involved in administrating your Google Cloud account. So in this, you can see first is like domain. So your company domain is the primary identity of your organization that establishes your company's identity with Google services, including Google Cloud. To manage the users in your organization, at the domain level, you define which users should be associated with your organization when using Google Cloud. Domain is also where you can universally administer policy for your users and devices. For example, enable two-factor authentication, reset passwords for any users in your organization. The domain is linked to either a Google Workspace or Cloud Identity account. The Google Workspace or Cloud Identity account is associated with exactly one organization. You manage the domain level functionality using the Google Admin Console from like admin.google.com. Then the second thing is organization. An organization is the root node of the Google Cloud hierarchy of resources. All Google Cloud resources that belong to an organization are grouped under the organization node, allowing you to define settings, permissions, and policies for all projects, folders, resources, and cloud billing account parents. An organization is associated with exactly one domain established with either a Google Workspace or Cloud Identity account and is created automatically when you set up your domain in Google Cloud. Using an organization, you can centrally manage your Google Cloud resources and your users' access to those resources. This includes proactive management and reactive management. So, proactive management is to reorganize resources as needed. For example, like restructuring or spinning up of a new division may require new projects and folders. And reactive management is an organization resource that provides a safety net to regain access to lost resources. For example, if one of your team members loses their access or leaves the company. The various roles and resources that are related to Google Cloud, including the organization projects, folders, resources, and cloud billing accounts, are managed within the Google Cloud Console. Now, the third thing is folder. So, folders are a grouping mechanism and can contain projects, other folders, or a combination of both. To use folders, you must have an organization node. Folders and projects are all mapped under the organization node. Folders can be used by group resources that share common identity and access management policies. While folder can contain multiple folders or resources, a given folder or resource can have exactly one parent. Then the fourth one is projects. So projects are required to use service level resources such as compute engine virtual machines, pub subtopics, cloud storage buckets, and so on. All service level resources are parented by projects, the base level organizing entity in Google Cloud. You can use projects to represent logical projects, teams, environments, or other collections that map to a business function or structure. Projects form the basis for enabling services, APIs, and IAM permissions. Any given resource can only exist in one project. And then we have resources. So Google Cloud Service level resources are the fundamental components that make up all Google Cloud services such as compute engine, virtual machines, pub subtopics, cloud storage buckets, and so on. For billing and access control purposes, resources exist at the lowest level of a hierarchy that also includes projects and an organization. Then the last one is label. So labels help you categorize your Google Cloud resources such as compute engine instances. A label is a key value pair. You can attach labels to each resource, then filter the resources based on their labels. Labels are great for cost tracking at a granular level. Information about labels is forwarded to the billing system so you can analyze your charges by label. Now let's move on to understand cloud billing account and Google's payment profile. So we will understand them simultaneously. Okay, so a cloud billing account is set up in Google Cloud and is used to define who pays for given set of Google Cloud resources and Google Map platform APIs. Access control to a cloud billing account is established by identity and access management rules. Then a cloud billing account is connected to a Google Payments profile. Your Google Payments profile includes a payment instrument to which costs are charged. So a cloud billing account is a cloud level resource managed in the cloud console, whereas Google Payments profile is a Google level resource managed at payments.google.com. A cloud billing account like tracks all the costs incurred by your Google Cloud usage. A cloud billing account can be linked to one or more projects, and projects usage is charged to the linked cloud billing account. Okay. Whereas a Google Payments profile connects to all of your Google services such as Google Ads, Google Cloud, and iPhone services. A cloud billing account results in a single invoice per cloud billing account. Okay, and a Google Payments profile processes payments for all Google services, not just Google Cloud. A cloud billing account operates in a single currency and defines who pays for a given set of resources. A cloud billing account is connected to a Google Payments profile, which includes a payment illustrating defining how you pay for your charges. Google Payments profile, on the other side, stores information like name, address, and tax ID when required legally and who is responsible for the profile. Also, it stores your various payment instruments like credit cards, debit card, bank accounts, and other payment methods you have used to buy through Google in the past. Also, Google Payments profile functions as a document center where you can view invoices, payment history, and so on. Cloud billing account has like billing specific roles and permissions to control accesses and modifying billing related functions established by identity and access management rules. Whereas Google Payments profile controls who can view and receive invoices for your various cloud billing accounts and products. Now let's understand the types of cloud billing accounts and profile. So there are two types of cloud billing accounts. First is self-serve account. So in which the payment instrument is a credit or debit card or ACH direct debit, depending on availability in each country or region. And in that, the costs are charged automatically to the payment instrument connected to the cloud billing account. You can sign up for self-serve accounts online. The documents generated for self-serve accounts include statements, payment receipts, and tax invoices and are accessible in the cloud console. And the second one is invoiced account, or you can say offline account. In this, the payment instruments can be checked or wire transfer. Invoices are sent by mail or electronically. Invoices are also accessible in the cloud console as are payment receipts. You must be eligible for invoiced billing. So for that, learn more about invoiced billing eligibility. You can learn that from the documentation of a GCP billing on Google Cloud Platform documentation. Okay. Now coming to the types of Google Payments profile. When you create your payments profile, you will be asked to specify the profile types. This information must be accurate for tax and identity verification. This setting can't be changed when you are setting up your payments profile. Make sure to choose the type that best fits how you plan to use your profile. There are two types of payments profile. One is individual and another is business. So in individual, you are using your account for your own personal payments. If you register your payments profile as an individual, then only you can manage the profile. You won't be able to add or remove users or change permissions on the profile. And in business payment profile, you are paying on behalf of a business, organization, or partnership or educational institution. You use Google Payment Center to play apps and games and Google services like Google Ads, Google Cloud, and iPhone services. A business profile allows you to add other users to the Google Payments profile you manage so that more than one person can access or manage a payments profile. All users added to a business profile can see the payment information on the profile. Now let's understand the charging cycle and billing context in GCP billing criteria. Okay. So first understand the charging cycle. So the charging cycle on your cloud billing account determines how and when you pay for your Google Cloud services and your use of Google Maps platform APIs. For self-serve cloud billing accounts, your Google Cloud costs are charged automatically in one or the two ways. You can see of like a monthly billing, which where costs are charged on a regular monthly cycle. And the second is the threshold billing, in which the costs are charged when your account has acquired a specific amount. For self-serve cloud billing accounts, your charging cycle is automatically assigned when you create the account. You do not get to choose your charging cycle and you cannot change the charging cycle. For invoice cloud billing accounts, you typically receive one invoice per month, and the amount of time you have to pay your invoice, means your payment terms, is determined by the agreement you made with the Google. Now let's understand the billing contacts. A cloud billing account includes one or more contacts that are defined on the Google Payments profile that is connected to the cloud billing account. These contacts are people who are designated to receive billing information specific to the payments instrument on file. For example, when a credit card needs to be updated. To access and manage this list of contacts, you can use the payments console or you can use the cloud console. Now understand the sub accounts under cloud billing accounts. So sub accounts are intended for resellers. If you are a reseller, you can use sub accounts to represent your customers' charges for the purpose of chargebacks. Cloud billing sub accounts allow you to group charges from projects together on a separate section of your invoice. A billing sub account is a cloud billing account that is owned by a reseller's parent cloud billing account. The The usage charges for all billing sub-accounts are paid for by the reseller's parent cloud billing account. Note that parent cloud billing account must be an invoiced billing. A sub-account behaves like a cloud billing account in most ways. It can have projects linked to it. Cloud billing data exports can be configured on it, and it can have identity and access management rules defined on it. Any charges made to projects linked to the sub-account or grouped and subtotaled on the invoice, and the effect on resource management is that access control policy can be entirely segregated on the sub-account to allow for customer separation and management. The Cloud Billing Account API provides the ability to create and manage sub-accounts. Use the API to connect to your existing systems and provision new customers or chargeback groups programmatically. Now let's understand the relationships between organizations, projects, and cloud billing accounts and payments profile. There are two types of relationships that govern the interactions between organization, cloud billing accounts, and projects. That is ownership and payment linkage. So ownership refers to an identity and access management permission inheritance, and payment linkages define which cloud billing account pays for a given project. Ownership of a cloud billing account is limited to a single organization. Payment linkage of a project linked to a cloud billing account is not limited by organization ownership. It is possible for a cloud billing account to pay for projects that belong to an organization that is different from the organization that owns the cloud billing account. The following diagram you can see shows the relationship of ownership and payment linkages for a sample organization. In the diagram, the organization has ownership over projects 1, 2, and 3, meaning that it is the IAM permissions parent of the 3 projects. The cloud billing account is linked to project 1, 2, and 3, meaning it pays for costs incurred by the 3 projects. Note that although you can link cloud billing accounts to projects, cloud billing accounts are not parents of projects in an identity and access management sense, and therefore projects don't inherit permissions from the cloud billing account they are linked to. The cloud billing account is also linked to a Google Payments profile, which stores information like name, address, and payment methods. In this example, many users who are granted identity and access management billing roles in the organization also have those roles on the cloud billing account or the projects. Now that you have a theoretical understanding of billing criteria in Google Cloud Platform, let's now see how it's been done practically by trying our hands on it on Google Cloud Platform. You can just directly go to the Google Cloud console. So I already have my account login here. If you don't have an account on Google Cloud Platform, create one. It's a very good platform to have your account on. You will just ask for a little bit of information, including debit or credit card details, and it will just deduct a very small amount of money, 1 or 2 rupees. That's it, and that will also be refunded soon. And what you will get is by creating a Google Cloud Platform account, you will get 90 days free trial in which you will get $300 of free credit, and you can use that for certain demos of like BigQuery or Bigtable, or you can say of compute engine virtual machine instances, launching any kind of service you can use using those free credits. Okay, so this is the project I can show you. Like you can go here and create a project. Okay, or you can I have like certain projects here, but I will create one more new project. Okay, so that I can show you how billing can be linked to this project. So I will just make the project is getting created. You can see the project name. Okay, this is the older one, so we will just open the new one, demo billing. Yeah, so now you can see the project name here, project ID is being shown, and project number, everything is here. But right now the billing account is not been linked to it, so we can just go here and open billing from here. So we can manage from here. What you can do is you can create a new billing account also. Like for this, we can say right now it's because it's been linked, because there is a limit of 3. Like if you are making projects, so only 3 accounts can be linked to a billing account. And right now, before making this project, I only had 1 account linked to it. So I just created another, and it got automatically linked to it. Okay, so it just got linked, and means it got it linked by itself. But you can if it don't get linked, you can, if you open this from like billing section, when you open now, from there only you can link the account. Like manage billing accounts is there. You can go here, and if you don't have a billing account, you can create one billing account from here, and then the account will be appropriated to it. The billing account will be attached to your project. Okay, so we can see like there is one active billing account, and if we close the active, then there are 2 accounts. This is the free tier account. Actually my free tier is over, so it's closed now. that is my billing account, that is the free tier account, and right now we are accessing is my billing account 1. Okay, so that's how it's get linked. And then what you can see here, like it's showing the billing account, my billing account 1 we are accessing right now. Now what we can do is we can set the budgets and alerts for it. So we can just go to budgets and alerts. Right now the budget is being created for that. We can delete this one. This is the older one, so we will just delete this one and we can create budget. So all you have to do is give a name. So we can say like custom billing. Okay, and you can like select for which you want to give. Like there are two projects are there, demo or demo billing, but we have to choose a demo billing, so we are just going to choose demo billing, or we can choose all of them also. It's up to us. And then we can go for all services. You can choose a specific service also, or you can choose all of them. So right now I'm choosing all of them. Yeah, and I've chosen all of them, and then I'm just right now unchecking it, just because we want to see the price like without our discounts and promotion applied to it. So we can just go to next then there are like two options here. You can see amount, like if you want to give the last month spend, whatever you have spent last month, that will be applied here, or you can just choose a specific amount. So I will just choose a specific amount for it, like I can give 1,000. Okay, and the maximum amount I'm going to choose, and that's 1,000. Now you can see you can like put a threshold over it. If the Google will notify you, it will mail you or something, so that you get the alert that 50% of your budget is being spent, or 90% of your budget is spent, or 100% of your budget is spent. Okay, and from like this is the amount, on that basis only it's showing. Okay, so we can also go for actual or forecasted. So actual is like, okay, when it gets spent, I mean. Okay, and forecasted mean when it will forecast that in how much time or in how much period of time it will get spent. It will notify you. Right now we are choosing actual, and you can like create another threshold if you want to. Like I can give at 1% also. So 1%, that will be 10 rupees. After 10 rupees will be spent, it will notify us, I mean, that this much amount is being spent. Okay, and you can like email alerts. Okay, it will email, so you can choose this so that you can get the email for threshold. Okay, you can just finish it. So custom billing has been made, and 0 credits are being used out of 1,000. That has been done. Then what we can do is go for billing export. How you want to get it export to your BigQuery. Okay, you can like export your billing, whatever your billing amount and every information regarding billing, that will be exported to your BigQuery. It's enabled actually, but it is enabled for demo, right? It's not enabled for our demo billing project. So what we can do is we can edit settings. We want to make it for demo billing, but right now we don't have a data set. So create new data set we can do. This is getting created in BigQuery, under BigQuery only. This data set is getting created. So demo bill underscore BQ we can give BigQuery. So data location default we can give, that's not a problem. So whichever location you want to choose, and enable table expiration. Like this is a very cool option. Like whatever data you are like getting saved in your table now under dataset, so for how many days should it retain. So you can give the number of days you want to retain, or if you don't want to delete it, so like just for a second you can understand, like you can give here 10 days. So if you give here 10 days, after 10 days only all the data under table will get deleted, even the table will get deleted. So in that sense you can just give the days here, or you can just remove it so that don't expires. Okay, so you can just create data set. Okay, must contain only letters. Okay, so demo bill BQ is okay. You can just create data set now. So data set is being created, demo bill BQ we can choose, and then we can save it. So BigQuery export is being getting created, and then we can like also enable it for pricing also. So we can just go to edit settings, and we can choose our project, that is demo billing and demo bill BQ. So we have to enable the data transfer API in BigQuery. So we can just enable it. So we can just now go back to the billing, and then we can go back to the billing export, and now we can do this. As the data transfer API is being activated, now we can go for demo billing, and we can choose the demo billing IQ and save it. Okay, so the pricing is being enabled for demo billing, and also the daily cost detail is also been enabled, and that will be saved in your BigQuery dataset under the table. Okay, whatever table it's been getting created under that BigQuery, so that will be there. You can see it in BigQuery also, like Just go here, BigQuery. You can see the demo bill IQ. You can see data set. So in this, the table will be created. Right now, it's not getting created, but means when the data will be exported, at that time the table will be created and the data will be saved here. So this has been showing in the BigQuery. Okay, and we can go back here, and now the last feature, like this is the main thing, that is cost table. You can come to cost table. It will show you about the cost of the resources you have used. So for this, like right now, I haven't made any resources in this billing account. What we can do is we can go to the that I have told you, like I have that free tier account. So we can go to that account. We can choose that account. Like if we can remove, we can go to the older account, that is closed one. But we can choose this one. So we can just go to my billing account, this, and now we can go to cost table. So here I have all the invoices for it because I have used resources in this. So we can choose this project. Okay, we will open this project demo. Now all the cost and everything which has been charged for this project is just showing here, cost, credit, and everything, because this was a free tier account. So all of whatever is charged, it been reimbursed at the same time. Okay, so you can choose for like compute engine. Every resource has been elongated here. So okay, we can just minimize it, recover it, I mean. So in demo we have a compute engine. So in compute engine we can see, like I have launched the instance and one predefined instance core for Americas and everything, however it has been given. So you can see the prices for it, like the cost 4297. The virtual machine instance which I have launched, it is showing the cost 4297. But we can check it from pricing calculator also, like how much does it cost. Open from pricing calculator from here. So just open pricing calculator, okay, and we can just check for instance, for compute engine instance, like how much does it cost. I might have ran that for around a month, actually 20 days or a month. So you can just compute engine and instances we are seeing. So number of instances we can say like 2 instances, but we can okay check for one only. So yeah, all these things are okay, no problem. That's machine type standard only might have I have chosen. So I had to estimate. So estimate cost it's showing is $48.92 per month. So that will come around like 4,000 5,000 only. So that's how I've been charged for it. Similarly, if you can see, like there is an N1 predefined instance core and N1 predefined instance core running in Americas, everything like how it has been charged 163. I have other instance that might be. Then there is a RAM running, so for that also it's been costed around 2147. That also you can check in pricing calculator only. So instances, okay, it will come in instances only, RAM and everything. So because it's a instance core and instance RAM. So and then we can see for E2 instance core how it costed 756 rupees. For everything you can see like the cost is given for every resource. Similarly, we can come for the app engine also. Just a second. What I can do is I can minimize it from here, compute engine. So now there is app engine. You can see similarly for the prices for it. The flex instance core hours Mumbai. In Mumbai I have launched it, so for Mumbai region, so it's costed 2089, and flex instance RAM in Mumbai it costed 277. Similarly, you can see it for Cloud SQL also. These are the prices, and for those prices you can choose the if you think it's really high, so you can check it for here, like what's the average price for the resource you are going to launch. Okay, for whatever you are like using, the resource you are using. So now you have understood like how it is costing, and if it is not similar to the cost it has been showing in pricing calculator, then you can redefine it and make it more efficient by understanding the costs and everything. So that's how the GCP billing prices works. So first, let's understand the best practices under data management. So first, you have to ensure a total visibility of data. Without a holistic view of data and its resources, it can be difficult to know what data you have, where data originated from, and what data is in the public domain that shouldn't be. Second, to design data loss prevention policies in GSuite. So data loss prevention in GSuite is a set of policies, processes, and tools that are put in place to ensure your sensitive information won't be lost during a fire, a natural disaster, or break-in. You never know when tragedy will strike. That's why you should invest in prevention policies before it's too late. Third is have a logging policy in place. So it is important to create a comprehensive logging policy within your cloud platform to help with auditing and compliance. Access logging should be enabled on storage buckets so that you have an easily accessible log object access. Administrator audit logs are created by default, but you should enable data access logs for data rights in all services. Also use display names in data flow pipelines. So always use a name field to assign a useful at a glance name to the transform. This field value is reflected in the Cloud Data Flow Monitoring UI and can be incredibly useful to anyone looking at the pipeline. It is often possible to identify performance issues without having to look at the code using only the monitoring UI and well-named transforms. Then moving on to the second category, that is cost optimization. So one of the best practices for cost optimization is to automate it, like automating the tasks and reduce manual intervention. Automation is simplified using a label, which is a key value pair applied to various Google Cloud services. You can attach a label to each resource, such as compute instances, then filter the resources based on their labels. So the second best performance under cost optimization is using preemptible virtual machines. As with most trade-offs, the biggest reason to use a preemptible virtual machine is cost. So preemptible virtual machines can save up to 80% compared to a normal on-demand virtual machine. This is a huge savings if the workload you are trying to run consists of short-lived processes or things that are not urgent and can be done anytime. So the third one is purchase commitments. The sustained usage discounts are a major differentiator for GCP. They apply automatically once your instance is online for more than 25% of the monthly billing cycle and can net you a discount of up to 30% depending on instance type. You can combine sustained and committed use discounts but not at the same time. Committed use can get you a discount of up to 57% for most instance types and up to 70% for memory optimized types. Fourth is utilize cost management tools that take action. Using third-party tools for cloud optimization help with cost visibility and governance and cost optimization. Make sure you aren't just focusing on cost visibility and recommendations, but find a tool that takes the extra step and takes those actions for you. This automation reduces the potential for human error and saves organization time and money by allowing developers to reallocate their time to more beneficial tasks. Now, the last best performance in the cost optimization is optimized performance and storage costs. In the cloud, where storage is billed as a separate line item, paying attention to storage utilization and configuration can result in substantial cost savings. And storage needs like compute are always changing. It's possible that the storage class you picked when you first set up your environment may no longer be appropriate for a given workload. Moving on to the next category, that is networking. So the first best performance in networking is use virtual private cloud to define your network. So use VPCs and subnets to map out your network and to group and isolate related sources. Virtual private cloud is a virtual session of a physical network. Virtual private cloud networks provide scalable and flexible networking for compute engine virtual machine instances and for the services that leverage virtual machine instances, including Google Kubernetes engine, Dataproc, and Dataflow, among others. VPC networks are global resources. A single VPC can span multiple regions without communicating over the public internet. This means you can connect and manage resources distributed across the globe from a single Google Cloud project, and you can create multiple isolated VPC networks in a single project. VPC networks themselves do not define IP addresses ranges. Instead, each VPC network consists of one or more partitions called subnetworks. Each subnet in turn defines one or more IP address ranges. Subnets are regional resources. Each subnet is explicitly associated with a single region. Then we have centralized, like you have to centralize the network control. So use shared VPC to connect to a common VPC network. Resources in those projects can communicate with each other securely and efficiently across project boundaries using internal IPs. You can manage shared network resources such as subnets, routes, and firewalls from central host project, enabling you to apply and enforce consistent network policies across the projects. With shared VPC and IAM controls, you can separate network administration from project administration. This separation helps you implement the principle of least privilege. For example, a centralized network team can administer the network without having any permissions into the participating projects. Similarly, the project admins can manage their project resources without any permissions to manipulate the shared network. Then connect your enterprise network. So many enterprises need to connect existing on-premises infrastructure with their Google Cloud resources. Evaluate your bandwidth, latency, and SLA requirements to choose the best connection option. If you need low latency, highly available enterprise-grade connections that enable you to reliably transfer data between your on-premises and VPC networks without traversing the internet connections to Google Cloud, then use Cloud Interconnect. And if you don't require the low latency and high availability of Cloud Interconnect, or you are just starting on your cloud journey, then use Cloud VPN. Now moving on to the next category of best practices, that is security. So under this, first one is like apply least privilege access controls or identity and access management. The principle of least privilege is a critical foundation element in GCP security. The principle is the concept of only providing employees with access to applications and resources they need to properly do their jobs. Second is manage unrestricted traffic and firewalls. Limit the IP ranges that you assign to each firewall to only the networks that need access to those resources. GCP's advanced VPC features allow you to get any granular with traffic by assigning targets by tag and service accounts. This allows you to express traffic flows logically in a way that you can identify later, such as allowing a front-end service to communicate to virtual machines in a back-end service account. And the third one is ensure your bucket names are unique across the whole platform. It is recommended to append random characters to the bucket name and not include the company name in it. This will make it harder for an attacker to locate buckets in a targeted attack. Fourth is set up a Google Cloud organizational structure. When you first log into your Google Admin Console, everything will be grouped into a single organizational unit. Any settings you apply to this group will apply to all the users and devices in the organizations. So, planning out how you want to organize your units and hierarchy before diving in will help you save time and create a more structured security strategy. Moving on to the next category, compute engine region selection. So the first one in this is when to choose your compute engine region. So early in the architecture phase of an app, decide how many and which compute engine regions to use. Your choice might affect your app. For example, architecture of your app might change if you synchronize some data between copies because the same users could connect through different regions at same time. Also, like price differs by region, and also process to move an app and its data between regions is cumbersome and sometimes costly, so should be avoided once the app is live. Second is we need to see the factors to consider while selecting regions. Okay, there are multiple factors where you decide to deploy your role. Okay, so first factor is latency. However, this is a complex problem because the user latency is affected by multiple aspects such as caching and load balancing mechanisms. In enterprise use cases, latency to on-premises systems or latency for a certain subset of users or partners is more critical. And the second factor affecting is price. So Google Cloud resources, if you see, like their costs differ by region. The resources available to estimate the prices are compute engine pricing, pricing calculator, Google Cloud SKUs, billing API. If you decide to deploy in multiple regions, be aware that there are network charges for data synced between regions. And the third factor affecting is co-location with other Google Cloud services. So co-locate your compute engine resources with other Google Cloud services wherever possible. While most latency sensitive services are available in every region, some services are available only in specific locations. Fourth factor affecting is machine type availability. Not all CPU platforms and machine types are available in every region. The availability of specific CPU platforms or specific instance type differ by region and even zone. The fifth factor affecting is resource quotas. Your ability to deploy compute engine resources limited to regional resources quotas. So make sure that you request sufficient quota for the regions you plan to deploy in. Moving on to the third best practice, that is evaluating latency requirements. So latency is often the key consideration for your region selection because high user latency can lead to an inferior user experience. You can affect some aspects of latency, but some are outside of your control. Region selection can only affect the latency to the compute engine region and not like entirety of the latency. So the first one in this is last mile latency. The latency of the segment differs depending on the technology used to access the internet. Then the second one is Google frontend and edge pop latency. These are like subcategories under evaluate latency requirements best practices. So second subcategory I mean is Google frontend and edge pop latency. Depending on your deployment model, the latency to Google's network edge is also important. This is where Google load balancing products terminate TCP and SSL sessions and from which Cloud CDN delivers cache results. Based on the content served, many round trip might already end here because only part of the data needs to be retrieved the whole way. Okay. So moving on to the third subcategory, that is compute engine region latency. So in compute engine region latency, the user request enters Google's network at the edge pop. The compute engine region is where Google Cloud Services handling requests are located. This segment is the latency between the edge pop and compute engine region, and it's wholly within Google's global network. So the fourth subcategory is app latency. Different apps have different latency requirements. Depending on the app, users are more forgiving of latency issues. Apps that interact asynchronously or mobile apps with a high latency threshold 100 milliseconds or more can be deployed in a single region without degrading the user experience. However, for apps such as real-time games or a few milliseconds of latency can have a greater effect on user experience. Deploy these types of apps in multiple regions close to the users. Now, moving on to the next category, that is AI platform training. We have different best practices under AI platform training also. So the first one is choose the right machine configuration for your training characteristics. You can choose arbitrary machine types and various GPU types. The machine configuration that you choose depends on your data size, model size, and algorithm selection. For example, deep learning frameworks like TensorFlow and PyTorch benefit from GPU acceleration, while frameworks like Scikit-learn and XGBoost don't. On the other hand, when you're training a large Scikit-learn model, you need a memory optimized machine. Okay, so the second one in this is don't use large machine for simple models. Simple models might not train faster with GPUs or with distributed training because they might not be able to benefit from increased hardware parallelism. Because the scikit-learn framework doesn't support distributed training, make sure that you use only the scale tier or custom machine type configurations that correspond to a single worker instance. And the third best performance is scale up before scaling out. So scaling up instead of scaling out while experimenting can help you identifying the configurations that are performant and cost effective. For example, start by using a single worker that has a single GPU and then try a more powerful GPU before you use multiple GPUs. After that, try distributed training as discussed later in the section. Scaling up is faster than scaling out because network latency is much slower than the GPU interconnect. And the fourth best performance under AI platform training is for large data sets, use distributed training. So distributed training platforms data parallelism on a cluster of nodes to reduce the time required to train a TensorFlow model when you use a large data set. Make sure that you adjust the number of iterations with respect to the distribution scales. That is, take the total number of iterations that are required and divide the total by number of GPUs multiplied by the number of work nodes. I hope you have understand all the best practices under the Google Cloud Platform.
Now moving on to our first topic, what exactly is Google Cloud Certification? Well, Google Cloud Certification is a level of Google Cloud expertise that an individual obtains after passing one or more certification exam. The certification validates your cloud expertise and helps you showcase your ability to help companies and businesses with Google Cloud technology. Now, some of the reasons to get a Google Cloud certification would be you will be more confident about your cloud skills. According to the survey response from the 2020 Google Cloud Certification Impact Report, 87% of the Google Cloud certified individuals are more confident about their cloud skills. Next, the Professional Cloud Architect was the highest paying certification of 2019 and also 2020. Next, more than 1 out of 4 Google Cloud certified individuals took on more responsibility and leadership roles at their work. Now, a company or an organization is more likely to work with an individual who is certified rather than a person who isn't. This is because the certification acts as a proof that you have knowledge about Google Cloud and you have worked on it before. Now, this was about Google Cloud certification. Now, let us move on to our next topic and see the types of certification. There are 3 levels of Google certification. First is the foundational certification, next is the associate level certification, and then comes the professional level certification. Now let us discuss about them one by one. The fundamental level of certification validates broad knowledge of cloud concepts and Google Cloud products, services, tools, features, benefits, and use cases. To sum it up, you should basically understand the capabilities of Google Cloud. Now, in this level of certification, there is only one certificate, which is the Cloud Digital Leader. This certification is appropriate for individuals in a non-technical job role who wants to add value to their organization by gaining cloud knowledge. This certification is also for someone who has little or no hands-on experience working on the Google Cloud. In the foundational certification, multiple choice and multiple select types of questions are asked. You will have 3 hours to complete this examination, and the registration fees for this examination is $99. You can write this examination in English. You can either write it online or in a test center near you. The next level of certification is the associate level. This level of certification focuses on the fundamental skills of deploying, monitoring, and maintaining projects on Google Cloud. In this level of certification also, there is only one certificate, which is the Cloud Engineer. Now, this certification is a good starting point for those who are new to cloud and can be used as a path to professional level certifications. It requires at least 6 months of work experience working on the Google Cloud. The types of questions which are asked in the associate examinations are also multiple choice and multiple select, but you will have only 2 hours to complete this exam, and the registration fees for this examination is $125 plus taxes. You can write this examination in English, Japanese, or Spanish. The last level of Google certification is the professional level. This level of certification ranges across various key technical job functions and accesses advanced skills in design, implementation, and management. The certifications are recommended for individuals with industry experience and familiarity with Google Cloud products and solutions. There are 8 professional cloud certifications in Google, which are the Cloud Architect, Cloud Developer, Data Engineer, Data Security Engineer, Cloud Network Engineer, Cloud DevOps Engineer, Collaboration Engineer, and Machine Learning Engineer. Now, this level of certification requires more than 3 years of industry experience, including more than 1 year of hands-on experience working on the Google Cloud. The types of questions asked in this examination are again multiple choice and multiple selects, but you'll have 2 hours to complete this examination. The registration fees for this examination is $200 plus taxes, and you can write this examination in English. Now, some of the professional certification exam can also be written in Japanese. You can either write this examination online or in a test center near you. Now, these were the types of certification. Now, let us move on to the next topic and see some of the major role-based certification. We will start by knowing the fundamental level certification, which is Cloud Digital Leader. A Cloud Digital Leader should have good understanding of Google Cloud core products and services and how they benefit the organizations. The Cloud Digital Leader should understand how the services can be used in real time to solve business problems and how cloud solutions support an enterprise, making it more efficient. This is the only Google Cloud certification that does not require any previous cloud experience nor requires hands-on experience with Google Cloud. So if you're just starting your cloud career and do not know where to begin, well, preparing for this certification should be your first step. The Cloud Digital Leader exam accesses your knowledge in 3 areas. The first is general cloud knowledge, second, general Google Cloud knowledge, and Google Cloud products and services. The next certification we'll talk about is the Associate Level Cloud Engineer certification. An Associate Cloud Engineer is expected to deploy application, monitor operations, and manage enterprise solutions. An individual appearing for this certification should be able to use Google Cloud Console and command line interface to perform common platform-based tasks to maintain one or more deployed solution that leverages Google managed or self-managed service on Google Cloud. Now, for this associate level certification, you will need more than 6 months of hands-on experience working with Google Cloud. The Associate Cloud Engineer exam examines your ability to set up a cloud solution environment, plan and configure a cloud solution, deploy and implement a cloud solution, and ensure successful operation of a cloud solution, and also configure access and security. The next certification we'll talk about is the Professional Level Cloud Architect certification. This certification is intended for individuals who are interested in designing and managing business solutions using Google Cloud Platform. According to Google Knowledge, Google Certified Professional Cloud Architect is the highest paying certification. Now, the Professional Cloud Architect should be able to use cloud technologies to maximize the benefit for their organization. They should have a thorough understanding of Cloud Architect and Google Cloud Platform. They should be able to design, develop, and manage robust, secure, scalable, highly available, and dynamic solutions to drive business objectives. For this certification, you should have more than 3 years of industry experience and also have 1 or more year experience architecting and managing solutions using GCP. The next certification is the Professional Cloud Developer. This certification is intended for individuals who want to build and test applications using Google Cloud Service. A professional cloud developer should be able to build scalable and highly available applications using Google recommended practices and tools. It should have hands-on experience with cloud-native application, developer tools, managed services, and databases. A professional cloud developer should be skilled with at least one high-level programming language and skilled at producing meaningful metrics and logs to debug and trace code. For this certification also, you should have more than 3 years of industry experience and more than 1 year of experience designing and managing solutions using Google Cloud. The rest of the professional certifications are the Data Engineer. This certification is intended for individuals who want to design and build data collecting and processing machine learning models on Google Cloud Platform. Next, we have Cloud DevOps Engineer. This certification is intended for individuals who want to work as a DevOps engineer. They should be efficient in both development and operation and should have good knowledge of various DevOps tools. They should build software delivery pipeline, deploy, and monitor services. The next certification is Cloud Security Engineer. This certification is intended for security engineers who have good understanding of security best practices and the current industry security requirements. They have to design, develop, and manage a secure infrastructure using Google Security Services. The next professional certification is a Cloud Network Engineer. This certification is intended for individuals who want to design, implement, and manage network architecture on Google Cloud Platform. Next is a Collaboration Engineer. This certification is intended for individuals who can understand an organization's mail routing and identify management infrastructure and be able to efficiently and securely establish communication and data access. They should have at least 1 year of Google Workspace administration experience. The next certification is the Machine Learning Engineer. This certification is intended for individuals who want to design, build, and productize ML models to solve business challenges using Google Cloud technologies. Now, these were the professional level certification. Now we will move on to a final topic for today, where I will give you a few tips to prepare for this certification. The first point is read the exam guide for the certification. Now, before you start practicing for the certification, I would suggest you to go through the exam guide. The exam guide contains domain and subdomains from which the questions are asked in the examination. This will give you a clear idea about what topics you should focus on in order to pass the examination. You will find the exam guide in the Google Cloud Certification official website. Next, the most important step is hands-on experience. If you're writing any certification examination except the Cloud Digital Leader, you should have at least 6 months of hands-on experience working on the Google Cloud. But if you're just starting your career in Google Cloud or want to start a career with Google Cloud, I would highly recommend you using the GCP free trial account. Now, Google provides all its new customers with free trial, which offers $300 in free credits. Now, they do this because they want you to fully explore and conduct an assessment on Google Cloud Platform. You can use this $300 to try various Google Cloud products and learn how to use them. You won't be charged unless you choose to upgrade, and it will be valid for 90 days. My next suggestion would be solving the sample questions. The sample questions will familiarize you with the format of the exam question and example content that may be covered on the exam. Now, solving the sample questions will help you improve your confidence. You can also refer Google white papers, which will give you technical knowledge about various Google Cloud concepts and services. If you want to follow a structured approach, then I would highly recommend you to opt for an online training certification. I would highly recommend Edureka certification training, which is curated by top industry experts. The certification course consists of demonstration, assignments, MCQs, and a certification project, which will help you master the concepts.
So first, let's understand who is a Google Cloud Architect. A Google Cloud certified professional cloud architect enables organizations to leverage Google Cloud technologies. Through an understanding of Google technology and cloud architecture, the individual designs, develops, and manages robust, secure, scalable, highly available, and dynamic solutions to drive business objectives. The cloud architect should be proficient in all aspects of enterprise cloud strategy, solution design, and architectural best practices. Also, the cloud architect should be experienced in software development methodologies and approaches, including multi-tiered distributed applications which span multi-cloud or hybrid environments. Now that you have understood who is a Google Cloud Architect, let's understand why there's a need for a Google Cloud Architect. First of all, let's look at the market trends for Google Cloud Platform. If you see for the first pie chart, in this you can see that the data is for Q1 of 2021, where we can see the top 3 cloud service providers. Like the first one, you can see the AWS for 32% market share, and then Microsoft Azure for 19%, and Google Cloud for 7%. And then there are various others and like a lot of cloud service providers, which constitutes to 42% of the market share. Now, if you see, AWS is actually the biggest cloud player because it was launched like way back in 2004. and after that Microsoft Azure, and then after that Google Cloud in 2010 was launched. But if you see, like initially it wasn't that much growing, but if you see in the last 3 years, so if you see this second graph from Q1 2018 to Q4 2020, you can see that AWS has 28% surge in market, and then Azure has 50%, where Alibaba Cloud has 54%, and the highest you can see is of Google Cloud, which is 58%. And Google Cloud is that's how grabbing the market like aggressively. It's because of its various services like ML and AI also, and of Cloud AI, like various BigQuery services. These are like the unique services which Google Cloud provide. We will talk about it later on. Okay. Now let's talk about the need of Google Cloud Architect certification. So Google Cloud certification validate your expertise and showcase your ability to transform with Google Cloud technology, and it enables organization to leverage Google Cloud technologies. Also, like 87% of the Google Cloud certified individuals are more confident about their cloud skills. And Professional Cloud Architect was the highest paying certification of 2020 and 2019. More than 1 in 4 of Google Cloud certified individuals took on more responsibility or leadership roles at work. Also, one of the major factor of a Google Cloud Architect certification, it helps in getting the candidate shortlisted in the company which is looking for a cloud architect. So this, first of all, what they see in a resume is whether you have a Google Cloud Architect certification or not. If you have it, then you will get shortlisted for sure. That's the major needs of a Google Cloud Architect certification. Now let's look at the job trends for Google Cloud Architect. So if you look at the IT sector, 86% of the enterprises have more than a quarter of their IT infrastructure running in cloud environments. And according to the study done by Gartner, the public cloud services market will like hit about $331.2 billion by 2022. And 52% of the enterprises spend more than $1.2 million annually on public cloud, as well as 26% of the enterprises spend more than $6 million, which is like really huge. Now let's look at the salary or say pay scale for a Google Cloud Architect. So according to Global Knowledge, the average pay for a Google Cloud Architect in India is 15.3 lakhs, whereas in US it is 175,000 US dollars, which is, you can understand, like a very high scale salary has been provided to Google Cloud Architects. Now let's understand why Google Cloud Platform is in great demand. We all know how big the database of Gmail, YouTube, and Google Search is, and I don't think in recent years Google server has gone down. It's actually one of the biggest in the world. So it seems an obvious choice to trust them, right? So now let's look at what really gives Google Cloud an upper hand over other vendors. So first of all, the major advantage Google Cloud has is of Google Cloud's IoT core, which is a fully managed service to easily and securely connect, manage, and ingest data from globally dispersed devices. Also, Google Cloud has a better pricing than its competitors, which means it's cost effective. Third, due to serverless computing, it is highly available and fault tolerant. With Cloud AI, Cloud Functions in GCP is the easiest way to run your code in the cloud integrated with machine learning technologies. Also, it is highly scalable as it uses auto scaling to automatically adjust the number of virtual machine instances that are hosting your application. So what it does is it allows your application to adapt to different varying amounts of traffic. Lastly, Google Cloud Smart Analytics solutions are fully managed, means big data analytics solutions. This multi-cloud analytics platform empowers everyone to get insights while eliminating constraints of scale, performance, and cost. It uses real-time insights and data apps to drive decisions and innovation. Now let's look at the job description of a Google Cloud Architect. So you can see here the job description of a Google Cloud Technical Architect of Accenture company, and the location you can see is Gurugram, Haryana. So now let's understand what type of work will be required by the company and what skills will you be performing on a regular basis. So the work experience, first of all, is required 4 to 6 years, a minimum of 4 years of overall hands-on experience in programming and data structures. Then strong cloud expertise in delivering data solutions, especially like database services and big data services on the Google Cloud platform. Also, Google Cloud Architect should be experienced in integrating cloud native services. Cloud native services are the like unique services for that particular cloud service provider. Means unique services which are in Google Cloud platform. The Google Cloud Architect should know about it and should know how to work on it and how to execute and make an output through it. So Google Cloud Architect should be like integrating cloud native services into secure, efficient, and scalable solutions. Also, Google Cloud Architect should know how to design data pipelines using cloud native data technologies, Means cloud native data technologies can be like storage accounts, Cloud SQL, Bigtable, BigQuery, Dataflow, Dataproc, etc. Also, the Google Cloud Architect should have a deep knowledge of RDBMS as well as of NoSQL for like database programming. And other non-technical or say professional attributes that the Google Cloud Architect should carry is analytical thinking and attention to details, good time management skills, and the ability to work to tight deadlines, and then capacity to work under pressure. These all things are required by a Google Cloud Architect. You can see the emphasis as the main of data solutions, cloud native services, data pipeline, cloud native data technologies, also of RDBMS and SQL. Now let's understand the roles and responsibilities of Google Cloud Architect, which he performs on a daily, weekly, or monthly basis. So the Google Cloud Architect should know how to design and deploy applications on Google Cloud Platform, which are dynamically scalable and available, fault tolerant, and also like it should be very much reliable and secure as well. Also, if the Google Cloud Architect is going to deploy an application, then he should know what kind of Google Cloud services should be used for it, for that kind of a deployment based on the given requirements. Especially, he should also know like how to migrate application, also like multi-tier applications, say the databases and a heavy database also on Google Cloud Platform. One more thing is he should make a strategy of how to work on Google Cloud Platform with the most optimization and cost saving techniques. And he should also know how to coordinate if there are new things are coming. He should be easily adaptable to the changes. Okay. Also, he should know how to implement multiple Google Cloud services and use multiple products of Google Cloud Platform in a way that it shouldn't cost much to the company or say organization. That means he should be well aware with the cost optimization techniques in Google Cloud Platform. Now let's understand the skills required by the Google Cloud Architect. So first of all, let's see the programming skills required by the Google Cloud Architect. So he should have an hands-on experience of SQL as well as NoSQL, which are like majorly required for database programming and database migration and for querying purposes. He should also know the Python programming language, maybe not to the expertise or in very advanced level, but at least at an intermediate level, so that he can create, analyze, and organize large chunks of data, as well as it's very useful for using ML and AI products like natural language processing and means natural language understanding and auto ML products. For these purposes, Python is very much required. Also, for the application development purposes, he should know the Java programming language. Also, for web development purposes, he should carry a good knowledge of HTML, CSS, and JavaScript. Now, let's see the operating systems, which the Google Architect should be well aware of and should have a good knowledge of, like Linux, Solaris, Ubuntu, Windows, Unix. But preferably, I would say he should have a good knowledge of Linux as it brings the features like open source, security, customization, and is adopted by different cloud platforms as well. He should also have a very good knowledge of security and identity fundamentals in Google Cloud Platform, like identity and access management, like how to provide certain access management to certain users. If an employee is working under him and if he is handling any team, then he should know what kind of access he should provide to that person, to that employee, I mean, and what are the roles and policies of identity and access management. Also, you should be well aware of cloud compliance techniques. So, cloud compliance is like the principle that cloud delivered systems must be compliant with the standards their customers require. And cloud compliance ensures that cloud computing services meet compliance requirements. Lastly, he should be well aware of data privacy. If he is uploading any data on cloud or if he is extracting any data from the cloud, import, export, everything. So, he should be well aware of the data privacy and how to protect and secure data from exploitation. So Google Cloud Architect is also required to have a good knowledge of networking as well. Means networking in Google Cloud Platform. Like you should have a very good knowledge of Cloud CDN, which is a cloud delivery network for service, web, and like video content, and also of Cloud DNS, which is a domain name system for reliable and low latency name lookups, as well as of hybrid connectivity options for VPN, peering, and enterprise needs. On a whole, Google Cloud Architect should know how to design networking ways to make sure the network is responsible to user demands by building automatic adjustment procedures. Lastly, he should be very well aware of cloud storage techniques in Google Cloud Platform and especially like usability and accessibility through cloud storage, how easily cloud storage can be used and accessed. Secondly, he should ensure the security for storage. If he is storing any data, he should be ensuring that how he can use security techniques to secure the data, and whatever services he is combining with cloud storage, it should be cost efficient, as well as the service he is using, like cloud storage service if he is using, he should be able to optimize it in a way that it should cost the least to the organization. As well as he should be using it that it's very portable or you can say like very easily usable, so that will be convenient for the organizations and for the client. Also, he should know how to automate the data he is storing in cloud storage, and the data should be synchronized with the multiple devices, or we can say with the lead device of the organization. And also, he should be well aware of the disaster recovery in cloud storage, so that if the data gets lost, then it can be backed up later on. Now, when we come to data storage, so there are like four types of storage. So the first is standard storage, which is good for hot data that's accessed frequently, including websites, streaming videos, and mobile apps. Second is nearline storage, which is like for low cost, good for data that can be stored for at least 30 days, including data backup and long tail multimedia content. Then there's cold line storage, which has a very low cost, good for data that can be stored for at least 90 days, including disaster recovery. Then there is archive storage, so which has a lowest cost, good for data that can be stored for at least 365 days, including regulatory archives. Now, these are the non-technical skills required by the Google Cloud Architect, that he should be flexible in working, and he should have leadership skills as well to lead a team, and he should be business oriented, that how to profit the organization. If he is working on any project or something, he should know that how to extract out the maximum leads, or you can say the maximum profit for the business. Also, he should have very good communication skills, so that he can lead a team, or he can connect multiple teams, or he can easily handle the clients as well. Now let's understand how one can become a Google Cloud Architect. For becoming a Google Cloud Architect, you should know cloud native services, means which are the unique services, you can say like Firebase, Firestore, App Engine, or Google Kubernetes Engine, Cloud Run. You should have a good hands-on experience, or say a very deep knowledge of these cloud native services. Also, you should be well aware of database programming, like both SQL and NoSQL, so that you can handle SQL databases as well as NoSQL databases. Like there is a Cloud SQL, and then there is a Cloud Bigtable, Firestore, also like Memory Store, Cloud Spanner. All these are database services provided in Google Cloud Platform. Also, you should be well aware of big data solutions, so that big data services in Google Cloud Platform can be easily managed, like BigQuery and Dataproc or Cloud PubSub or Dataflow. These all big data solutions you should be well aware of. Also, you should carry very fine analytical skills. Also, you should be well aware of application development. Like you can use App Engine in Google Cloud Platform for developing the applications, for deploying, also for deploying purposes also. Also, you should know the automation process in Google Cloud Platform. Like there is a free Google Cloud Platform automation software from 𝐏𝐻𝐻𝐿. So 𝐏𝐻𝐻𝐿 is a like tool for scheduling non-production instances on Google Cloud Platform that helps companies reduce their cloud computing costs, also like improve their IT governance, increase accountability, and optimize their cloud computing resources as well. Also, you should be well aware and have a good knowledge of DevOps products and integrations, so that you can build and deploy new cloud applications, or store artifacts and monitor app security and reliability on Google Cloud. Like there is a cloud build and artifact registry. Like cloud build, you can say like it defines custom workflows for building, testing, and deploying across multiple environments. And artifact registry is used for storing, managing, and securing your container images and language packages. All these things you should be well aware of. Also, you should be flexible enough to work in a fast-paced environment as well. Also, you should be well aware of the compute services as well, like there's Compute Engine, where you can run virtual machines in Google's data center. And also, like there is a Google App Engine, which is a serverless application platform for apps and backends. Also, like cloud GPUs and preemptible virtual machines and shielded virtual machines, you should be well aware of, and should also have a like hands-on experience also. Other than that, there are also like ML and AI services, which is very unique in like Google Cloud, and Google Cloud is actually famous for its ML and AI services. So that is something you should be like, you should have a deep knowledge and a hands-on experience, and you should really be well aware of it. So you can see like there are certain services like Auto ML, Vision AI, and like there's cloud translation for language detection, translation, and there is a cloud natural language for sentiment analysis, and video AI is also there for video classification and recognition. This is like for deep learning. All these things, this is something you should have an hands-on experience, and you should know really, really well. This is what companies are targeting for. Then lastly, you should know how the Google Kubernetes engine work, and you should know about the architectural working of Kubernetes engine. So there are like two modes of Google Kubernetes engine, means there are two modes of operation Google Kubernetes engine. They are like standard and autopilot, and like there's also podding, cluster auto scaling in it, and there is like pre-built Kubernetes applications and templates are also there. Also, like a container native networking and security is also being provided by GKE Sandbox, means Google Kubernetes Engine Sandbox. So these are some of the concepts you should be well aware of. Other than that, you should also have a very good communication skills to handle clients and handle teams and multiple teams as well. Now let's see the Google Cloud certification provided by Edureka as well. So you can see how I have explained you step by step. Like Google Cloud certification training is designed to meet the industry benchmark. It's of course the industry relevant course, and then there are multiple batches for it. Right now there is a July 31st batch which is filling fast. Then is also like August 28th batch. They are like monthly batches. You can register for them. As I have like explained you step by step how Google Cloud certification is needed and why you need to be certified Google Cloud architect. You can see I have explained you compute services for like virtual networks, all these things, and compute services and security and identity fundamentals. As I've explained you, like the identity and access management and cloud compliance and data privacy things. Other than that, data storage services, and these are like the fundamentals. Like these services you should actually be knowing, and how where you should implement these services for what requirement. This is how the industry relevant Google Cloud Platform Architect course is being constructed by Edureka, and it can surely help you in also cracking the Google Cloud Platform exam that we are going to talk about. Then there's, you can see, like I have explained you DevOps, automation, everything I have explained you. So as I have told you how these services are very much important, and these are the services you should target for. So you can register for Edureka Google Cloud Platform Architect certification. So this was all about how to become a Google Cloud Architect. Now let's understand how to crack Google Cloud Architect exam. If you don't know much about Google Cloud Architect exam, it is valid for 2 years and it's a 2 hour exam. When you are prepared for it, you can actually apply for it. That you can look at the documentation part of a Google Cloud platform. For cracking Google Cloud Architect exam, you should know how to design and plan a Google Cloud solution architecture, like designing a solution infrastructure that meets business requirements, and consideration for that includes business use cases and product strategy, cost optimization, supporting the application design, integration with external systems, movement of data, as well as like design decision trade-offs and build, buy, modify, or depreciate. Also the compliance and observability as well. Other than that, designing a solution infrastructure that meets technical requirements like high availability and failover design, scalability to meet growth requirements, and performance and latency. And while designing in network storage and compute services, you should consider integration with the on-premises or multi-cloud environments, choosing data processing technologies as well, and choosing compute resources, and mapping compute needs to platform products. Then also like creating a migration plan, that is documents and architectural diagrams, for which the considerations include integrating solutions with existing systems, migrating systems and data to support the solution. Also for software license mapping and network planning. Also like depending management planning and envisioning, especially like envisioning future solution improvements. Considerations for that include cloud and technology improvements and evolution of business needs and evangelism and advocacy. Second thing is you should know how to manage and provision a solution infrastructure. So for that, you need to configure network topologies, and you should consider extending to on-premises environments and extending to a multi-cloud environment that may include Google Cloud to Google Cloud communication. So one more thing is there while configuring network topologies, that is security protection. Also, while managing and provisioning a solution infrastructure, you should configure individual storage systems, and you should consider data storage allocation for that and data processing, as well as compute provisioning and security and access management, as well as data growth planning. Also, like you should configure compute systems as well while managing and provisioning, and you should consider compute resource provisioning for that and compute volatility configuration as well. Now, the third thing is you should know how to design for security and compliance. While designing for security, consider identity and access management, also like resource hierarchy and data security, and separation of duties and security controls like auditing VPC, service controls, etc. And also like managing customer managed encryption keys with cloud key management services and remote access as well. And second thing under designing and security of compliance is designing for compliance. For that, consider legislation and commercial as well as industry certifications and audits as well, like including logs. So the fourth step is analyzing and optimizing technical and business process. So while analyzing and defining technical process, consider software development lifecycle and continuous integrations or continuous deployment, as well as troubleshooting and testing and validation of software infrastructure. Other than that, service catalog and provisioning and business continuity and disaster recovery as well. Second step is to analyze and define business processes. And for that, you need to consider stakeholder management, change management, team assessment, decision making processes, customer success management, cost optimization, resource as well. Third thing under analyzing and optimizing technical and business processes, developing procedures to ensure reliability of solutions in production. Like you can take, for example, chaos engineering and penetration testing. Fifth step is managing implementation. So that can be done by advising development or operation teams to ensure successful deployment of the solutions. And for that purpose, you need to consider application development, API best practices, test framework, and data and system migration and management tooling. So implementation can be managed also by interacting with the Google Cloud programmatically. And for that, you need to consider Google Cloud Shell, Google Cloud SDK, also like cloud emulators, means Cloud Bigtable, Data Store, Spanner, PubSub, and Firestore as well, etc. So the last step is ensuring solution and operations reliability. And for that, you need to consider monitoring, logging, profiling, alerting solutions, as well as deployment and release management, assisting with the support of deployed solutions and evaluating quality control measures.
Now, starting with our interview questions, we are first going to see some general cloud computing and Google Cloud Platform questions, then questions on compute and hosting domains, then storage and databases, next networking, followed by big data, machine learning, and cloud artificial intelligence. So I guess it is clear what all we're going to talk about today. So let's get started. So the first question we're going to discuss is, what is cloud? Now there are various ways to answer this. One of them could be, the cloud can be referred as a global network of servers, each with a unique function. These servers are designed to store and manage data, or to run various applications, or deliver content, and have many more functionalities. You can also mention that the servers are located in data centers across the world. You can also talk about the various service cloud offers such as compute, storage, databases, networking, and so on. Now I want you to understand the concepts and frame the answer in your own words. Moving on to our next question. What is cloud computing? Now, like the previous question, even this question can be answered in many ways. So to answer this question, I would say cloud computing is an on-demand availability of computer system resources. Now, these resources could include computing power, storage, databases, and so on. With cloud computing, you don't have to buy or own or maintain physical data centers and servers. You can just rent these resources whenever you need them from a cloud service provider. Now here you can also mention what are cloud computing used for. Like it can be used for data backup, disaster recovery, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. So now moving on to a third question. List the type of service model available in cloud computing. So there are three types of service model available in cloud computing. That is IaaS, PaaS, and SaaS. IaaS stands for Infrastructure as a Service. In this service model, you can rent IT infrastructure such as servers and virtual machines, storage, networks, and operating system. Let's say a user wants to use a Linux machine. He can access the Linux machine using IaaS service model without worrying about the physical machine or the networking of the system on which the OS is installed. The next service model is Platform as a Service. This service model provides an on-demand environment for developing, testing, delivering, and managing your software application. The users don't have to worry about setting up or managing the underlying infrastructure of servers, storage, networks, and databases which are needed for development. This is taken care of by the cloud service provider itself. The next service model is Software as a Service. In this service model, the cloud providers leases application and software which are owned by them to its client. The clients can access the software on any device which is connected to the internet using tools such as web browser or an application. Now to summarize this answer, just think of it as this way. Infrastructure as a service provides you with an infrastructure such as virtual machine or a servers, whereas platform as a service provides you with a platform where you can develop, test, and run your application. And software as a service provides you with the software itself. Now I guess you have some idea about service models which are available in cloud computing. Let us move on to the next question. The next question is list the types of cloud deployment model. So there are 4 types of cloud deployment model, which are public cloud, private cloud, hybrid cloud, and community cloud. In public cloud deployment model, the resources such as application and storage are available to general public over the internet. These resources can be free or sold on demand, which will allow users to pay only per usage for the CPU cycles, storage, or bandwidth they use. Now, when we talk about private cloud, it is operated solely for a single organization. It offers services over a private internet network, which is typically hosted on premises. Now, this private cloud is costlier, but there is high level of security. Next, the hybrid cloud deployment model can be defined as a combination of public and private cloud. It can share services between public and private clouds depending on their purpose. The fourth cloud deployment model is the community cloud. Now, the community cloud infrastructure is shared between several organizations from a specific community with a common concern. Educational universities that are cooperating in the same area of interest as that of a research institute can use the same community cloud. Now, these were the 4 types of cloud deployment model. So now let us move on to the next question and see what are the benefits of cloud computing or why companies are increasingly adopting cloud computing. So now here you can mention some of the benefits of cloud computing, such as there is reduced cost of managing and maintaining IT system or infrastructure. The next benefit is scalability of the IT resources. You can scale up or scale down your operational and storage needs according to your convenience. The next benefit is it provides better productivity and collaboration efficiency. For example, if your team is working on a project across different locations, you can use cloud computing to give your employees, contractors, and third-party access to the same file. The next benefit is data backup and storage. You can elaborate this by saying your data is backed up, so you don't have to worry if your data is lost or deleted. The next advantage is cloud service providers provide automatic updates. This would include up-to-date version of software as well as upgrades to servers and computer processing power. Now, these were just some of the benefits of cloud computing. We can also mention some more benefits of cloud computing. So now let us move on to the next question. So the next question is, what is 𝐄𝐝𝐿? 𝐄𝐿 is the abbreviation for Elastic Utility Computing Architecture for linking your program to useful systems. It is an open source software infrastructure that helps in implementation of clusters in the cloud computing platform. It can build public, hybrid, and private cloud and has the ability to create a data centers into a private cloud. It also helps the user to utilize their functionalities across those other organizations. Now, these were some of the general cloud computing questions that can be asked in a GCP interview. So now let us move on to the next set of questions on Google Cloud Platform. So first question is, what is Google Cloud Platform? We all know Google Cloud Platform is a cloud service provider, but just to define it, Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. It runs on the same cloud infrastructure that Google uses internally for its end user products such as Google Search, Gmail, Google Photos, and YouTube. Now, this is a very basic question, but even this can be asked in your interview. The next question is, what are the various services offered by GCP? The various services offered by Google Cloud Platform are compute services, storage and database services, networking services, big data services, identity and security services, Internet of Things services, then machine learning and cloud artificial intelligence services. Moving on to our next question, what is Google Cloud SDK? Google Cloud SDK or Google Cloud Software Development Kit is a set of command line tools. It is used for the development of Google Cloud. With these tools, you can access the compute engine, cloud storage, BigQuery, and other services directly from the command line. So now I guess you have understood what is Google Cloud SDK. So let us move on to the next question and see what is Google Cloud APIs. Google Cloud APIs are programmatic interface to Google Cloud Platform services. They are a key part of Google Cloud Platform, which allows you to easily add the power of everything from computing to networking to storage to machine learning based data analysis to your applications. Now moving on to our next question, why would you prefer GCP over other cloud service providers? Well, here you are expected to say the benefits of GCP. We can start the answer by saying, well, each cloud service provider has its own pros and cons. But what makes Google Cloud Platform unique is it offers a much better pricing model compared to the other cloud service providers. Next, considering hosting cloud services, GCP has an overall increased performance and service. You can also mention Google Cloud is very fast in providing updates about servers and security in a better and more efficient manner. You can also mention the security level of Google Cloud Platform is excellent. The cloud platform and the networks are secured and encrypted with various security measures. So I guess you got some idea about how to answer this question. So now let us move on to the next question and see what is projects in GCP and how to create one. A project organizes all your Google Cloud resources. A project consists of a set of users, a set of APIs, and billing, authentication, and monitoring setting for those APIs. So for example, all of your cloud storage buckets and objects, along with the user permission for accessing them, all this resides in a project. So in order to create a project, you have to sign in to Google Cloud Platform Console. Then on the top left corner, you will have an option called as project. Select that and click on new project to create a new project, or you can also select an existing project from the list. So now I guess you have some idea about projects in GCP. So let us move on to the next question. Our next question is, what is Cloud Shell? So if you have been using GCP, you will know what is Cloud Shell. So for people who don't know what Cloud Shell is an online development and operational environment which is accessible anywhere with your browser. You can manage your resources with its online terminal, which is preloaded with utilities such as 𝐔𝐿 command line tool, 𝐄𝐝𝐶TL, and many more. We can also develop, build, debug, and deploy a cloud-based application using the online Cloud Shell editor. So this was about Cloud Shell. Our next question is, what are availability zones and region? And how many availability zones and regions are there in GCP? So a region is a specific geographical location where you can host your resources. And availability zones are isolated locations within these regions from where public cloud services originate and operate. And then talking about Google Cloud Platform availability zones and region, it has 25 regions with 76 zones. Each region has at least 3 or more zones. The next question right after this could be, how would you choose an availability zone? Or what all parameters would you consider while selecting an availability zone? So you can answer this by saying you have to select the availability zone based on the following factors. The first factor is latency. Opt for the closest region for low latency. Fast connection to the servers ensures better performance in terms of quick loading and transfer time, which results in overall better user experience. So choose a region that is closest to the majority customer base. And then the next factor you should consider is the cost. Different regions will have different costs for the resources. For example, if I want to use an EC2 instance virtual machine in the US Central region, it would cost me somewhere around $48 per month. But the same virtual machine in Mumbai region would cost me $58. So you can see there is $10 difference per month in these two regions. So these are the factors you need to keep in mind before selecting an availability zone and region. So these were some of the general Google Cloud Platform questions. So let us move on to the next set of questions on compute and hosting services on GCP. So the first and basic question they could ask is, what is Google Compute Engine? Because Google Compute Engine is a primary compute engine in GCP. So you can explain this in a very simple term. It is a secure and customizable compute service that lets you create and run virtual machines on Google's infrastructure. So now moving on to our next question, what is Google App Engine? So App Engine is a fully managed serverless platform for developing and hosting web applications at scale. It allows you to choose from several popular languages, libraries, and frameworks to develop your application, and then the App Engine takes care of provisioning servers and scaling your application instances based on the demand. So now when you answer this question, they might ask you, what is serverless computing? So serverless computing is nothing but a cloud computing execution model in which the cloud provider allocates machine resources on demand, which means they take care of servers on behalf of the customers. So the customers can only focus on building your application while the servers and all that is taken care of by the cloud service providers. So I guess you have some idea about serverless computing. So now let us move on to our next question. Now this question is a frequently asked question. How are Google App Engine and Google Compute Engine different from each other? You can answer this by saying Google Compute Engine and Google App Engine are complementary to each other. Google Compute Engine is an infrastructure as a service product, whereas Google App Engine is a platform as a service product of Google. So now if you want the underlying infrastructure in more of your control, then Compute Engine is a perfect choice. For instance, you can use Compute Engine for the implementation of customized business logic or in case you need to run your own storage system. On the other hand, you can use Google App Engine if you do not want to provision and manage your servers or scale them. Now I guess you have understood the difference between Google Compute Engine and Google App Engine. So now let us move on to our next question, which is how does the pricing model work in GCP Cloud? So to generally answer this question, you can say, while working on Google Cloud Platform, the user is charged on the basis of compute instances, network use, and storage by Google Compute Engine. Now you can see here, I'm not specifically talking about a particular service. This is just a general overview. Google Cloud charges virtual machines on the basis of per second with a limit of minimum of 1 minute. Then the cost of the storage is charged on the basis of the amount of data that you store. The cost of the network is calculated as per the amount of data that has been transferred between the virtual machine instances while communicating with each other or over the network. Over the network means the internet. You should prepare yourself with the questions on Google Cloud Platform pricing models, as these are among the most common Google Cloud interview questions. So moving on to our next question, what is Google Kubernetes Engine? Google Kubernetes Engine or GKE provides a managed environment for deploying, managing, and scaling your containerized application using Google infrastructure. Basically, in simple terms, it's a platform to deploy and manage containerized applications. So this was the definition of Google Kubernetes Engine. The next question is a scenario-based question. So if I want to run my application on GCP, which product would I use? You can answer this by saying it depends on the application requirements. GCP basically offers 4 means for application deployment, such as Google Compute Engine, Google Kubernetes Engine, Google App Engine, and Cloud Functions. You can use Google Compute Engine if you want to run your application on a customizable virtual machine platform. Next, if you want to run a containerized application, you can use Google Kubernetes Engine. You can use Google App Engine if you do not want to manage the infrastructure and just deploy the application without worrying about scaling your servers. Next, with Cloud Function, it will run your application after an event-driven function. That means only after a particular event occurs, your application will be deployed. So these were the 4 primary means for application deployment model. You can also tell the interviewers you can use a combination of these services. So let us see the next question. The next question is how to migrate servers and virtual machines from on-premises or another cloud to Compute Engine on GCP. So if the interviewer asks you this question, you can just say Google provides a cloud software known as Cloud Migrate for Compute Engine. The software is used to migrate the virtual machines from on-premises data centers or any other cloud service providers into Compute Engine in the GCP platform. You can also mention the software is provided by Google itself and it comes with no additional cost. Now they can also ask this question as what is Cloud Migrate for Compute Instances? The answer would be the same. So now let us move on to the next question and see why should you opt for Google Cloud hosting? This question is usually asked in Google Cloud consultant interviews. The interviewer may ask this question to check your knowledge and explanation skills about Google Cloud. So here talk about the advantages of choosing Google Cloud hosting. The first advantage is it provides a better pricing plans. Next, there is a benefit of live migration of virtual machines, which means you can migrate a running virtual machine to and from any cloud service providers or on-premises also. The next benefit is it provides enhanced performance and execution. It also has strong control and security of the cloud platform. The next benefit is it has inbuilt redundant backup, which will ensure data integrity and reliability. So these were some of the benefits of Google Cloud hosting. Let us move on to the next question and see what are shielded virtual machines. Shielded virtual machines are virtual machines on Google Cloud which are hardened by a set of security control that helps them defend against threats such as malicious project insiders, malicious guest firmware, and kernel or user mode vulnerability. Using shielded virtual machines help protect enterprises' workload from threats like remote attacks and malicious insiders. So these were some of the questions on compute and hosting services in GCP. So now let us talk about the interview questions in storage and database services in GCP. So our first question in storage and database section is, what is cloud storage? Well, cloud storage is a primary storage service in GCP. It is a service offered by Google for storing your objects in the Google Cloud. Now an object is an immutable or unchangeable piece of data consisting of files of any format. Now object can be unstructured data such as music, images, videos, backup and log files, or archive files. Also, objects have two components, which are object data and object metadata. While object data is typically a file that you want to store, and object metadata is a collection of name-value pairs that describes the various object qualities. Now you store these objects in containers called buckets. So when you mention about buckets, there is a high probability of the interviewer asking you, what are buckets in cloud storage? Well, buckets are nothing but a basic containers that hold your data. Now everything that you store in cloud storage must be contained in a bucket. You can use bucket to organize your data and control access to your data, which means you decide who has access to your data. You can create a bucket by specifying a globally unique name for your bucket, also specifying a geographical location where the bucket and its contents are stored, and also a default storage class. So this was about buckets in cloud storage. The next question we're going to discuss is, what are the types of GCP storage available and in what scenarios do we use them? Now here we've already talked about cloud storage, so we'll move on to the other GCP storage services. Now it offers Google Drive, which can be used to store, manage, and share your personal files. Next we have cloud storage for Firebase, which helps you manage data in your mobile applications. The next storage service is persistent disk. Now this is a block storage which can be added to your compute engine virtual machines. And last we have file store, which allows you to store files or create a file-based workload. So these were the GCP storage services. Our next question is, what is object versioning in GCP? Well, object versioning is used to retrieve objects which are overwritten or deleted. So let's say I have updated a file in cloud storage. Now the updated file and the file before updating, both versions will be available to me. So if the updated file gets deleted by mistake, or I want to check what were the file before the update, I can do that with the help of object versioning. One disadvantage of this would be it increases the storage cost, but it would provide me security for objects when they're deleted or overwritten. And on enabling the object versioning in GCP bucket, a non-concurrent version of the object is created every time when the object is overwritten or deleted. So the next question in storage and database section is, what are the libraries and tools for cloud storage on Google Cloud Platform? Well, you can answer this question by mentioning the libraries and tools such as Console, GSUtil, Client Libraries, and REST APIs. Now, Console is nothing but the Google Cloud Console, which provides a visual interface for you to manage your data and perform basic operational on objects and buckets. Next, GSUtil is a command line tool that allows you to interact with cloud storage through a terminal. Next, we have the Cloud Storage Client Libraries, which allows you to manage your data using one of the preferred language, which would include C++, C#, 𝐏𝐤𝐚, Java, Node.js, PHP, Python, or Ruby. The next tool for accessing cloud storage on GCP is REST APIs. Now you can manage your data using the JSON or XML APIs. So these were the libraries and tools for cloud storage on Google Cloud Platform. So now moving on to our next question, how can I maximize the availability of my data, or how can my important data be more secure and available to me? You can answer this by saying you can store your data in multi-region or dual region bucket location if high availability is a top priority. This ensures that your data is stored in at least 2 geographical separated regions, which will provide you continued availability even in the rare event of a region-wide outage, which includes anything caused by natural disasters. So this is what GCP offers for more availability of their data. Moving on to our next question, what is Cloud SQL? Well, Cloud SQL is a fully managed database service that helps you set up, maintain, manage, and administer your relational database on the Google Cloud Platform. We can also mention you can use Cloud SQL with MySQL, PostgreSQL, or the SQL Server. Well, Cloud SQL is one of the core database services in Google Cloud Platform. The next question is, how would you choose the right Google Cloud Database Service? Well, this would definitely depend on the requirement. You can select from any of these options. You can select either Cloud SQL, Cloud Spanner, Cloud Firestore Data Store, Cloud Big Data, or Cloud Memory Store. You can choose Cloud SQL when you need relational database capacity, but do not need storage capacity over 10 TB or more than 4,000 concurrent connections. Next, you can select Cloud Spanner when you plan to use large amount of data, which is typically more than 10 TB, and need transactional consistency. Next, you can use Cloud Firestore or Data Store when you plan to focus on application development and need live synchronization and offline support. The next option is Cloud Bigtable. Now, Cloud Bigtable is a good option if you're looking for large amount of single key data, in particular, which is good for low latency and high throughput workloads. And the last option is Cloud Memory Store. Now, this would be a good option if you're looking for key value datasets and your primary concern is transactional latency. These were some of the Google Cloud Database Services. So now let us move on to our next question, which is a scenario-based question. So the question is, can my app engine in one region access the Cloud SQL instance which is present in a different region? Well, the simple answer for this is yes. If you're connecting to a MySQL instance, your App Engine application does not need to be in the same region, and it can be running in either the standard or the flexible environment. However, a larger distance between your Cloud SQL instance and your App Engine application causes greater latency for connection to the database. Now, latency is nothing but a delay in the transmission of data. So the next question in the storage and database section is, can I import or export a specific database in Google Cloud Platform? Well, the answer for this is also yes. For MySQL instances, you can import and export either a single database or multiple databases. And for PostgreSQL instances, you can only import or export a specific database. Now, these were some of the questions in storage and database service in GCP. Now, let us move on to the next set of questions in networking. So the first question in this section is, what is Google Cloud VPC? Now, if you're applying for any Google Cloud job, you're expected to know this answer. Virtual Private Cloud in GCP is a virtual network that provides connectivity to all your virtual machine instances. It could be your compute instance, Google Kubernetes Engine clusters, or your App Engine flexible environment, and any other Google Cloud products which are built on the compute instances. So you don't have to talk in detail about VPC. You can just define it so the interviewers knows that you have some knowledge about VPC. So the next question is, how is Google VPC different from any other cloud service provider's VPC? So as you can see in the diagram, in the traditional VPC or the VPC provided by other cloud service providers like AWS, the architecture would look something like this. Now here in the first diagram, you can see there are two VPC built with two different subnets in two different regions, which are US West and US East. Now the virtual machine in one region can access the internet and communicate with the other virtual machine only through the VPC gateway. Now this gateway acts as an interface. So now in a traditional VPC, one virtual machine cannot directly communicate with the other virtual machine. Now in Google version of Virtual Private Cloud, it follows a global construct, which means instead of creating a VPC in US East and US West, you can just create one VPC and put the subnets in different regions within that VPC. Now in this case, the virtual machines present in one region can directly communicate with the virtual machine in the other region without the help of VPN gateway. Now I guess you have some idea about how Google VPC is different from the VPC of other cloud service providers. Now if you have understood the concept, you can put the answer in your own word and explain it. The next question in networking is, what are routes and firewall rules? Now when we talk about VPC, this question comes tagged along. Now route tells the virtual machine instances and the VPC network how to send traffic from one instance to the destination. This destination can be either inside the network or outside of the Google Cloud, which is typically the internet. Next, firewall rules are rules which allow you to control which packets can travel to which destination. It lets you allow or deny connection to and from your virtual machine instances based on the configuration that you specify. So this was about routes and firewall rules in Google Cloud Networking. So our next question is, what is load balancing? Now this is a frequently asked question in many GCP interviews. Load balancing is a process of distributing the computing resources and workload in a cloud computing environment to manage the demands. By spreading the load, load balancing will reduce the risk that your application will experience performance issues. By using cloud load balancing, you can serve content as close as possible to your users. We can also mention this point that cloud load balancing is a fully distributed, software-defined managed service. It is not hardware-based, so you don't have to manage a physical load balancing infrastructure. So this was about load balancing. Our next question is, what is Cloud DNS? Well, Cloud DNS is a high-performance, resilient global domain name system service that publishes your domain name to the global DNS in a cost-effective way. Now, DNS is nothing but a directory of easily readable domain names that translate website names into numerical IP addresses which are used by computers to communicate with each other. For example, when you type a URL in your browser, DNS converts the URL into an IP address of a web server associated with that name. Like www.example.com is translated to the IP address of 72.220.193.173. Now I guess you have some idea about DNS. Now let us move on to the next question. Now next question is a scenario-based question. How can I connect my existing network to Google Cloud resources? You can answer this by saying Google provides 4 options to do this. The first one is through Cloud Interconnect, the second one is through Cloud VPN, the third is through direct peering, and the fourth one is through carrier peering. Now Cloud Interconnect enables you to connect your existing network to a VPC network through a highly available low latency connection. You can choose Cloud VPN, which will enable you to connect your existing network to a VPC network through an IPsec connection. Next, direct peering enables you to exchange internet traffic between a business network and Google at one of Google's broad-reaching edge network locations. And the fourth option is carrier peering, which allows you to connect your infrastructure to Google's network edge through highly available low latency connection which is provided by the service providers. Moving on to our next question, describe some of the security aspects that the cloud offers. Well, some of the important security aspects that the cloud offers is access control. It offers the control to the admin to decide the access of other users who are entering the cloud ecosystem. The next security aspect is identity management. This provides the authorization for the application services. And third is authorization and authentication. This security feature lets only the authenticated and authorized users to access certain applications and data. These were some of the important security aspects that the cloud offers. Moving on to our next question, list some of the GCP security services. GCP security services include Cloud Security Command Center, Cloud Armor, and Cloud Identity. Cloud Security Command Center is the tools that let users view and monitor the cloud assets and provides important security support functions like storage system scanning, vulnerability detection, and access permission reviews. Next, Cloud Armor is a DDoS and application defense system. It is built using the same major technology and infrastructure that Google relies on to protect its services, including Google Search, Gmail, and also YouTube. The third security service is Cloud Identity. Now, this service controls and defines the users and groups and the GCP resources they have access to. Now, these were some of the GCP security services. So now let us move on to our last set of questions on other GCP services. Now these other GCP services would include big data, Internet of Things, and Google Cloud Artificial Intelligence. So the first question in this section is, what is Google BigQuery? BigQuery is a Google Cloud's fully managed, petabyte scale and cost-effective analytics data warehouse that lets you run analytics over vast amount of data in near real time. You can say Google BigQuery is a replacement of the hardware setup for the traditional data warehouse. You can also mention how the BigQuery organizes its data. We can also mention the BigQuery organizes the data table into units that are known as datasets. Moving on to our next question, what are the big data services which are offered by Google Cloud Platform? Well, some of the services are Google Cloud BigQuery, Google Cloud Dataflow, Google Cloud Dataproc, Google Cloud Pub or Sub, Google Cloud Composer, Google Cloud Big Data, and Google Cloud Data Catalog. Moving on to our next question, what is Google Cloud Dataflow? Well, this is one of the important GCP's big data service. You can answer this question by saying Google Database is a managed service for executing a wide range of data processing patterns. It provides a managed service and a set of SDKs that you can use to perform batch and streaming data processing tasks. It works well for high volume computation, especially when the processing task can clearly and easily be divided into parallel workloads. Next, moving on to our next question, what is Cloud AutoML? This is one of GCP's machine learning service. Well, Cloud AutoML is a service that enables developer with limited machine learning and programming expertise to train high quality models specific. You can use AutoML to build on Google's machine learning capabilities to create your own custom machine learning models that are tailored to your business needs, and then integrate those models into your application or website or both. So this was about Cloud Auto ML. Let us move on to the next question. Our next question is, explain Google Cloud AI Platform. Well, AI Platform is a suite of services on Google Cloud which are specifically targeted at building, deploying, and managing machine learning models in the cloud. AI Platform provides the services you need to train and evaluate your training model in the cloud. It is integrated with several easy-to-use tools like BigQuery and data labeling service to help you build and run your own machine learning applications quickly. You can store and manage the large amount of data with BigQuery and then prepare or label this data for model training using data labeling service. So this was about Google Cloud AI Platform. Now our next question is, what is Cloud IoT Core? Well, Cloud IoT Core is a fully managed service that allows you to easily and securely connect, manage, and store data for millions of devices which are spread globally. It provides a complete solution for collecting, processing, analyzing, and visualizing IoT data in real time to support improved operational efficiency. So this was about Cloud IoT Core. Now let us see the next question. Our next question is, what service would you use for text analytics in Google Cloud Platform? So the service which is used for text analytics in Google Cloud Platform is Cloud Natural Language. Natural Language AI enables you to analyze text and also integrate it with your document storage on cloud storage. You can extract information about people, places, and events and have a better understanding about social media sentiments and customer conversations. So these were some of the important and frequently asked GCP questions. So now let us move on to the next topic and see what are the skills required to become a cloud engineer. So a cloud engineer is an IT professional responsible for performing technological responsibility concerning cloud computing. They are mainly responsible for maintenance and support, management, planning and designing of an infrastructure on the cloud platform. So now talking about the skills required to become a cloud service provider, the first skill is having knowledge about cloud service provider. So if you're thinking of taking the cloud computing career path, spend some time familiarizing yourself with at least one of the cloud service provider. The top 3 cloud service providers are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Now if you want to see a comparison between these 3 cloud service providers, I will leave a link to that video in the description box below. Now these cloud service providers offer end-to-end services like compute, storage, databases, ML, migration, and many more. It includes almost everything that is related to cloud computing, and this makes it one of the important cloud engineer skills. The next skill is programming skill. This is one of the important cloud engineer skills. Proficiency in programming language is essential for scaling web application. Some of the programming language you should be familiar with are PHP, Java, .NET, SQL, Python, and Ruby. You can learn all of these languages with the help of blogs, online videos, or either offline or online classes, but the most important of all is hands-on practice. Now talking about the third skill required to become a cloud engineer is having knowledge about the important cloud service domains. Now this cloud service domain would include compute, which involves virtualization and serverless computing. Next is cloud storage, which deals with data and information which is stored in the cloud. After that, we have networking and security. Now, a cloud engineer should be familiar with the basic cloud networking concepts and network security, which includes encryption, authorization, and different protocols. Moving on to our next skill, that is web services and APIs. Cloud architects are heavily based on APIs and web services because web services provides developers with method of integrating web application over the internet. XML, SOAP, WSDL, and UDDI open standards are used to tag data, transfer data, describe and list services available. Plus, you also need APIs to get the required integration done. Now, having experience of working on websites and related knowledge would help you have a strong core in developing cloud architectures. The next skill is Linux. Now, Linux is an open source operating system that can be customized to meet business needs. Linux is being increasingly adopted by many cloud service providers because of its various benefits. So as a cloud engineer, you should be able to architect, administer, and maintain Linux-based servers. Talking about the next skill required to become a cloud engineer, it is DevOps. Now DevOps brings in the development and operational approach in one place. thus easing their work dependencies and filling in the gap between the two teams. DevOps approach is being increasingly adopted by many top companies and gets really well with most of the cloud service providers. Now, these were some of the important skills required to become a cloud engineer. And with this, we have come to the end of our session. I hope it was helpful. Happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!